Now the other part, the climatology, oceanography and the biodiversity part is in this particular short 2. What are the conditions of the atmosphere? Let us say that it's raining, whether it is very bright sunshine is there, or it is cloudy. So those conditions, which are very short term, these are known as weather. You know what solar radiation is? That is received on a unit area of a surface facing the sun. Because of that, it was unbearable for me, or for you for that matter, and you jumped from the chair. What did you observe here? Do not confuse it with the phenomena of condensation, because when we talk about rain, clouds and all, it is basically the condensation that has taken place, and then those phenomena take place. So these 4-5 statements which I have written here has been asked in the PCS itself. Till here the gradient is less. After that, when you move ahead, the gradient will rise because the slope is steep here. I'm telling you the concepts that we are doing, those are basic concepts which are indirectly mentioned in the NCERT, and I've expanded them. Hello aspirants, I guess you're doing really very well. A very good morning, good afternoon or good night, depending upon the time you are watching this lecture. The important thing is, the more important announcement which I want to say is, we are now back with the part 2 of the physical geography series. Now this is a one-shot video, please remember. You have done the geomorphology section. Now the other part, the climatology, oceanography and the biodiversity part is in this particular short 2. So please make sure you see the video completely, and if you have missed something, note it down, revise it again and again. It is very critical for your preliminary as well as the mains examination. So this is the part 2 of the complete physical geography. Please remember, you must be asking, or repeatedly you ask, so where can I find the notes? Please remember, please check the description link. In that description link, the link is given, you need to enroll. It is completely free of cost, and through that link you can basically download the notes. So to download the notes for free, please click on the description link below. Below the video is a description link, and on description link click, there is a link that you can register or enroll for free, and then you can get the notes for free. So don't need to worry about that. So please enroll yourself. This is a free batch. So next is, please remember, all those who want to buy the paid batches, many of them are very interested. So please remember, you have the Pinnacle 2027 batch. This is a 2-year comprehensive program completely in English for prelims, mains and the interview. So again, please there's a link in the description box that is given. Please click on it and you can enroll on that. So now, leaving these things apart, let us begin with the part 2 of the physical geography one-shot video. Let's begin. In the first lecture, we had already talked a little bit about the atmosphere, how it was evolved. We'll be dealing with that in this chapter also. But before we begin with the topic of atmosphere, let us firstly understand what is weather and climate. Now let us assume you are enjoying yourself in your room and it is bright sunshine. And after 15-20 minutes, you see there is heavy rainfall. Do you realize there has been a sudden change in the conditions which you are experiencing right now? It was bright sunshine and after that rainfall. Now, similarly, after a few hours, you again see bright sunshine. So what do you call that? Is it weather? Is it climate? Something very confusing also for many. Please remember, when we talk about weather, these are short-term state of the atmosphere at a particular place and time. So at any particular place, what are the conditions of the atmosphere? Let us say that it's raining, whether it is very bright sunshine is there, or it is cloudy. So those conditions, which are very short term, these are known as weather. Now, it includes like humidity, whether the humidity is high or low, whether it is raining or not raining, whether it is bright sunshine or not, or for that matter, winds are blowing or not. So these are very short term duration things. But overall, when you realize that, when we say that there is monsoon type of climate, now, monsoon type of climate is a very broad word. When we talk about monsoon climate, we talk about reversal of winds, which we'll be studying later on in the series, where you see during the summertime, you see the monsoons coming and the winds are basically flowing from the Indian Ocean side. And on the other hand, during the winter time, there is reversal. So overall, we call it, or Indian region or Indian subcontinent region, as a monsoon type. It is a broad categorization, long duration processes are involved. So that is why climate is a long-term average pattern of weather conditions over a large region. Weather usually studied for 30 years or more. That is why, do you realize, when we talk about the concept climate change, why climate? Because overall, when we talk about a region, there is a certain set of broad generalization, what type of climate would be experienced in that region during winters, summers, or whatever be the case. If there are certain changes in that, that is why we use the word climate change. So climate is basically referring to a word which is a long-term study of weather itself over a larger region, over let us say more than 30 years also. And based on that, we derive that this is the weather. Now, this is the climate. Sorry, this is the climate. But on the other hand, if you see weather is basically talking about short-term, day-to-day changes taking place in a region. That is what is weather. So weather and climate. Now, if I want to differentiate between both of them, first you can quickly copy it if you want. Okay. Now, pause the video, copy it. Now, let us see weather and climate. What are the differences? See, what we've already studied the definition. Having studied the definition, you should be aware of what are the differences. Now, let us say this is weather, this is climate. Now, I told you duration, it is short term, day-to-day changes that are taking place. This is long term, on an average 30 plus year is taken. That in 30 years, what are the general weather conditions present day-to-day basis in a particular region, and based on that, you decipher the climate of a particular region. Area, it is generally confined to small areas when we talk about, because weather are local level conditions for a shorter duration. So that is why small region, this is larger region. Now weather is something that changes very rapidly, quickly. As I said, that it might be very sunny with bright sunshine, but after a few years, it might rain very heavily. So changes very rapidly, but this is again changes slowly. We don't say that it does not change. Why? That is why the concept of climate change comes. Because overall, if you realize, let us assume there is a region which has an average temperature of, let us say, 30 degrees Celsius. But due to climate change, you realize after 50-60 years, the average temperature has gone to 35 degrees Celsius. So it is changing slowly, but changing. So that is why changes slowly. Now, if I talk about which is the branch which studies these things. So when we talk about weather, that is dealing with day-to-day activities or changes in the atmospheric conditions, we're talking about meteorology. Right? That is why we talk about meteorological department, because it has to take care of every little condition changes that is taking place in India and around them. Overall, when we talk about climate, the subject that deals with it is climatology, right? Climatology. Now, you can quickly note down whatever is written on the board. Take a screenshot also, right? Okay. We have studied what weather is, what climate is. So these two concepts are absolutely clear in your heads, hopefully. Now, following this pattern, let us come to the topic that we have to study, that is atmosphere. Now, atmosphere is one topic that you have been studying since you were in school days, something very interesting, something that talks about the various gases, the matters, particulate matters, and for that matter, what all gases that are surrounding this earth. And it is always very interesting to study also. That is why, because it talks about various layers. How come these layers are formed? How come these density of the layers keep on changing? Why there are certain, let us say, shooting stars seen in certain layers? Where is the International Space Station located? These are certain types of things that generally create curiosity. Along with it, these are the questions that have been asked also in the examinations repeatedly, in the prelims examination as well as the mains examination. So let us have a look at them. Atmosphere. So whenever I talk about atmosphere, you know that atmosphere is a mixture of gases, water vapor, and dust particles surrounding the earth, right? It is a mixture. Now, gases are present, water vapor are present, then you see the dust particles are present. This is the basic understanding which you read in your NCERTs also. Why I have very specifically mentioned here? Because this is the definition in NCERT. And this is the simplest definition also that you can come across. Now, the question arises, sir, if these gases are there surrounding the Earth's surface, how they are there basically? It is because of the gravitational force of the Earth. So, it is held by the Earth's gravitational force and rotates along with the Earth because it is an integral part of the Earth's mass itself. The air is an integral part of the Earth's mass. So, that is why it is an air is integral part of the Earth's mass. This statement is very, very important. Why? Why? Because this has been asked in the preliminary examination as one of the statements, right? As a statement. So you should be very well aware of this statement also. Now, 99% of the total mass of the atmosphere is confined to the height of 32 kilometers from the Earth's surface. Now, let us say you are right now on the Earth's surface. If you go 32 kilometers, 99% of the mass. Why? Because as you go higher and higher, the density keeps on decreasing. So even though you might reach great heights, density will be so less. So what will happen? That is why we say the mass, the lower layers are denser in nature. So that is why they contribute more to the mass. So that is why the mass or the total mass of this atmosphere, 99% is confined to the 32 kilometers from the surface of the earth. This should be very clear in your minds. Absolutely clear, right? Okay. Now comes, having studied what atmosphere is, brief idea, brief details. Now let's see evolution of atmosphere. Remember this, we have studied this in chapter 1 also, where we had talked little bit details about the creation of lithosphere, hydrosphere and atmosphere. We are again repeating it because it is relevant here. Initially, when the earth was formed, it is generally assumed that it had hydrogen and helium, that is known as primordial atmosphere, before the modification took place. So initially hydrogen and helium were the main components of the earth's atmosphere. Later on we see that solar wind, because of the solar winds, this basically, there was a loss of the original atmosphere that was composed of hydrogen and helium. So these are the representation of what? These are solar winds. Let's mark it also. This is what? Solar winds. So the loss of primordial, primordial means original, old. So originally it was hydrogen and helium, and later on because of the solar winds, this hydrogen and helium basically got lost because of the solar winds. Now, next stage that happens is degassing. Now, initially we realized that, let us assume that the earth was a hot bowl. Slowly it started cooling. Now what happened is, when it started cooling, a lot of gases were released from the interior, which were like water vapor, other gases being nitrogen, carbon dioxide, methane, ammonia, and little bit of free oxygen. Now, when these gases were released, it replaced now, because these other initial primordial atmosphere, which was of hydrogen and helium, was basically gone away with the winds. So now these things came up and these added to the atmosphere initially. Now these composed of again water vapors, nitrogen, methane, then you have carbon dioxide, ammonia and free oxygen. Now please understand, this will later be modified. Now this is a process in which a lot of components were added to the atmosphere. Now this is an evolving process, right? Now this process of cooling of the earth and the release of the gases from the interior is basically referred to as a term degassing. So you should always remember this. Now last stage, that is a stage 4. Many people have in the previous lectures had questions, sir, in the NCERT only 3 stages are mentioned. Why have you mentioned 4 stages? Please remember, NCERT mentions this also as an initial condition, which though not necessarily mentioned as a stage, is taken as a stage in this lecture. So this is also a stage. That is why I have taken 4 stages. Otherwise, it is absolutely correct. There is nothing wrong in that. So it is basically in alignment with what is mentioned in the NCERT also. Clear? Okay. Now, 4th stage is, please understand, modified by photosynthesis. Now you realize that as Earth started cooling, there were water vapors were released. Obviously, you will realize that cloud formation will take place. So because of that, rainwater fall started, again rain started, and it got collected into the depressions forming oceans. Now you know that very well. When you see Earth from a distant view, you basically see it in this shape, right? Geoid shape, which is like complete curves are here. But on the other hand, if you remove the oceans, you will possibly imagine that Earth is something like this. It is basically the presence of the water on the surface of the Earth that basically gives it a proper shape. So this is what? Water. Now what happens is, as rainwater is following, there were depressions there which got filled. And as they got filled, they were known as oceans or even seas. That is why this is saying that rainwater falling got collected in the depressions forming oceans. Oceans formed within 500 million years from the formation of the Earth. Now, when the Earth formed, after 500 million years, you realize that this process took place and the process of formation of the oceans took place. Now, 3,800 million years ago, life began to evolve. And now these are because of the complex reactions or amino acidic reaction that took place, that life basically evolved according to the scientist. Now, initially life was confined to the oceans. Now, initially, whatever life forms were there, they were confined to the oceans initially, right? Now what happened is ocean began to have contribution of oxygen through the photosynthesis. Now those plant-based life, whichever it was, it started again the formation of photosynthesis, and then oxygen became a component of the ocean. So ocean became oxygen rich also, and slowly then oxygen started releasing also. Now eventually 200 million years ago, oxygen began to flood the atmosphere. Now, because of that, oxygen being released, that basically became a part of the atmosphere also. Now, what is going on is, this basically led to the modification of the atmosphere, where oxygen also became a very, very important ingredient, which also started supporting life. Clear? So now this is the process through which the evolution of the atmosphere took place. Now, the topic which basically talks about is the composition and structure of atmosphere. This is the evolution. Now let us go to the concept of composition of the atmosphere. Composition, what it comprises, what are the ingredients at present. So when we talk about it, it is not simply the gases. There are a lot of other components of particulate matter, dust particles are also present. So we'll be considering those aspects also, again in alignment with the NCERT, and certain other facts may be added. The atmosphere is composed of gases, water vapor and dust particles. This is a direct line that I picked up from the NCERT. Why? Because few years ago, there was a simple question that was asked that it is composed of gases, dust particles, water vapor. So all the three were right. So this statement, that is why, becomes important. Now, the important thing is, it is not so simple also. If I take little bit more standard form, let us say more what is present in other books also, what UPSC is now taking you to is, there are certain permanent gases, there are certain variable gases, and there is particulate matter. Again, dust particles, aerosols, different kind of matters that is present. So these are the general compositions which we see. Now this is simply a statement that is written completely correct, not wrong. But this is, when we go in more detail, we'll be realizing all these things. Now we have to study all these things so that we get to know better about the composition of the atmosphere. Now, when I talk about the permanent gases, this is somewhat approximate percentage in which the gases are present in the atmosphere. We'll be telling to which layer also as we move ahead in the class, because there is a concept of homosphere and hydrosphere also. Right now, simply understand that this is a roughly a percentage which is almost similar, but obviously due to pollution, due to the anthropogenic activities, the percentage of, let us say, carbon dioxide might increase, which is leading to a lot of problems. But overall, this is the percentage. Now, if you will see here, nitrogen 78.05%, close to 78%, oxygen close to 21%, argon 0.93%, carbon dioxide 0.036%, neon 0.002%, krypton 0.001%, helium 0.00008%, xenon 0.00009%, hydrogen 0.0005%. Now, the problem that arises is, how can we remember this, right? See, certain people create their own mnemonics to understand it. Some people try to remember the facts and figures also, but then remember what happens is, by the end of the syllabus, when you have studied a lot of subjects, it is quite possible that you might forget the percentages also. Initially, when you are studying a subject, at that particular moment, you might remember it. After 1 month or 2 months, when I ask you, possibly what is the percentage, you can tell me about nitrogen, oxygen, possibly argon. After that, you will not remember the order also. So leave along the percentages. This question is very important. Why? Almost every year in the various PCS examination, the order is asked. Now the question that arises is, it is not necessary that they might ask you the initial order. They might take up argon, neon, xenon. In that particular case, you will be in a state which you will not be able to remember. So knowing this order is important. Now, I created a mnemonic while I was studying, and which was basically helpful for me also. See here, naughty old aunt. Now, whether you want to put naughty old aunt or auntie, it is up to you. Naughty old aunt cooks nice kheer, hot, extra hot. So you can imagine there is a old aunt who is cooking kheer which is hot. No, it is extra hot. So how do you remember? Naughty old aunt cooks nice kheer, hot, extra hot. Now over here, nitrogen, oxygen, argon, carbon dioxide, neon, krypton, helium, xenon, and hydrogen. So remember, hydrogen is lesser than helium. Clear? So this is something that you should always remember and you should understand. This is a mnemonic, possibly you will be able to remember the order well. Just read it twice and thrice and you will remember the order. Clear? The only thing where you can make mistake is possibly because H and H are mentioned. So please remember, helium is more than hydrogen as a percentage component. So that is why this is, if you remember this, you will be able to solve provided you remember the mnemonic. Clear? Now, this is a permanent gases. Now, when we talk about the variable gases, see, again, different books try to categorize different things. So we are broadly generalizing. We have put over here water vapor, we have put here methane, and we have put here ozone. Clear? Now see, under them, if you realize, water vapor again is a very important ingredient. Many people get confused. That's a vapor is present. Please remember, we are not talking about boiling of water. Boiling of water is taking at 100 degrees Celsius, yes. But water vapor formation is taking place under normal temperature also. Remember that. That is what is contributing to the water vapor in the atmosphere. There's a difference between evaporation and the difference between boiling. So boiling takes place at 100 degrees Celsius, but evaporation, which is adding water to the atmosphere, is taking place under normal temperatures also. That is why if you realize, this is an invisible component of the atmosphere, but very important and intricate when you talk about concept of climate change and greenhouse effects and all. It's very important ingredient here. It is also known as vapor in the gaseous state, and it is an invisible component. It is an invisible component of the atmosphere. Clear? That is why its concentration in the air varies depending upon the location. Now, if you realize, in the warm and the tropic region, if you realize, it is 4% by volume. Now why? Because there is more evaporation taking place during that time. So obviously the percentage of water vapor in the warm and the tropic region is going to be more. Whereas if you go to the colder regions, obviously that is percentage is going to be less. So desert and polar regions have lesser water content in the atmosphere. That is why it is approximately 1% by volume of the total. So more in the warm and the tropic regions and less in the desert and the polar regions. So that means there is variation that is present here, right? In the polar regions as well as in the warm tropic region. Now water vapor decreases from equator towards the poles, as you have already seen. Warm tropic region is in what? Close to the equatorial region. As you move towards the poles, the water vapor content will decrease. So now this is again question which has been asked in your preliminary examination as statement, along with the other statements. So you should be very clear about these questions. Clear? Okay. Now it decreases with altitude. Obviously, if you go higher, basically if you realize, when we will be doing the structure, you see the topography in the troposphere, the lowest layer, that is basically talks about the weather activity. So over here you will be seeing the water vapor content. But as you move up, the amount of water vapor that is present will definitely decrease, right? Now, it observes the part of the insolation from the sun and preserves the Earth's radiated heat. Now, incoming solar radiation is absorbed by the water vapor also, and it preserves the Earth's radiated heat. So, it acts like a blanket in order to maintain the temperature. Remember this. This is again a very important activity. It is a natural blanket. It prevents the Earth from becoming too hot or becoming too cold. Clear? Please note it down. Okay, now having studied this, let us move to the next part, methane. Now methane is something that is repeatedly asked in your papers also, like what are the sources of methane, because it is again a very important aspect with respect to the atmosphere. Now if you see, it is present in the atmosphere through the natural and human activities which observe specific radiations which basically act as regulating the atmosphere temperature. If the methane content increases, it is basically will be contributing to global warming also to a great extent. And that is why it is very problematic also. UPSC can ask you as a direct question which I have stated right now, but on the other hand, it can ask you the sources of methane. Now, there are natural sources also, and there are human sources also. Like geological sources like volcanic eruptions, from methane also, from ruminant animals also, termites also, they are also associated with production of methane. These are natural phenomena. This is something that you cannot control. But from the perspective of human or anthropogenic causes, you realize that there are agricultural activities, energy production, biomass burning, wastewater treatment, landfills, natural gas distribution. Now, these things are also contributing to methane. Now, overall, these activities tend to impact the percentage of methane in the atmosphere, which again creates a lot of problem with respect to the global warming also. Clear? So, this is methane. Next is ozone. Now, please understand, ozone basically is O3. It is a 3-atom isotope of oxygen. Now, faintly it is blue in color. It is little irritating gas with pungent odor. Little bit pungent odor. It is faintly blue in color. Now, it filters the incoming shortwave solar radiation. You know that very well, that ozone is a protecting layer for us. Because if you realize the UV radiation that are coming, right, UV radiation that are coming, possibly if come directly, might cause a lot of cancer on the skin or related issues also. This ozone layer acts as a protective layer. So that is why if you realize, it filters the incoming solar radiation and the harmful UV rays. So it is generally present between 10 to 50 kilometers above the Earth's surface. So very, very important again. Its formation of the process again takes place on a continuous basis. It is not that ozone is present, it is present. It is again chemical reaction that are taking place which leads to its formation. So this layer is generally present between 10 to 50 kilometers above the surface of the Earth. We'll be dealing with that when we'll be seeing the structure of the atmosphere. Okay. Now, there are particulate matter. Now, something particulate matter again becomes very important. This question has been asked repeatedly. A lot of dust particles, soot particles and all are also present in the atmosphere. Now see, atmosphere has sufficient capacity to keep small solid particles which may originate from the different sources. Now, if they are even lighter than the air, possibly they can be pulled up or they can be displaced upward also. There's something very common phenomena. That is why these particles are present. Possibly you will realize that in the Delhi NCR region, you realize that the particulate matters that are present in the atmosphere are so harmful for you. That is why please remember, their increase in the number or composition within the atmosphere is a very, very harmful phenomena also. So over here, it can be through the sea salts, fine soil particles, smoke, soot, again a very important aspect in today's phenomena, ash, pollen grains, dust, disintegrated particles of the meteors. Now these all things are present in the atmosphere. Now, the dust particles are generally concentrated in the lower layers of the atmosphere. High concentration of dust particles are generally seen in the subtropical and the temperate region. Now, these things should be remembered also. Why? Because these are directly mentioned in the NCERT and they become very important from the MCQ purposes or point of view. Now, please remember these particulate matters again is a very important topic in today's time because UPSC can repeatedly ask questions because it is directly mentioned in the NCERT. And it is important from the perspective because it has been in the news also. So you should be very well aware when you are making your notes from these. Please note it down properly and revise it. Clear? Okay. Now comes the structure of the atmosphere. Now please understand, when I talk about structure, structure basically talks about the arrangement of the atmosphere. So we realize that based on various parameters like density and temperature, there are various layers into which the atmosphere is basically divided. Now, initially, please understand, let us see how you make the graph. See, this is basically representing 0 degrees, this is 20 degrees, this is minus 20, minus 40, minus 60, minus 80, minus 100. That means as you move towards this side, it is basically a representation of fall in temperature, right? This basically refers to the height. This is 0 means the Earth's surface. As you move up, this is 10 kilometers, 50 kilometers, 80 kilometers, 400 kilometers, and so on and so forth. These are layers. I will be marking it now. Please understand, this green is basically representing or showing what are the changes in the temperature as you move upwards or there is increase in height. So if you realize if you move from this point to this, that means there is fall in temperature, there is some constant, then increase in temperature, some constant, then decrease in temperature, some constant, then increase in temperature. Now, these are basic guidelines that you should understand. Now coming to the actual concept is, see, this lowermost layer over here you can see is a troposphere. It ends over here, this line, red line basically refers to tropopause. That means pause is there with respect to the changes in temperature. After that comes After that comes is stratosphere. This layer is present here. Then stratopause. Then you have above that a layer known as mesosphere. Then you have the mesopause. Then there is thermosphere, and even you have the thermopause also, though many books do not mention it. But yes, you can write it here also. It can be mentioned also. Thermopause. Some books do not mention. Even the NCERT does not mention it categorically, but standardly in various books it is present. Above that is an exosphere layer, which is very less known because again it basically merges with the emptiness of the space. So we very less know about it, but we know, okay, this is the layer, last layer, which can be called as the exosphere. Among these, you realize there is a layer of ionosphere, which is basically dealing with the ionization of gas, which we will be understanding, which is very important for the radio communication, which I'll be telling you while we studying the structure. Now, this is a basic hand-drawn diagram, which is very important because if you know this question has been asked in the mains examinations also. This has been asked in the preliminary examinations repeatedly, whether temperature decreases, increases, what are the reasons, what are the layers, what are the temperature, what is the, let us say, the height, and how the changes take place. The favorite questions of the examiners, particularly for the PCS as well as the UPSC examination. And remember this concept that this diagram should be learnt by you by heart. You should make it many times, multiple times, only then you'll be remembering it. Clear? Just draw this diagram as a master diagram. So this is what tropopause, stratopause, mesopause, thermopause, troposphere, stratosphere, mesosphere, thermosphere, exosphere. This is the 0, 10, 50, 80, 400, and this is the decrease in temperature. So this graph is basically, this line is representing as you move upward, there is decrease in temperature, increase, decrease, increase. Clear? Now let's move ahead. One by one, let us study. Now what we are studying here is, see here, we are studying this particular part. Right? Troposphere. This is a troposphere and the upper part is a tropopause. Now see here. It is a lowermost layer of the atmosphere. As you have already seen here, this is the lowermost layer. This is the surface. This is the lowermost layer of the atmosphere because there are so many layers here. So this is the lowermost layer. Now average height is 13 kilometers. Now if you see the height, maximum height which it reaches is 13 kilometers on an average. Now this varies basically. It is near the pole, it is 8 kilometers, and near the equator, it is 18 kilometers. The reason is, please understand, close to the equatorial region, there are a lot of convectional currents and a lot of cloud formations take place. So that is why it basically pushes the tropopause layer a little upward. That is why you realize that close to the poles, it is not so tall, not the height is not so much because it is simply 8 kilometers. Whereas if you see close to the equator, it is 18 kilometers. On an average, if you see, it is 13 kilometers as average taken place, as mentioned in the NCERT also. Now, all the weather or climatic phenomena that you talk about basically take place in this layer. Now, many will be saying, sir, does that mean that what the clouds we study, majority of them are present here? I would say yes. But if the question comes that there are no clouds present in the above layer, that will be wrong. There are stratospheric clouds also, right? There are stratospheric clouds also. But when we talk about weather phenomena, it is basically talking about this layer where it is confined. So all weather climatic changes take place in this layer. Clouds, majority of the clouds are present here. Some clouds might be present in the stratosphere. This, which we'll be studying in the chapter of clouds later on. Temperature in this layer decreases as you move up. As your height or altitude increases, the temperature will decrease. We will be studying the phenomena like normal lapse rate and all later on. But simple phenomena right now you can understand is in the troposphere layer, as you move ahead, there is a fall of 6.5 degrees Celsius per 1000 meters. It is also known as normal lapse rate. We'll be studying later on. But as you move up, in altitude increases in this particular layer, this is a fall in the temperature. Clear? So now this is the major characteristics that you should know. There is a layer, those are tropopause. Now the zone separating the troposphere from the stratosphere is the tropopause. Why? Because this is a small layer about 1.5 kilometers. which basically there is no specific change in the temperature. So that means what phenomena of decrease in temperature was taking place stops here. Pause is here, that is why tropopause. And it is separating the troposphere from stratosphere, that is the tropopause word is mentioned here, right? Tropopause. This is the tropopause, right? Now, air temperature at the tropopause is about 80 degrees Celsius over the equator and 45 degrees Celsius. That means, as we have already known that, see here, let us understand. Supposingly, this is the surface of the earth, right? Let us take this for the timing, that this is, let us say, 0 degree, that is equator. This is supposingly, this is basically poles. Let us say North Pole for the timing. Same thing happens with the South Pole also. Now, if I'm talking about ideally, I had mentioned that this is the, let us say, ideally, this is what? Ideally, this is what the tropopause, right? Tropopause means that the troposphere layer ends. There is this zone of 1.5 kilometers and then the stratosphere begins. So there is no change in the temperature as you move ahead in this layer. That is a tropopause. Similarly, other pauses will also come later on in the other layers. So ideally, this is tropopause. If you see over here, right now I told you that when I talk about tropopause, average height is, let us say, 13 kilometers. Let us say just above the troposphere and then tropopause begins. So over here, ideally you can put it as 13 kilometers above the surface of the earth. Clear? But in reality, if you realize, this is not the truth. Why? See here. The reality is, see, this is the actual tropopause, because where the troposphere layer ends. Now the thing that will arise is, you have right now read over here that it is 8 kilometers near the poles and 18 kilometers near the equator. Now see, 8 kilometers near the poles and 18 kilometers near the equator. Now the question will arise, why? Right? I will tell you why, because why I have to explain this diagram is because only then you will understand this phenomena. See here. First thing is, average is 13 kilometers, but in reality, if you see, because 13 is the average, near the poles it is 8 kilometers and near the equator it is 18 kilometers. If you see close to the equatorial region, there is a lot of convective activities take place. Convection, that means a lot of, let us say, because of low pressure region, a lot of air is basically pushed upward. That is why you realize a lot of thunderstorm activities taking place, a lot of cumulonimbus clouds, huge clouds are formed. We will be studying these clouds. That is why I'm not using those specific words also. So you realize over here, a lot of convective activities takes place here. A lot of convective activities take place. Now this basically leads to the tropopause being little upward. Along with it, because the temperature is relatively higher, so there is expansion also. Over here, no such activities take place, so it is relatively lower. This is a region. Now, if you realize one thing, we know something that as you move upward, there is decrease in temperature. Now, though it is above the equator, but the height of the tropopause is 18 kilometers here. It is 18 kilometers here. Over here it is 8 kilometers. So if supposingly I am at the level of the tropopause, though I am at the equator, I am at a greater height. The normal lapse rate, which I said, decrease in 6.5 degrees Celsius per 1000 meter will also be applicable here and here. So if I say 18 kilometers, you will realize it is minus 80 degrees Celsius here and minus 45 degrees Celsius here. Clear? Minus 45 degrees Celsius here. So please remember, you might get confused that they will ask you that above the poles at the troposphere, there is minus 80 degrees Celsius and at the equator it is minus 45. You will say, yes, it is cold region. Yes, there will be minus 45. No. This is a reality. So you should understand this phenomena, what it means. I've explained you both the things, why this is taller over here, the height is more, and why the temperature is less, because the height is more, that is why the temperature is going to be lesser because of the normal lapse rate, where there is decrease in temperature. The rate is 6.5 degrees Celsius per 1000 meters. Clear? This is the phenomena that you should understand. I hope it is clear to everybody. Okay. Now, another thing here, temperature is constant here in the tropopause, because this is a transitionally layer, because there is no change in temperature within this layer, which is hardly 1.5 kilometers thickness. And that is why this is known as tropopause. This is troposphere and tropopause, which you should be aware of. Now, let's move ahead. We have studied troposphere, we have studied tropopause. Above that is the stratosphere. And again, the end of it basically marks the stratopause. Right? Now, let us see the details. It is found above the tropopause and extends up to a height of 50 kilometers. So, close to the 50 kilometers, because please understand, the end of stratosphere or any layer, the troposphere ends here, the tropopause begins. So, that means the end of troposphere, whatever the height is given, is basically the start of the tropopause. Similarly, when I talk about stratosphere, it ends at 50. So, that means this is the region where stratopause will be found. Yes. So, that is why you realize it is found above the troposphere and extends up to a height of 50 kilometers. Clear? Now, this layer contains the ozone layer. Now, ozone layer is not simply that is a very specific defined layer. Now, because ozone formation is a dynamic process that takes place where chemical reactions take place. So, it is between the 15 to 30 kilometer, between the 15 to 30 kilometer height above the surface of the earth, which you generally find the ozone layer. Now, the ozone layer is a protective layer which basically prevents the harmful UV radiations from coming and causing problems to us. So that is why this is how nature basically has been working to protect us also. Now, this layer absorbs the UV rays. Now, please understand, as I had mentioned, a question may be asked, though we'll be doing the clouds when we'll be doing in the coming chapters, that as I said, weather and climatic phenomena are present confined to the troposphere layer. Yes, it is correct, but it does not mean that the clouds are not present in other layers. The majority of the clouds are present in your the layers of your troposphere, but there are certain clouds like cirrus clouds are present in the stratosphere also. So there are certain feeble winds also moving here. Increase in temperature with height. Now please understand, now the thing is that as you move upward, there is increase in temperature. If you see here, the reason is because the ozone layer being present, chemical reaction being taking place, UV radiation being observed here, leads to increase in the temperature in this particular layer. The major reason for that. So that is why you realize there is increase in temperature over here. Clear? So stratopause basically separates the stratosphere from the mesosphere. So that means this is a stratopause. Again, there is no change in temperature in this particular thin layer. And after that, the mesosphere comes. So stratopause basically separates the stratosphere from the mesosphere, right? Okay. Next comes mesosphere. Now this is a mesosphere. Again, mesopause will separate thermosphere from mesosphere, similar thing. So see here, it lies above the stratosphere and extends up to a height of 80 kilometers, which I have mentioned here. So that means, please remember, if you have done this diagram well, you will be able to answer any type of query that comes or question comes in your examination, because whatever is written over here is basically an explanation of what is drawn here. Clear? So mesosphere, and then you have the mesopause and the thermosphere, right? So up to the 80 kilometer mark, if you see here, it is the 80 kilometer mark, it is still here. Now the temperature decreases with height, again a natural phenomena where as you're going ahead, the temperature is decreasing here. At the height of 80 kilometers, the temperature can fall to minus 100 degrees Celsius also. In the examination, you can be asked which of the layer is generally considered the coldest layer, right? Which is considered the coldest layer. Sometimes it is, sometimes over here you will be coming across this. So within the atmosphere, you will be mentioning mesosphere, generally considered, right? Many meteoroids disintegrate and the shooting stars are generally seen over here. And mesopause basically separates it from the thermosphere. Now this is some details that you should be well aware of, and something that you should note it down also. Quickly note it down. Next comes thermosphere. After the mesopause, you have the thermosphere. Please remember, as I've mentioned you, many books do not mention the concept of thermopause, but again, certain books have mentioned that the end of thermosphere is marked by the thermopause. So you can mention, because the concept is because the temperature keeps on increasing over here. That is why when you move from thermosphere to exosphere, measuring those things become relatively very difficult. So on a general basis, we say that, okay, there is increase in temperature, so we don't have to mention thermopause, but certain books mention thermopause over here. So if you want, you can mention, as I mentioned in the initial diagram. It extends on an average up to 400 kilometers from the Earth's surface. Temperature increases with height. The temperature increases because you will realize that the concept of ionosphere is present here majorly. Obviously, certain parts of mesosphere also, but here also it is present. And that is why that ionization, what this ionization of gas means, which we will be studying. Let us say there is a gas, and due to the UV radiations that take place within a molecule, electron is removed. So it is charged. So these charged particles are present here because of the chemical reactions and the processes that are taking place. That basically again leads to increase in temperature. Further, you will realize that this is a very important layer because the International Space Station is also located here. This has been asked in one of the PCS examinations and long ago in the civil services examination also. So it can be asked as one of the statements also. So International Space Station is located on the lower part of this layer. Energetic solar UV cause ionization, as I mentioned, of the gases. Now, this is what is the thermosphere. Now, the important thing later on comes the exosphere. Now, this exosphere is basically above 400 kilometers, you can take up to 10,000 kilometers also. Over here, this is one layer where you have the least knowledge, least understanding also. So, extends beyond thermopause, ultra thin layer. At exosphere gradually merges into the emptiness. So this is one layer which you realize that this is basically merging into the emptiness of the space. So whatever is above the thermosphere is considered as exosphere. Clear? So this is what is exosphere. Now the important thing which we always talk about is a layer which we talk about, ionosphere. Many people get confused. Some people mention that thermosphere/ionosphere. That is a wrong statement. Or I would say partially correct statement. There is a concept known as ionosphere. Now, ionosphere is basically, again, not a layer which is specifically mentioned like a specific region. It is basically little dynamic in nature also. Now, it is present in the thermosphere and even certain parts of the upper mesosphere also. Now, it is characterized by ionized gases, or ions are present, which are formed due to the UV radiations. They are various layers that are located. Now, these various layers on this ionosphere are very important for the radio communication also. Again, nature has gifted us everything. Now, the NCERT does not go into detail with respect to this particular topic, the various layers. I have mentioned here so that you can basically understand them and note it down, because this can be asked in your papers. It has been asked in certain preliminary examinations of the PCS. So it can be asked in UPSC also very well. These are the layers. D layer between 60 to 99. Now you will be saying, sir, 60 to 99, this will come in the mesosphere. Yes. As I said, these are the layers where a dynamic phenomena of ionization takes place. So these layers which you realize are ionosphere itself is a part of the thermosphere as well as the mesosphere regions. And it is as the ionization takes place, so this region where ionization is taking place is known as ionosphere. So these layers which are formed are basically divided into various, or given various names, like the D layer, E layer, F1 and F2 layer, right? D layer basically between 60 to 99, it can be formed depending upon the ionization. Now it reflects the low frequency waves but absorbs the medium and high frequency waves, so again used for telecommunication. E or communication, satellite communications and all. Because these radio communication things and all become very important, and this is something what nature has gifted us. E layer between 99 to 130 kilometers, it is known as the Kennelly Heaviside layer. Now this is one thing that has been asked in prelims also in one of the PCS exams. So this this word itself is very important. They can ask you, Kenny heaviside layer is associated with which of the phenomena following? Let us say thermosphere, mesosphere, or ionosphere. So that wise you have to be very careful that it is talking about ionosphere. When I talk about 99 to 130 kilometers over here, then you also know that it is present in the thermosphere. But it is associated more with what? Ionosphere. Reflects the medium and high frequency waves. F1 and F2 layer between 150 to 380 kilometers. Now these are called the appellatant layer. Now F1 reflects the medium and high frequency waves, and F2 is generally associated with the sunspot activity cycle that takes place, which we will be studying later on along with that. So these are the few layers, D, E, F1 and F2 layer, which you should be aware of with respect to the ionosphere. Clear? So now comes the concept of structure based on the gaseous composition. Till now you have studied this, right? Troposphere, stratosphere, mesosphere, thermosphere, exosphere. From the base ground surface till the mesosphere, this region is known as the homosphere. Homosphere. Beyond that, it is known as heterosphere. Why? Because in this particular region, the composition of the gases is almost similar. A similar percentage is there. But beyond that, there are certain layers which basically are in a separate composition. At certain region, some percentage of certain gases will be more and some less. But over here, almost a similar composition is present. That is why it is present, known as homosphere. Let us see what it means. Up to 80 to 90 kilometers of the surface of the earth, there is homogeneity in the various gases. Whatever the gases are present, when we were talking about the gases, nitrogen, oxygen and all, you will realize that the composition is almost similar in these layers. But as you move ahead, between 90 to 10,000 kilometers, there is very different set of composition present. Now let's see. As we move from 80 to 90 to above, you will see heterosphere, because over here if you realize from 90 to 200 kilometers, there is a nitrogen layer, molecular nitrogen layer. Above that, there is an atomic oxygen layer from 200 to 1100 kilometers. Above that is a helium layer up to 3500 kilometers, and above that is an atomic hydrogen layer which is till the top. So because these layers of different gases are present, is known as heterosphere. Over here, mixed composition of almost similar homogeneity of the gases is present. That is why it is known as homosphere. On the other hand, these are the different layers which are present. That is why it is known as heterosphere. Clear? Now, something which we have heard or seen in our classes, even class 6th and 7th, we have seen this. That is why I have created a cute figure for you. This is again handmade. Why I have made this is so that you can understand it from the very basics, right? What is solar radiation? Or very often we call it insolation. What these words are basically saying, what they are is, please understand, the energy received from the sun in the form of short waves. Now the energy which is being received by us, that is basically referred to as the solar radiation or the insolation. Now you have heard this particular word, short wave. And with the terrestrial radiation, that means the radiation which is given out by the earth, you will hear the word long wave. We will study this concept later on, so that what it basically means. But meanwhile, in simple words, the energy that is received from the sun is referred to as the solar radiation or the insolation. Now please remember, now if you see the size of the sun, it is so huge. It is basically emitting the energy from all the direction. It is going in all the directions. But if you see the size of the earth, you will see it is just receiving very small part of the total energy of the sun. To be more precise, earth receives only half billionth of the sun's total energy. So we already know that the size of the sun is so small when you compare it, size of the earth is so small when you compare it with the sun. So that is why the amount of energy also that is received is a minuscule amount if you compare it to the total energy that is emitted by the sun. Now, having understood what is solar radiation, there is one more very important concept, solar constant. Now this particular topic which I'm going to deal in the next slide has been asked repeatedly in the preliminary examination also earlier on, and in the PCS examinations also it is very often asked. Now I'll request you to quickly write what is mentioned on the board so that you make the note of it in your A4 sheets, right? Okay, you can pause the video if you want. Okay, let's move ahead. Next concept, if you want to understand the concept of solar radiation, is the concept of solar constant. Now why this is important is, this can be asked as one-liner in your preliminary examination, right? Now see, let's understand this concept. the amount of solar radiation received on a unit area of the surface facing the sun at an average distance between sun and the earth. So if we take a unit area, the amount of energy that is received in that particular area is referred to as a solar constant. Now it is basically, the figure is 2 calories per centimeter square per minute. 2 calories per centimeter square per minute. Now this calories per centimeter square is also referred to as Lange. So it can also be mentioned as 2 Lange per minute. This has been asked repeatedly in the PCS examinations of various state services. Also, it has been asked in the preliminary examination as one of the statements. So you should be very clear with it. What does it mean? The amount of solar radiation, you know what solar radiation is? That is received on a unit area of a surface facing the sun. With an average distance is 150 million kilometers. So with an average distance between the sun and the earth, this is known as the solar constant. Clear? Now, having understood this, we have understood what is solar radiation or insolation. We have understood what is solar constant. Please write this down quickly. You can pause the video and then possibly write it down, right? Okay, having studied this, let us move ahead. Very important factors, that what are the factors that are basically affecting the distribution of insolation? Now, you know that very well, Earth has a tilted axis. That is why if you see, I have tilted it in this manner, right? Now, let us see this basic understanding. During the months of summer time, when we basically see, or let us say when the sun is basically directly facing, let us say, the Tropic of Cancer. Let us assume the sun is directly facing the Tropic of Cancer. In that particular case, do you realize that this particular region will be having more amount of sunlight in comparison to the lower latitudes? Let us assume that sun is over here. Let us see, sun is over here. Now, supposingly there are direct rays from the sun that are coming. For Tropic of Cancer, right? Now, if you realize this, because it is tilted, this region is experiencing, let us say, longer duration of days also, then also larger amount of insolation also. So that means the tilted axis of the earth are actually impacting the amount of insolation that is being received on a particular surface of the earth. Now, if you see this region, this will obviously, when it is directly over the Tropic of Cancer, obviously you know this very well, that there is going to be by default greater insolation over here. When there is greater insolation, automatically the amount of energy received is also more. So this is the basic representation which you should be very well aware of. Clear? Okay. Now, please copy it down. Just to explain, we will be doing this diagram later on also. This 0 degree is equator, 23.5 degree north is a Tropic of Cancer, 66.5 degrees Arctic Circle, 23.5 is basically Tropic of Capricorn, and 66.5 degree is the Antarctic Circle. At the top you have over here the North Pole, and over here you have the South Pole. This is a basic understanding that should be clear with you. Clear? Okay. Let's move ahead with the distance from the distance from the sun. Now, if you see, this is the sun. Let us see the condition at the time of July. Now, if you realize that in the month of July, the distance is 152 million kilometers. Clear? And in the month of January, the distance is 147 million kilometers. It is because of the orbit that the Earth has. Now, do you understand something very clearly? That this is the longest distance between the sun and the Earth. This is basically known by a word aphelion. A-P-H-E-L-I-O-N. This particular distance, which is the longest distance at any particular point of time, 152 million kilometers, is known as aphelion. Whereas the shortest duration is in the month of January, which is 147 million kilometers, which is known as perihelion. That is why on an average, because farthest is 152 and the nearest is 147 million, that is why we take an average of 150 million kilometers as the average distance between the sun and the Earth. Now, please understand, do you analyze a very interesting fact here? During the time of July, you know that very well that it is summers in the northern hemisphere, right? Now, during this time of summers in the northern hemisphere, the earth is farthest. Had the earth been closest during that time, the summers would have been very severe in the northern hemisphere. That is why, again, this is how nature is. Because it is farthest in the month of July, which is basically summers in the northern hemisphere, the summers are not very severe. They are relatively milder. Had that been in the case where July would have been, let us say, a condition which would have been perihelion, in that particular case, the summers would have been so bad, so hot, that possibly it would have basically impacted the survival of the human beings also. Why I'm mentioning about northern hemisphere in particular? Because northern hemisphere is the one which basically comprises a majority of the land surface lies in the northern hemisphere, and so does the human habitation also. That is why this is how balance of things basically happen. Now, January again is, you would see that this is representing perihelion, which is 147 million kilometers, which is these two things. Now, how does these two things basically impact? Now, see, distance from the sea. If now I ask you, there is more insolation during the time of January or during the time of July, 99.9% students are going to mark it wrong. There is more insolation with respect to what is received on the earth in the month of January than in the month of July. Why? Because the distance between the earth and the sun is less, that is 147 million, than in comparison to 152 million in the month of July. So if somebody asks you, because you are staying in the northern hemisphere, you possibly assume because it is summers in the northern hemisphere, so possibly yes, in the summer more insolation would be received on the complete earth. No. Because the distance is less in the month of January, which is 147 million kilometers, that is where the overall insolation that is received, that means the incoming solar radiation received on this earth, is more in the month of January. So can I say more insolation in January than July due to the distance. So this should be very clear to everybody. Many people get it wrong just for a mere reason that you presume that you are in the northern hemisphere and it is summers during that time, so possibly there is going to be more insolation. No, it is overall the distance that is mattering here. This has been asked as one of the statements in the preliminary examination. Clear? Okay, let's move ahead. Let's see the length of the day. Now, if you realize that if the length of the day is longer, obviously if there is summers during a particular time, summers will have a longer duration of the day, so there is more insolation being received. So we can simply say longer the length of the day, now this is referring to a particular region. I'm not talking about complete earth, particular region, right? At a particular region. Now that particular region can be any part, right? Particular region. So that is more insolation, obviously. Keeping other conditions constant, right? Keeping other conditions constant. Other conditions or other factors constant. Clear? Okay. Please understand this very, very clearly. Clear? You can note this down very well. Quickly note it down. Now see this very well. When I'm talking about next point is the effect of the atmosphere. Now you know that very well that atmosphere itself impacts the amount of insolation that is reaching the, let us say, the surface or the land. Why? Because let us say there is a lot of cloud cover. So the cloud covers is one of the means which is basically reflecting the insolation back into the space. This we will be studying in the heat budget also topic, where we see how much the amount of insolation that is coming and how much is basically observed, how much is reflected, how much is scattered. We'll be studying in that. But the effect of atmosphere is that whatever disturbances in the form of, let us say, clouds or all these things are present there, they basically impact the insolation that is reaching the surface. Let's see. You can say cloud cover, dust particles, etc. in the atmosphere impact the insolation reaching the surface. Right? Clear? So that is going to impact the surface. Obviously, clouds also reflect dust particles and other things also, basically reflecting it back. So now we will be studying this in the topic of heat budget in detail. Clear? So this is what we have studied with respect to the factors that are impacting the distribution of insolation. Clear? Let's move ahead. Heating and cooling of atmosphere. Now, very important thing that happens is when we're talking with respect to the topic of climatology. Now, when we talk about atmosphere, what are the various processes through which the atmosphere is basically heated or cooled? Now, please note this very carefully, that there are 4 mechanisms that I have mentioned here, or 4 ways, or 4 concepts also you can say. These are mentioned in your NCERT also, and I have explained them using the diagram. So make sure that you use the diagrams when you are writing your answers also, right? Now see, first is conduction, second is convection, third is advection, and fourth is radiation. Many people would have studied conduction, convection, and radiation in their physics chapters also, right? Very often in class 6th, 7th, 8th also you read it. Advection, sometimes you might have read, sometimes you may not, but this is mentioned in your NCERTs also. So we're going to explain this. Now let's understand one by one what are the ways in which heating and cooling of the atmosphere possibly takes place. See, I am taking right now one concept individually, keeping other factors constant. Please remember that very well. When I talk about conduction, the basic thing that you have already studied about conduction is that any body, any particular thing that is heated or cooled, whatever be that scenario, let us take a body that is heated. Now, for the conduction process to take place, that body needs to be in contact with somebody else, something else. Conduction works through the process or mechanism of contact. Let us assume this. Supposingly, this is a hand, which is right now, because I had placed in front of a heater, it is heated. Let us say the temperature of this particular hand increases. Now, let us say this hand, because of the weather or climatic condition, it is very cold, and I bring it here and join my hands. So you will realize that the heat from this particular hand is going to this particular hand, and that is because of the contact. This is known as conduction, conduct. Clear? Now see here, similarly, what happens is, supposing that this is a land surface, right? This is a land surface which I have drawn here. Now you know that very well, that air is everywhere, right? Air is everywhere. Obviously, the density of air is greater when you come closer to the ground, and the density keeps on decreasing. That is fine. But do you realize, supposingly this particular land surface is, let us say, hot, little bit, relatively hot. The molecules that are present here, the air molecules, which are in contact with the surface will also get heated because they are in contact. Let us assume this is the surface, the air molecules are present here, they are in contact with this particular surface, they will get heated, so they will warm. Then these, let us assume these particular ones are heated because of the contact, right? Now they will also give certain energy to heat to these also molecules that are present. Yes or no? By contact only. Now, what do you understand by this? Conduction mechanism is very well effective in the case closer to the ground, because as you move higher, there is more dissipation of energy, and the impact or the effect of conduction will not be so effective. So that is why conduction mechanism in here particular case works well for the air that is present close to the ground surface or the land surface. This is a way in which the atmosphere is heated. So that means heating of the atmosphere in the lower layers is through, very important means, through the process of conduction. Now, having understood this concept, let us read it also and understand. Why I have written this is so that what I've explained you right now, that will go into your minds, but also the content is here that will consolidate the things. Now see, the earth is heated by insolation. You know that very well. Because of the incoming solar radiation, this particular surface of the land is heated. Now, while the air in contact with the land gets heated slowly. Now you see this air or the air molecules that are present in contact with the land are also getting heated slowly, and the upper layers in contact with the lower layer also gets heated. That means when this particular layer, which is the lowest layer, is getting heated because it is in contact with the land, the upper layer is this upper layer is in contact with this layer, so it is also getting heated. The lower layer is getting heated because it is in contact with the land surface. The upper layer is in contact with this lower layer, so it is also getting heated. But you know that there will be lesser amount of energy being transferred because energy is dissipated, right? So this process is known as conduction. The flow of energy is from warmer body to a cooler body. Understand this very well. This is a basic understanding also. The flow of energy is from a body which is warmer to a body which is cooler to balance it. Clear? So this is the process of conduction. Now this process is relevant majorly in the lower layers of the atmosphere, not in the upper layers, obviously, because we know that other mechanisms are working, and one has to be the particles or the molecules have to be in contact for the process of conduction to take place. Clear? Effective mechanism. If in the question, in the exam, it is asked that, let us say a tricky question, one of the statements that conduction process is relevant only in the lower layers. So that statement is not wrong. That is correct. Clear? That is what the NCERT also basically mentions. So that will be marked correct. So keep this in mind very categorically. Clear? We have done with conduction. Now let us move to the concept of convection. Now you know that very well. When you were in class 6th or 7th, you were taught the concept of convection, where let us say you heat a pan which is filled with water, you heat from below, and there are convection currents that are established, right? Similar phenomena basically happens in the atmosphere also. Now what happens is, see, in this process, when the layer is heated, now please understand, when a lower layer is heated, it might rise up, rise vertically. This vertical rise is basically, and that vertical rise leads to the spread of energy also, transmission of energy. So this rising vertically and then dissipation of spreading of energy or heat is basically referred to as the formation of convective currents, and this phenomena is known as convection. Now let us see this. The air in contact with the earth rises vertically. Now you see, supposing the earth is heated tremendously. Now please see, conduction was a process through which, let us say, the lower layer is heated and it is basically giving its heat to the upper layer also. Now there is no vertical movement that is being talked about there, no. Here, when the lower layer is heated, it rises up, right? It rises vertically on heating in the form of current. Now this is like a current that is rising, right? And while this process is going on in the vertical manner, it is giving energy to the nearby layers also. Why is it rising? The reason is because the layer which is warm has got lighter. The lighter ones are going to rise. The cooler ones will take its place. Now see here, let us assume this. When this air is, because it is heated, it is lighter. Now lighter one will rise, so it is rising up. On the other hand, there will be cooler layer, which a cooler will take its place. You have seen this mechanism basically in the land and sea breezes also, which we will be doing in the next chapter. You must have studied also. The similar mechanism happens there also. Clear? So this is basically known as convection. Now please remember this very, very carefully. A very particular, very important line is mentioned in the NCERT. And this has been asked in the preliminary examination also. When I talk about convective currents, in the previous chapter you had heard, or I had mentioned very categorically, that the weather phenomena and the climatic phenomena are basically confined to the troposphere layer, right? Similarly, over here also, the convective transfer of energy is confined only to the troposphere. This should be kept in mind. There can be questions which they can alter it, like they can mention, it is present in the mesosphere, so and so, what such types of things can be mentioned. So you need to understand this statement is mentioned. Now many will say, no sir, there have been certain research studies which mention about these things, new discoveries. Please remember, the NCERT is a core where the UPSC basically considers it as correct. So this is what you have to basically abide by. Clear? Okay, please note it down. Pause the video and note it down. Okay, now next. Now we have covered two things. First, without any vertical movement, supposing that air is being heated, the air molecules are being heated, that is conduction. And let us say because of heat, there can be rise of currents also, a vertical rise, that is convection. Now, do you realize along with them, there can be there is horizontal movement of air. See, the difference between air and wind is, air is still, wind is moving air. Understood? Horizontal movement basically, please understand, air is still. Horizontal movement of air will be known as wind. Clear? Now over here, please understand, advection basically covers this aspect. Do you realize there is a great possibility also sometimes when you see during the time when the summers are on its peak in India and the northern regions and the northern plains, we have very, very dry, dusty, hot winds that blow, which are known as loo, right? Now that is basically what a horizontal movement. That is horizontal movement, and that horizontal movement is basically impacting what? The atmosphere, na? The lower layers in the troposphere only, but it is impacting. Isn't that transmitting energy from one region to another? It is based on the horizontal movement. So advection basically refers to the horizontal movement that has taken place. So transfer of air through the horizontal movement of air, or transfer of air, and plus you can add plus the energy or the heat. This can also be added. Yes, na? Obviously there is energy or heat is also being transferred. Now this process is known as advection. Now please remember, there are certain things that are being mentioned here. In the middle latitudes, most of the diurnal variation in weather is caused by advection. There are various regions, particularly in the middle latitude, where whatever diurnal means daily day and night variation that happens, there is a great impact of the advection, that is the wind movement that is taking place. So that is why they also occupy a very important position with respect to heating or modifying the temperature or the energy changes that take place in the lower atmosphere in particular. Now, loo is again an example of the advection process, right? You know that it creates a lot of dry conditions, people suffer a lot of heat strokes because of loo, right? Because it is dry, dusty, and there is horizontal movement of the air. Clear? This is known as advection. Now we have done three processes. First is the conduction, second is the convection, third is the advection. Now comes the radiation. Now please understand this very, very well. When I talk about radiation, there are two things we should understand. First, when I began with the chapter, I had very categorically mentioned that incoming solar radiation, I mentioned the word radiation, incoming solar radiation, and I mentioned the word short wave. Clear? Now that is one form of radiation. That means when the radiation from the sun are basically coming, they are also what? They are also without any contact, right? There is no contact here. Without any contact, they are heating the atmosphere. Firstly, that is what is a characteristic feature of radiation, without any contact. On the other hand, when the radiation is being observed by the land surface, then there are emissions of radiation from the Earth's surface also back into the atmosphere, which we will be doing in the concept of heat budget after a few minutes. So there are two things that are happening. One is incoming solar radiation. Other is terrestrial radiation. Terrestrial radiation means something that is given back by the Earth into the atmosphere, because Earth has to maintain a balance. That is what heat budget is, which we will be studying. See, if continuously heat energy keeps on coming from the sun, and that keeps on absorbing, obviously the temperature will increase so much that it will create a lot of problems. That is, the balance will be not maintained. So that is why their energy has to be given out. Yes or no? For example, you take your bodies. When you urinate, when you go to the toilet, you realize that along with the urine, energy is also basically dissipated, given out. These are also ways. When you sweat, there is evaporation taking place that cools your body. So body also has a mechanism to maintain its temperature. Similarly, Earth also has a balancing act through which it maintains its temperature. That is what is known as a heat budget also. Because when I talk about temperature, it is also a form of energy. Now see here, the incoming solar radiation heats the surface because it is without contact. That is what is a characteristic feature of radiation. So Earth receives insolation from the sun in the form of short waves, which is known as incoming solar radiation. Now, we will be studying all these things, don't worry. While the earth, after being heated, becomes a radiating body, because it is heated now, any heated body gives radiations, right? Now it radiates out to the atmosphere in the long wave form, which is known as terrestrial radiation. So terrestrial radiation refers to the radiation that is dissipated from the earth because it was heated. Clear? Now comes a very interesting thing that you should all note it very clearly. See here. You all have or must have studied in your classes electromagnetic spectrum, right? I will not go into the physics or the component, though you have to study for your general science as a part of the civil services. But I'm just mentioning one thing. See this. Remember this as GXU Wimmer. GXU Wimmer. Now, what does this basically mean? See here, let us see this one by one. G basically refers to gamma rays. X basically refers to X-rays. U basically refers to the ultraviolet or the UV rays that you talk about. V basically refers to the visible light, the ones which you can basically see, right? I refers to infrared. M basically refers to microwave. R basically refers to the radio waves. Now you should understand one thing very clearly. As you move to the left side, clear? How you'll remember? GXU Wimmer. This is something that I learned when I was in class 10th. From that time, I don't forget this because it is by heart. I learned in that manner when I was in class 10. So GXU Wimmer. Now please understand one thing. You should understand that these particular side, as you move from this side to this side, there are a lot of variations that happen. First, let me understand this. See here. As you, let us say, if you are in this position, let us say gamma and let us say radio waves. I'm just mentioning here. This is a region. These are those waves or forms of energy which are high in energy, right? High energy. These are relatively low energy, right? Along with it, these have high frequency. Frequency of waves are very high. These have low frequency. Frequency has an inverse relationship with the wavelength. That is why remember that these particular waves have low wavelength. And that is why these are known as short waves. These are basically referred to as long wavelength. Long wavelength. So these are referred to as the long waves. Now please understand, that means as you move towards, let us say if you move from gamma rays till this position, the frequency will keep on decreasing, the energy will keep on decreasing, the wavelength will keep on increasing. Clear? Now remember, when I mentioned over here that the sun basically emits short waves, like incoming solar radiation is in the form of short waves. See here, short waves, incoming solar radiation. That is why do you hear that when I talk about incoming solar radiation, we very often mention about UV rays. Now please remember this. The incoming solar radiation has all of them. The incoming solar radiation has all of them. But the amount which if I see UV rays is the maximum. So incoming solar radiation that means visible light is also there. Incoming solar radiation has all of them, but major component is UV. Now tell me just one thing, when I talk about UV, UV basically lies in the bracket of high frequency, relatively higher energy, and short wavelength. That means it is a short wave. What is this? Isn't this a short wave? If you compare relatively, these are higher energy ones. Na? So before the visible light, these are higher energy. After the visible light, these are relatively lower energy. Visible light basically forms a middle position, right? Short waves. That is why the incoming solar radiation is talked or spoken in the form of short waves. Now, when Earth has got heated, it will emit radiations. Now, please remember one thing. Out of the radiation which is emitting, the major radiation is which one? The infrared. Now, infrared, you should understand, on the left side of the visible light are the high energy, high frequency and low wavelength. On the right side are relatively what? Low energy, low frequency and higher wavelength. So, infrared are the major component of terrestrial radiation. Many will say, sir, does microwave and radio waves are on some amount present? Yes, very minuscule amount, yes, but major is infrared. So, major component of terrestrial radiation is infrared. Now, what I have taught you over here is the most important thing in this chapter, which is not explained properly in the NCERT. If you know this, you can solve a lot of questions which have been asked. Now you will say, sir, now this infrared lies in the bracket because it is on the right side. It is basically lower frequency, lower energy, long wavelength. Can I call it a long wave? See here. So while the Earth, after being heated, becomes a radiating body, it radiates heat to the atmosphere in the form of long waves. So these are basically what? The infrared rays which are being given. What are these? These are majorly UV rays that are coming. So after heating, Earth radiates the infrared. That is why it is known as the long waves. Clear, everybody? This should be very clear in your mind. If this concept is clear, most of the concepts will be clear. Clear? Okay. Now let's come to the concept of heat budget of the Earth and the atmosphere. When I talk about heat budget, please understand, this basically refers to the balance between the incoming solar radiation and the terrestrial radiation. See here. When I talk about heat budget, it refers to the balance between incoming solar radiation. Now, just tell me one thing. When I say incoming solar radiation, what do I mean? I mean insolation. And what do I mean? Short wave. Clear? So, it refers to the balance between the incoming solar radiation and the outgoing is what? The terrestrial radiation. Now, terrestrial radiation is in the form of, you know that very well, it is long waves. Now, why this is done? This is basically done so that there is balance of energy. Energy over here also means temperature. If excessive amount of energy is basically trapped inside, what will happen? It will lead to disturbances with respect to the life, with respect to the climatic changes that might basically aggravate. So it is basically a mechanism through which basically things basically happen, and the homeostasis in a way is basically maintained. Clear? Now please understand, this topic again is considered the most difficult topic by the aspirants because they never understand how this heat balance basically works. This has been asked in the mains examination also, and repeatedly it is asked in the preliminary examination also. Now see this very carefully, and for PCS exams, if you ask me, every single year a question comes on this. Any PCS across the country. Having understood what is heat budget, you can quickly note it down. It is basically refers to the balance between the incoming solar radiation and the outgoing terrestrial radiation. Now see here. Now, the problem that many people face is it has a lot of numbers that are mentioned here, here also, and possibly this makes it difficult to remember and possibly understand because we have not studied mathematics and all. But this is not mathematics, this is basic 1, 2, 3 that you basically do. Once you understand this, you will not face any problem. But way I am teaching you, you need to follow that mechanism very, very categorically. This is one of the most important topic that you can come across. Clear? Now see, let us assume that when I talk about heat budget, I will be basically talking about the balancing, what is incoming and what is outgoing. Incoming, that means incoming shortwave solar radiation. So what all is coming, I will be seeing how it is impacting and what is happening to it. And then I'll be talking about what is outgoing long wave radiation, which I'll be talking about that. Yes or no? Yes. So let us take one by one. Let me take that I'm taking now, right now, the incoming solar radiation or the radiations that are coming from the sun. Now see, if I take a specific number and all, it will become difficult. So let us take one thing. Let us take the complete solar radiation which is reaching the earth as 100%. Or you can take 100 units, right? 100 units or 100%, whatever. Take it as one, doesn't matter. 100% or 100 units. Let us take this total insolation that is basically coming on the earth, let us say even the atmosphere and all, is basically 100% or 100 units. Now, when it will be when the solar radiation will come, it will encounter the atmosphere. Now, there will be a lot of things that will happen. Some will be, let us say, radiated back, some scattered, and a lot of phenomena will take place. And out of it, some part will reach the surface of the earth. Not all. This is what is being studied here. Let us see. Bache, let's imagine this 100 basically refers to the total insolation, right? The way I'm teaching you, understand it that way, you will not face any problem. Now, when I say, let us say the total insolation is coming, this insolation is coming here. Now, what happens is, out of the 100 units, let us say 100 marks you have, 100 units or 100%, whatever, out of these 100, certain amount of units or radiation will be reflected back. Now, before you do, please understand this diagram also. Let me make it very clear. This green basically refers to the Earth's surface, right? This particular point, this line is referring to the Earth's surface. This particular part is referring to the atmosphere. More precisely the troposphere which we are talking about, right? This is referring to the outer space, even mesosphere, even exosphere and all those things, which is empty space where the atmosphere merges with the outer space. This is more important for us. This is the troposphere because most of the climatic phenomena take place in the troposphere. So though we are mentioning atmosphere, it is basically talking about mainly the troposphere. Obviously, other layers are being considered. Now see, as the total radiation is coming, out of the total radiation, 27 units is being sent back. That means reflected by the clouds. Where? Back to the outer space. That is why I have written minus here. Clear? That means 27 units are sent back into the outer space. So, gone. Secondly, now please understand, out of the radiation that is 100 units, 27 is gone. No need to worry about it, it's gone. Out of the 27, out of this 100, some radiation which reaches the surface, the earth also reflects it. How? You will realize that sometimes you would have studied that, let us say the snow cover is there. Sometimes the snow cover also reflects the radiation back. So out of the 100 units, 27 units have been reflected back by the cloud and 2 units have been reflected from the surface of the earth. That is why please remember, presence of cloud cover, that is what I had mentioned in the insolation, the factors affecting that. The greater the amount of cloud cover, which basically impacts the insolation that is reaching the ground surface or the surface of the earth. So 27 is gone back, 2 units are basically sent back by the earth. So because it is sent back to the outer space, it is also minus 2. So minus 27 minus 2, that means out of 100 units, you have already lost 29 units which are sent back to the outer space. Now, you will realize that scattering of lights also, because of the dust particles and all that are present, because of that scattering also, 6 units will be again, because of that scattering, sent back to the outer space. So that means, what do you see over here? Out of the total 100 units, 27 units outer space by the cloud, 2 by the earth, minus 6, that means 6 units scattered in the space. Now, what is actually reaching the surface? Let us see this. Out of these 100 units, there is certain amount of rays which was scattered, though it is reaching the ground surface. That is why I added plus 17, because the Earth's surface is absorbing that amount of radiation. So plus 17 here. Now these are based on the estimation, so they have simplified this. Though actually you are measuring in the form of energy and all, those are complex units. This is a simplified form. So out of them, 17 units out of the 100 are reaching the ground surface through the scattered radiation which is entering here. Direct radiation, do not assume that cloud, because the cloud cover is between it, is just a representation. Cloud has scattered, but all the other is basically coming to the ground surface. So 34 units are directly where it did not encounter any cloud, or straight away it came to the surface, the radiation came. So that was 34 units. So 34 units are reaching the ground surface. Out of 100, you have realized these have gone to outer space, these have been absorbed by the Earth's surface. Another 14 units are absorbed by the atmosphere. You realize when the insolation is coming, obviously the insolation will also heat the atmosphere. You had studied the radiation concept where I had told you terrestrial radiation as well as the insolation, which is also heating the atmosphere. So 14 units will be observed by the atmosphere itself. This is basically the phenomena which you study with respect to the incoming short wave or solar radiation. Now see here, the same thing that I have explained here is mentioned over here. See now, total insolation is 100% or 100 units. Reflection by cloud is 27 units or 27%, whatever you want. Reflection by earth is 2% or 2 units. Scattered to space is 6 units. That means 35 units are lost, are gone. Out of the 100 units, how much is remaining now? 100. So that means, can I say this, the remaining is 100 minus 35. 100 minus 35, what is remaining? 65 units. So 65 units are the one which are remaining, because the other 35 are already gone to the outer space. Now out of this 65 units, let us see the heat budget of the Earth. Earth is this surface, atmosphere is this surface, this area. Now heat budget of the Earth, what is it, how it is heated? By direct radiation, 34 units, 34. By scattered radiation, 17. Total is 51. Now heat budget of the atmosphere, did you see that over here atmosphere is absorbing what? 14 units. So absorption by the insolation, 14. So now see, 15 plus 51 plus 14 is 65. So the 65 units which was remaining is being distributed in such a way that 51 units are being observed by the Earth and 14 units are being observed by the atmosphere. Now this is only with respect to the incoming solar radiation. Now we need to study how it is basically going back. Okay? How it is returning. Now that returning and coming will be balanced. That is what will be referred to as a heat budget. You have just done what? The incoming solar radiation, where 35 units were sent to the outer space, lost, 65 units were left. Out of the 65 units, you realize that 51 units were observed by the Earth's surface. Some in the form of scattered radiation, that means the 17 units, and 34 units from the direct insolation. Other 14 units were observed by the atmosphere. So this is the incoming solar radiation whole chart that you have done. Now comes the second part of the heat budget, which is the outgoing long wave terrestrial radiation. Now please understand this very well. You need to understand this well. See here. When we study about this radiation which is going, let us again see from the similar manner as we had seen over here, heat budget of Earth and heat budget of atmosphere. Heat budget of Earth. Now you realize this, everywhere I have mentioned negative here. Why? Because it is being lost. In the previous one, energy was being gained, so I had written plus. Now the energy is being radiated back or sent back, so it is known as minus. So that means 23 units are being We will study all this later on. Right now, we are not concerned with the atmosphere. This is what the green line is representing, what? The Earth's surface. So heat, when I'm talking about heat budget of Earth, I'm just concerned with respect to the Earth. Now you see 29 units are being lost, 9 units are being lost, and 19 units are being lost. So energy lost from the Earth is 23 plus 9 plus 19, which is 51. Now you will say, sir, from where has 23, 9, 19 come? Better remember, scientists basically calculate them in the form of energy, complete statistical phenomena, and all those things are done. Those are a lot of numbers and all energy units are involved. This is a very simplified form of that complex process, right? That is based on the observation, that how much is observed, how much is reflected by cloud. That is an average that is taken, right? Based on that average, we are studying this. So energy lost by the Earth is 23 plus 9 plus 19, which is 51. Clear? Clear? Now, please understand this. In the previous slide, the amount of energy that was received by Earth was also 51. Now, lost is also 51 over here. Clear? Now, let's see further. Heat budget of atmosphere. Let me take this atmosphere. Out of the 23 units which was radiated out, 6 units were, because it is going out now do you realize that when this is being radiated or given out in the form of, let us say, long wave radiation. Out of the long wave radiation, some will be absorbed by the atmosphere. So it is mentioning that 6 units are being absorbed by the atmosphere. Other 17 units are sent to the outer space to balance the heat. On the other hand, there will be certain turbulence, convective mechanisms, cloud formation, and all those taking place. In that particular process also, the 9 units are lost and that are gained by the atmosphere, right? Evaporation will basically lead to losing of the heat from the Earth, but addition to the atmosphere. So what can I say? See here. If I talk about the heat budget of the atmosphere, it will be 6 plus 9 plus 19. First of all, see here. 6 plus 9 plus 19, that is 34. But one more thing that we have forgotten to add is, in the previous slide, we had known that the atmosphere already had 14 units. 14 units was already there. Now you realize, we know that these units have come on after the radiation. So we need to add 14 more from this, because 14 units of energy was already there with the atmosphere. So adding 14 units will lead to 6 plus 9 plus 19, that is 34. 34 plus 14 from the previously absorbed, which gives it to be 48. 48 units. Now see here. Now see here very well. Now see here very well. This energy, which is 48 units, is again being lost to the, later on, to the outer space. So energy lost is 48 units. Now see one thing. 17 units were being lost through this mechanism, and later on the 48 units are again being lost to balance the temperature. So this is 48 units. So 17 units from the radiation. So 48 plus 17 is 65 units. 65 units are being sent out. What was the incoming? 65 units. What is being sent out? 65 units. So this is the balance that is being maintained. Clear? This is known as the heat budget which we were talking about. Clear? So please note it down very carefully. This is very, very important. Take a screenshot or whatever you want, you're noting down. Pause the video if you want. Okay, let's move ahead. Variation in the net heat budget at the Earth's surface. Now please understand, you need to understand this diagram very well, because some will misinterpret it. Generally, when you see the Earth, let us assume this is the equator, this is the Tropic of Cancer, Capricorn. When I turn it like this is supposedly the 0 degree latitude. This is equator. What does this represent? Let us say this is the equator. I've turned the Earth. This is supposedly representing the North Pole. This is the South Pole. If I rotate it in this way, it will be North Pole will be on the top, but I've turned it like this just to show you. What is it saying is that this basically refers to the latitudes over here, and this is the energy in watts per meter square. The regions between 40 degree north and 40 degree south basically receive an excess amount of insolation. So there is energy surplus regions. You see, this white region is what representing the solar radiation which is coming, the green is basically referring to the terrestrial radiation. So if you realize over here, there is surplus. That means more amount of energy is present in the 40° north to 40° south region. There is energy surplus. On the other hand, the other regions beyond that is energy deficit. That means there is a lot of terrestrial radiation taking place, their insolation is less. So that is why the difference between the incoming and outgoing radiation is known as the net radiation. This is the graph. So net radiation means the difference between the incoming and the outgoing radiation is basically referred to as the net radiation. So net radiation, if you see, more insolation is in the region of the 40° north and south. So that means more energy, that means there is surplus of energy. Beyond that, there is deficit. So that is why this red part is referred to as a surplus, and this regions are referred to as the deficit regions. Clear? Okay. Temperature. Now please understand, when we talk about temperature, you know that very well. Temperature basically talks about the degree of hotness or coldness of any particular thing. Something is hot or something is cold. Clear? Something is hot or something is cold. That is what we talk about temperature. Heat is what? An energy. So see, the interaction of insolation with the atmosphere and the Earth's surface creates heat, which is measured in the form of temperature. So obviously you realize that the insolation that is coming, it creates heat, heating of the atmosphere, heating of the surface of the Earth. Now, it is heating, but how do you measure it? You measure it using the temperature, thermometers or various types of thermometers that are present there. So temperature basically refers to the degree of hotness or coldness of any body, entity or thing. Whether you are measuring the temperature of the land or the atmosphere, you will realize that you are basically measuring the amount of energy that was received that led to the heating or the temperature increase. So while the heat represents the molecular movement of the particles, because let us say when I say heat is given, a particular molecule set of air will be in motion because of the heat. Now, if I want to measure that, the temperature is a measurement of the degree of how cold or hot a particular thing is. This is what you should be understanding first of all. Clear? That is energy, and what is they're referring to the heat and the temperature concept. So please understand this. Note it down quickly. Let's move ahead. Factors controlling temperature distribution. Now please understand this. Let us see this particular diagram only, and we'll write it here only in brief, right? See here. This is one of the easiest topic that you can come across, that what are the factors that are controlling the temperature distribution? Let us see the latitude. Now you just now saw that we know very well that Earth is tilted axis is there and all. Let us see, higher the latitude, higher you go to the latitude, let us say from 0°, that is the equator, to let us say 65.5 to 90°, you will realize that the rays of the sun are slanting in nature. How? See here. This is supposedly the surface of the Earth. The sun rays that are coming over here, supposing it is direct. Over here it will be slanting. So these are what? Slanting rays in the higher latitudes. Slanting and direct. That is why what do you see? As you move in the higher latitudes, see, keeping other factors constant, please remember, if you're going to mix all of them, then the answer will not come. You have to keep other factors constant in order to study. Later on, when we analyze what a condition of a situation is or a region is, then we take all the factors together. So under normal conditions, what you see, as we move to the higher latitudes, the temperature basically falls. Clear? Altitude. Now you know that very well, that when I'm talking about troposphere particularly, there is a concept of normal lapse rate. Normal lapse rate we had mentioned in the previous chapter also, we will be doing in the next chapter also in detail. Basically refers to the decrease in temperature of 6.5 degrees Celsius per 1000 meters. That means for every kilometer, there is a fall in temperature of 6.5 degrees when you're talking about the troposphere. Now, when you realize that there are huge mountains that are there, let us say if you go to a particular altitude, by default what will happen? Because of the increase in the altitude, the normal lapse rate will work. So as you move higher in the altitude, the temperature will decrease. as one moves higher in the altitude, temperature falls. I am talking with respect to the troposphere, please remember. I had mentioned normal lapse rate, where you realize there is 6.5 degrees per 1000 meters fall in temperature. This should be understood very clearly. Right? Now comes the distance from the sea. Now you know that very well that if you just imagine that in a country, in India, you have a region, let us say Nanded. Nanded is in Maharashtra and Mumbai is along the coast of Maharashtra. Now you realize that the climatic conditions of Mumbai are almost uniform, very nice weather conditions, raining also and all. Matlab it is very calm. Because why? Because there is a moderating influence of the sea. As you move inside interiors of the earth, you will realize that there is very wide variations because it is far away from the sea. So that means there is a possibility of very high temperatures during the summer months and very cold temperatures during the winter months. Quite possible because of the what the concept we know as continentality. Continentality means far away from the sea. Because the sea has a moderating influence on a particular region which is close by. As you move inside the region, you will realize that the influence decreases, and then there is very high variations in the with respect to the seasons. There is very high variation that is present. Like summers might be very hot, the winters might be very cold. So you realize that seas have a moderating influence on the nearby regions. Yes? The ones which are far away are the ones which basically have very high variations in the temperature. Ocean currents. If you realize this, that ocean currents, again, if it is a current is warm, it will have a influence. That means it is going to warm the coasts. Let us take the example of during the months of January, the Gulf Stream basically has a warming influence in the Atlantic Ocean. Example. Now, any current which is, let us say, we will be doing this chapter in the oceanography part. What happens is, if a current is warm, it is going to have a warming effect in the regions that are nearby. If it is cold, it is going to have again aspect of, let us say, regions will be impacted from a similar manner, because the cold ocean currents obviously have a cold effect on the nearby regions. Clear? So then comes the wind. Now you know that very well. Wind, obviously, whether it is permanent winds, temporary winds, whatever winds we are talking about, they have a very important influence with respect to the temperature. For example, over here we have mentioned right now Lu. Now the Lu, when it comes, it is moving in the regions of the northern plains. You realize that of India, you realize that it basically raises the temperature and the aridity of the region to a very great extent. Right? Many people, that is why, suffer from heat strokes. Slopes and the mountain barriers. Now see, you know that very well. If I talk about the Himalayas, if you take the example of Himalayas, if the Himalayas had not been present, possibly the northern plain would have been a frozen region during the winter months. Why? Because the cold winds from the Siberian region are blocked by the Himalayas, the mighty Himalayas. So these barriers being present are basically acting as a climatic divide. Climatic divide, cultural divide, because based on the climate only, civilizations basically modify themselves, right? So this is again a very important thing that you should be knowing. You can note it down: latitude, distance from the sea, altitude, ocean currents, winds, slopes, or mountain barriers. Clear? Okay, let's move ahead. Temperature distribution. Now, temperature distribution basically can be seen. Your NCERT does not mention all the aspects, so I'm taking all of them. Vertical, horizontal, and regional. There are three ways through which the temperature distribution can be studied. Note that very well. Through a vertical means, through a horizontal means, and the regional aspect. Now, see here. When I talk about vertical, please remember this. In the previous lecture, we have already explained you how the temperature variation across the atmosphere takes place. Like the temperature decreases as you move up in the region of troposphere, in the stratosphere increases, mesosphere decreases, and so on and so forth. You had studied this. But I am not going to talk about all these things. My major concern over here is going to be the troposphere, because I know that very well all the climatic changes that take place are in the troposphere, right? The cloud formation and all. Now people will say stratosphere also has clouds. Yes, it has stratospheric clouds, which are lesser of a concern for us with respect to the climate change here. Troposphere is the one which has all the important climate and weather activities that are taking place. So now, though when I talk about vertical, this is also to be known by you and should be mentioned, because this is the vertical distribution and the changes of the temperature that take place. But over here, we have to talk from the perspective of with respect to troposphere now. With respect to troposphere. Why? Because this is a major region where climatic changes and the weather activities take place. Now see, temperature decreases as we go higher in the altitude. You know that very well. And the rate is also explained in the troposphere. The normal lapse rate, that's a decrease in 6.5 degrees Celsius per 1000 meter. What is the reason behind it? Please understand, as you move higher, the density of the air keeps on decreasing first. Second, dust, water vapor, etc. are of minimal value. Please understand that water vapor especially is a very important factor for absorbing the heat, right? For absorbing the heat. As you move higher, the water vapor is almost in a very less or minimal or not even present. That is why in the lower layers it is present, so that is why you realize the temperature is relatively higher. It acts as one of the factor. Next is terrestrial radiation. Now, terrestrial radiation is more active in the lower regions. So that is why as you move higher, you will realize that the temperature is going to decrease, and this is the rate that is observed. Now, the processes that are involved when we talk about the vertical distribution that is taking place of the temperature, it is conduction, convection, and radiation that you've already studied. Along with it, you know that we have not mentioned advection here. Why? Because we're talking about horizontal right now, right? We're talking about horizontal right now. So, vertical distribution is conduction, convection, and radiation. Clear, everybody? Please note it down. Please note it down. This is basically with respect to the troposphere that takes place. Okay. Now, next, horizontal distribution. Please understand, before I do the horizontal distribution, there are certain things that you should know. I'm going to use a map which is present in your NCERTs also. The two maps with respect to the world, with respect to January month and with respect to the July. Before that, you should know, let me show you a map. Do you realize these lines that I have mentioned, drawn? All these lines are mentioning temperature. Like this is 25, minus 25, minus 12.5, 0 degree, 10 degree. All this is complete 10. This is known as isotherm. Isotherm basically refers to lines joining places having equal temperature. All the line which is joining, that means all the regions that are lying on that particular line have the same temperature which is mentioned. So isotherm refers, therm means temperature, iso means the lines joining the places having equal temperature are isotherms. Now see, let us take, this is the month of January I mentioned here. Now there is a question that was asked even in this year's prelims on this particular topic. This particular map which I have drawn in front of you, handmade, question was asked on this. Right now, you understand the utility of the chapter which I'm teaching you. See the map here. Let us analyze certain things. This is minus 25 degrees Celsius, right? This is below that is minus 12.5 degrees Celsius. This is 0 degrees Celsius. This is 10 degrees Celsius. Shift is there. Just observe the path, the way it is moving towards the northern side in the Atlantic Ocean. 20 degrees Celsius. This is the thermal equator. Thermal equator means, this means that the average temperature is maximum over here. That is why it is the equator. Clear? 20 degrees Celsius here again, 10 degree and 0 degree. So these are lines. That means the lines joining equal temperature. That means this is the lines, that is isotherms. Quickly have a look here. Clear? Quickly have a look here. Now what do you see out of this? Do you realize there are certain observations that can be made? I would request you, if you are seeing this lecture, possibly can you open your NCERT also for seeing this map, possibly because it will take some time for you to draw. Otherwise, you can use your NCERT or pause this video or make this map. If not, now understand it. I would advise you to open your NCERT while you are seeing this particular part. Why? Because you will be understanding while I'm teaching you. There are certain things you can observe. Why in the Atlantic Ocean it is moving northward? Why in the continent wise it is moving southwards? Why do you see there is a lot of curving in the northern hemisphere, but it is almost parallel to the latitudes in the southern hemisphere? Do you see these observations? This is what the question was asked in the preliminary examination. See here. With respect to January, generally the isotherms are parallel to the latitude. So if you see, if there were no continents, almost the isotherms would have been parallel. But it is because of the presence of the land masses in large number in the northern hemisphere that certain variations are being created. See here. Isotherms are parallel in the latitude, but deviation is more pronounced in January than in July. First of all, you will see this. I will show you both the maps. One understanding is because in the month of January, you will realize that there is more deviations that take place of these isotherms than in July. We'll see that. We'll see the reasons also. Deviation is more pronounced in the northern hemisphere because it has more land surface. Now you will say why? Please see that the ability of a land to heat, cool, or for the water to heat or cool or to move also varies. That is why when there is more land, supposing this region is receiving insolation, this region might get heated quickly, but this water surface will, let us say, take time, or let us say the water might be move along with, let us say, some ocean currents and all. That is why when we say the specific heat capacity basically varies with respect to land and the ocean. Now, when there are more land over here, there is going to be more deviation also. Over here, lesser land is here, so that means there is more parallel to the latitudes. Now see here, isotherm deviate to the north over the oceans. Now you see here, in the Atlantic Ocean, why the isotherms are moving upward? Over here, there is Gulf Stream, a warm ocean current, which is moving towards the northern hemisphere. It carries warm water along with it. Along with it, not only the Gulf Stream, but also the North Atlantic Drift. Now, these both of them basically carry warm water upwards. That is why it raises the temperature of the water that is present in these regions. That is why it basically moves upward. Now, let us imagine 0 degree over here because of Gulf Stream has taken a warm temperature from the equatorial region to the this part. It is 0 degree here, so that is why it curves upward. But land mass will be very cold over there, so that is why it has moved down to match. This is a 0 degree. It has moved down because the land gets heated also cool and cools also cool faster rate. But in the land, if you realize, these regions are going to be very cold, so that is why it cannot be straight. 0 degree will be over here, that is why it curves down. So we see North Atlantic and the Gulf Stream that basically leads to the isotherms moving upward, because these currents will basically take the water upward. It will take the warm water upward, increasing the temperature of this region. So the isotherms deviate north over the ocean due to the presence of warm Gulf Stream and the North Atlantic Drift. This is something that you should be aware, and this was a question that was asked also. Clear? Next is, over the land the temperature decreases sharply and isotherms bend southward. As let us say cross the ocean, as you cross the ocean, immediately it has to bend down because 0 degree will be here, not here. Because Gulf Stream has taken the temperature over here warmer, but over here this is land. This is going to be cold here because it is in the high latitudes. That is why it has gone down. It moves towards the south in the continental regions, right? Similarly, if you see over here also, and over here it has gone up. Clear? That means the Gulf Stream is diverting the parallel path which would otherwise have been. Clear? Okay. The effect of ocean is well pronounced in the southern hemisphere, so isotherms are more or less parallel. So you realize in the southern hemisphere there is lesser of land. That is why it is almost parallel. Little bit of land is there, so little bit diversion is there because of the ocean currents. Otherwise, it is more or less parallel in the southern hemisphere. Clear? This is what is explained here. Now comes July. Now if you see during the July time, the impact that is caused by the Gulf Stream and all is not pronounced, because already this region over here, sun is receiving, let us say, a lot of direct rays over here. So that is why you realize that sun is already receiving a lot of sunlight over here. So you realize the impact of Gulf Stream as such is not so pronounced. That is why if you realize already heat is over here, that means 10 degrees, 20 degrees. So it is almost parallel if you see. Almost parallel. That is why, because in the month of January, the northern hemisphere is very cold. So the effect of Gulf Stream is more pronounced. That is why it leads to more of the deviation taking place, otherwise which would have not taken place. That is why in July the isotherms are generally run parallel to the latitudes. Clear? Okay. Now we have done the vertical distribution, horizontal distribution. Let us take the regional distribution. Now see, it is very simple, which you have done in class also. Tropical, this is known as a tropical zone. From 23.5 degree, this is known as Tropic of Cancer, 0 is equator, 23.5 is Tropic of Capricorn. Between these regions, you realize that this receives a maximum insolation, and that is why it is known as tropical. Let me make it very clear that it is not exactly the tropic equator which has a maximum temperature, because close to this regions you will realize will have relatively higher temperature also in insolation, because at the equator, the cloud cover is also very high. Clear? That cloud cover is also very high. But leaving that apart, because this is a simple classification, this is known as tropical region. This is known as temperate, lesser, more colder region. Polar zone from 65.5 degree to the North Pole and 65 degrees south to the South Pole. So this is known as a polar zone. It is basically more temperature, lesser temperature, or the least temperature there. So this is known as a regional distribution with respect to the temperature which we are talking about. Clear? Okay. Next comes temperature inversion. Now please understand a very simple and the last topic that we are doing here. Normally what you see is, let us take, normally when you move higher, let us say altitude, what will you see? The temperature will decrease. Normally, leave the temperature inversion topic for 2 minutes. Normally when you move higher in the altitude, there is fall in temperature, right? Fall in temperature. I'm talking with respect to troposphere right now. Please understand this very well, right? Fall in temperature. Now this temperature is basically referring to as a normal lapse rate, which is 6.5 degrees Celsius per 1000 meters, right? Why? Because you realize that if supposingly a surface is being heated, the warm air again will rise. The warm air rises, the warm air will start cooling. This is the normal process of the, let us say, the convective activity that takes place. Now, what is a simple instance of understanding is, from this is, can I say, if supposingly there is layer within the troposphere, let us say this is basically referring to troposphere. Let us see this. Supposingly this is troposphere. Can I say that this region is what? Some temperature is going to be there. As you move ahead, the temperature will be decreasing. So as you move upward from this layer, moving up is basically temperature decrease. Because the upper layers are colder also, so there is an easier mechanism to move up also. Clear? Because the lower layer, let us say, are literally warmer, and as it moves up, the temperature keeps on decreasing. This is the general phenomena. Now, supposingly a scenario happens that there is a layer above certain layers which is of warmer nature. Please understand this. Supposingly if I say there is a condition where a warm layer is existing above a colder layer. Now this warm layer is existing above a colder layer, which will restrict the movement of the air upward also. So in this process, you will realize instead of the temperature decreasing as you move upward, there is instead an increase in temperature for a small time. This inversion that is taking place is referred to as the temperature inversion. Let's see here. Supposingly this is the Earth's surface in white, right? This is the height I'm talking about. Now, supposingly there's a condition where it was extraordinarily cold on the surface of the Earth. Let us say there's a lot of snowfall. That means that this surface is very cold. Possibly the layer which is, let us say, few meters above that is not as cold as the one which is adjoining the layer which is adjoining the Earth. Can I say in that particular case, let us assume this, supposingly this particular, let us say this particular are air molecules over here. These are in contact with this white surface, that is the Earth's surface. Let us say it is very cold snow surface. This particular region will become very cold. Now what happens is, this is much more colder than a layer which is above it. That means we realize that there is a warmer layer lying above a colder layer, something reverse of what we have studied. So if I draw a temperature graph, you will see that there is increase in temperature because of this layer, which is actually inversion. Then after that, the temperature will decrease because it will follow the normal pattern. But over here, there is inversion taking place. That is why you realize sometimes when temperature inversion takes place, which you see in Delhi, there is a warmer layer that is lying above a colder layer. That is why in the winter, once it happens, the air is not able to move upward. And that is why whatever the pollution, smog that is trapped in this layer. That is trapped in this layer. And that is why you cannot basically move out of that region, because the pollution is trapped because of the temperature inversion concept. So temperature normally what happens is decrease as you move up. But if there is an inversion, that means there is a warmer layer above a colder layer. It is known as a reverse condition. We also call it a negative lapse rate. Negative normal lapse rate also is called. So this is a simple phenomenon. Again, when we go in the further chapters, we will realize that temperature inversion is of various categories, various types. It is associated with even the valleys. It is also associated with frontal activities, also a lot of things. These are simple concepts which is explained, which you should know. In this condition, long winter nights, cloudless clear sky, dry air, snow-covered mountains, snow-covered grounds are helpful in the creation of these temperature inversion conditions. Clear? This is something that you should be aware of. When we're talking about this particular topic, the first thing that comes into our minds is, what is atmospheric pressure? When we study these atmospheric pressure definitions, this you would have already studied in your geography sessions while you would have been studying in your school, or even in the physics chapter, or if you would have studied physics in your school days. This is something very common, but let us understand this also. See, what is atmospheric pressure? It is defined as a total weight of a mass of a column of air per unit area at a sea level. Now let us assume this is a sea level. Now, if you are standing here, this, let us say, a column of air, that means some form of weight is being exerted by the air also. So what does it mean? The total weight of a mass of column of air per unit area at the sea level. So what is the weight being exerted? This is referred to as the atmospheric pressure. That is why you realize that your atmospheric pressure needs to balance the blood pressure also. So the balancing stuff is there, then only you can basically survive. Otherwise, what happens? When you go to higher altitudes, over there the atmospheric pressure decreases, but your blood pressure is relatively what it used to be. That is why you have nose bleeding and all. Clear? So that is why this is the definition of atmospheric pressure. Now what it is? It is 1034 grams per centimeter cube or 1013.25 millibar of mercury. Now these are both things which are again standard, which you need to know. Now please understand, this is something very, very important. Vertically, 10 MB decrease per 10 meter of height is generally seen in the lower atmosphere. Now, this is a fact that is written in the NCERT, and you won't believe that this particular question has been asked in the PCS examinations repeatedly in the Uttar Pradesh PCS as well as Uttarakhand PCS. And this has been asked in your UPSC Prelims also long time ago. So with every 10-meter height, there is a decrease of 10 millibar, right? Now, this is something that you should be aware of as a fact. Now, this is applicable in the lower atmosphere, obviously. So this is again, you should remember. Clear? This is what is atmospheric pressure. Having now understood this, let us come to the topic that we are studying here. Very often you hear low pressure, high pressure, low pressure, high pressure. Now, have you ever deciphered what these sentences or statements basically mean? Now, let us today decipher it and understand it in a very proper manner. Let us see a very simple example. Let us assume, students, supposingly this is a chair, right? Right? This is a chair. Now imagine yourself that this chair is made up of iron. What? Made up of, this chair is made up of iron. Clear? Done? If you remember this example, you will never be confused with the concepts of particularly this low pressure and high pressure, right? Get your logics clear, get your concepts clear. That is more important. Now let us assume you as a person sit on this. Supposingly you sit on this, right? Now what I do is, please understand, when you are sitting on this, when sitting, that means you basically sat on this chair. When sitting, you are exerting pressure. Pressure on the chair. Obviously you are, because you have weight. Now let us take a very simple understanding. What I do is, I light fire over here. What I do, you're sitting on that iron chair and I have put certain woods and I've lightened that. Now slowly, what will happen? The temperature of the chair will increase. What will happen? What will happen? Temperature will increase. Yes. Now just tell me one thing. Till the time the temperature was fine, you were sitting, you were enjoying yourself sitting on the chair. Now I have increased the temperature. This will heaten the chair, iron chair. Yes. Now do you realize after some time you will start feeling hot? What you will do, you will jump from that chair. What you will do? Because of the temperature increase, you will jump. Can I say when you will jump, there will be decrease in pressure on that particular chair, or there will be lower pressure what it used to be? Can I say when you jump, because of the temperature that have increased, now the pressure being exerted on the chair is much less, that means it is low. So can I say now lower pressure is existing? You will say yes, sir, because the temperature became high, and because of that it was unbearable for me or for you for that matter, and you jumped from the chair. What did you observe here? See, when the temperature increased, you, what did you do? You jumped. You jumped and went somewhere else. Yes? So what do you understand by this? In geography, what happens is, now this was a basic understanding which I wanted to tell you so that you understand from this analogy. What can we basically understand? I will go to the geography part, don't we need to worry about that. But what do you understand from this? You understand that When the temperature is increasing, something is rising and the pressure that was there is decreasing. That means low pressure is being created. Low pressure and high pressure are relative terms. Supposingly, if there is pressure of 1 millibar somewhere, another place it is 2 millibar. Again, this is low pressure, this is high pressure. Even if it is, let us say, 1000 millibar and it is 2000 millibar, then also this is what? Low pressure, high pressure. It is relative, right? It is relative. Now, what we are trying to say is you will jump. So that means decrease in pressure. Now, similarly, can I say something? Supposingly, this is some region. In this particular region, let us say this is some island or something, some place. If the temperature increases here, if the temperature increases, what will happen here? What will happen? The air present over here will get heated. The air present over here will get heated and it will rise. When the air will rise, it will rise over here. So it will create what? Low pressure over here because it has risen. So what will happen? A low pressure will be created here. Now you know something very well. Anything that has risen will go upwards. It might move here or there, whatever. But somewhere when it cools down, it will sink. When it sinks, it will create high pressure. Somewhat very similar to this. Supposing I have heated the chair, you have jumped. Afterward, it cools, you again sit. When you sit, you exert pressure. So what is here? Whenever there is sinking of air, that means it will lead to what? High pressure situations. Clear? Whenever there is temperature relatively increase and the air is rising, what does it do? It will lead to low pressure. Now, high pressure and low pressure both are relative. High pressure does not mean, supposingly, please understand this. If I say 10 millibar pressure and I say 900 millibar, obviously this is low pressure, this is high pressure, no problem. Clear? No problem. Second thing is, if I say 10 millibar and 11 millibar, then also this is low pressure and high pressure. High pressure does not mean it has to be high. It is a relative term in comparison to the other pressure to which you are comparing. So it is relative. One more thing you need to understand. Now, just see here, when the air has risen upward, this region has become vacant. So the air that had fallen down here will move here. This is at the ground. Please understand. This thing is taking place at the ground level. This thing is taking place in the upper troposphere. Let us say to a certain height, you can say, the upper in the atmosphere, let us say at some height. So this is what surface level. This is up in the higher in the atmosphere. Let us say 5 kilometers, 10 kilometers up, right? Can I say something? Air moves from a region of high pressure to a region of low pressure. What I'm saying, air moves. What is, say, see, simple word, air is stagnant, or moving air, let us say wind, or that means simple words, air only. It moves from a region of high pressure to a region of low pressure. Now you will say one thing, sir, how is it that over here upward, so it is moving from low to high? It is not low to high. Please remember, if you ever study in advanced geographical concepts, whenever there is low pressure here, there is a high pressure induced over here. When there is high pressure here, there is a low pressure induced over here. Here also from high pressure to low pressure. This is in the upper atmosphere, right? And over here also high pressure to low pressure. At the lower ground level, you see high pressure to low pressure. So there is a movement that is taking place. Movement of the air takes place from a region of a high pressure to a region of low pressure. So the movement from a region of high pressure to a region of low pressure. Why again understand? Because the region where temperature is high, relatively high, the air rises up. It creates a vacant space here. So some other air or wind will come here and takes its place. So that is why what happens, the regions which are for high pressure regions, because there is sinking of air, they will move to other regions. So they will move to the regions of low pressure. So in order to occupy that place which had become vacant. So that is why this thing happens. So what do you understand by low pressure and high pressure? Relatively, it is again relative concepts. Both are relative concepts. So this is basic understanding of high pressure and low pressure that you should be knowing. Clear? As I've explained you here also. Now, something again very important, isobars. You've already studied isotherms in the previous chapters. What do you mean isotherms were, what were isotherms? Isotherms were regions, these are lines basically joining regions having equal temperature. That was isotherms. When I talk about isobars, it basically refers to the regions having equal pressure, right? See here. These are referred to as lines joining places having equal pressure. Equal pressure. Atmospheric pressure. Now the important clause over here is that everything while we are dealing with isobars are reduced to the sea level. Bracket, reduced to the sea level. I'll tell you what it means. Reduced to the sea level. This is something that most books do not write, but you should know. Now please understand something. You said, what does this word mean? Isobar, we understand that regions having equal pressure or demarcation, it's fine. But what do you mean by at the sea level? Now let's see one thing here. Let's see this horizontal distribution of pressure in January. Now you know that very well. Let us assume this is an isobar. These are isobars. All of these are isobars. Now you know that over here, a lot of mountains might be present. There might be plains. There might be so many landforms and topographic features are present. Now, if we start calculating that fact with every atmospheric, with every landscape that is present, it becomes very difficult to compute it. So this map that is present in front of you assumes that all the regions are at the sea level. They are not taking into consideration the landforms that are present here. Landforms, that means mountains or plateaus that are present here, they are not taken into consideration. They are considered as almost equivalent to the sea level. This is a very, very important critical point that everybody should be aware of. UPSC long time ago had asked this question, as one statement was isobar and second was it is reduced to the sea level. So that means let us say mountain is present. We assume that mountain is not present at a sea level. So what will be the isobar? It is assumed that, so that it is easier to calculate also. Clear? Now, just a brief representation of these, because when we will study the further concept of the pressure belts, then it will become easier. But let's see. Horizontal distribution of pressure in January. You will see during the month of January, you realize that the direct sun is directly over the Tropic of Capricorn, right? So what happens is it has shifted towards the south. So this region over here has a relatively what? Higher pressure. Higher pressure. Now these regions are high pressure. So this is just a representation. Obviously this is referred to as ITCZ. We'll understand the concept of ITCZ also. So this is basic representation. And similarly, if you realize in the month of July also, the sun basically is directly over the Tropic of Capricorn. So this is a region where a lot of heat is being thrown. So that is why low pressure regions are being exerted over the land surfaces also. So this is a basic representation. We will be going into the detail, only then you can understand. Now, when you see these diagrams, or let us say these maps, it becomes relatively difficult to why these things are there, right? For this, you need to understand the concept of pressure belts also, how the pressure belts shift. Once you understand that, then this diagram, these isobars and maps become very easy to understand. Let's see them first and then we'll return to this point. Okay, first of all, when I'm talking about air and wind, you should understand what is air and wind. Air simply means stagnant. Wind means air in motion, right? When the where air is moving, that is wind. So sometimes people say air moving, it is not incorrect, but the more precise word is when moving air is called wind. Clear? Now the question arises is when we are talking about so much about pressure system and all, pressure belts and all, which we're going to study now, we should understand what are the factors that are impacting the winds also. Only then we can understand the concept of pressure belts, which we'll be studying. Now please understand, what are the factors impacting the wind motion? First topic is pressure gradient. What do you understand by the concept of pressure gradient? A very, very important concept. Now see, what does it mean? It refers to the rate of change in pressure per unit horizontal distance. See, let us understand this. What are these yellow lines? What are these yellow lines? These yellow lines are isobars. Yes, isobars are representing regions having equal pressure. So let us assume this region, this yellow line is 1020 millibar, right? 1020 millibar. This is 1016 millibar. This is 1012 millibar. 1008 millibar. 1004 millibar. First thing, tell me, which region has high pressure? 1020. This has low pressure. So by default, you know that wind will be flowing in this direction. Do you realize these isobars are very close to each other in this region, but over here they're far off? Yes, these lines, yellow lines, are very close to each other over here, but they're very far off from here. The motion of the wind is from which direction? From a region having high pressure to a region having low pressure. So by default, this is high pressure, this is low pressure. The wind will be moving in this direction as shown here. Agreed, no problem. But what I am referring to over here is a pressure gradient. Pressure gradient means the rate of change of pressure. Now, when the pressure gradient is high and whether the pressure gradient is low will be influenced how close the isobars are. Over here, do you realize that within this small distance, the pressure, these isobars are very close and it is changing from within a very small span of distance, the pressure is changing very rapidly. So that means the rate of change of pressure when this horizontal distance is very fast. So it means that the pressure gradient is very high. The wind speed is also going to be very fast. Right? So see here, over here, what is going on? In this huge distance, the pressure is again changing, but the distance is very huge. So the rate of change of pressure is less in per unit distance, right? So what will happen? The speed of the wind will be relatively low here. Again, understand this. When I talk about pressure gradient means the rate of change of pressure. So over here, this is also 1020. This is also 1016 as I have mentioned here. 1012, 1008. 1008. This is 1004. Same isobars, right? Same isobars. But what do you see here? Here within this small distance, the change has taken place. Over here, such a long distance. So the pressure gradient is high over here. It is low over here. So the wind speed is going to be very high here. Wind speed is going to be very low here. So pressure gradient refers to the rate of change in pressure per unit horizontal distance. Now what happens? Higher the temperature difference, steeper the pressure gradient, and faster the speed of the wind. Clear? This is pressure gradient. Now let us move ahead. Coriolis force and Ferrell's law. Now these two concepts are very, very important. 99.9% students confuse this when they write the statement. What I have written on the board, please make sure that you understand it well. Firstly, many people when they're writing their answers about Coriolis force, they tend to mix with Ferrell's law. And that is where the problem starts. In the civil services preliminary examination also, they can ask you, which among the following is basically solely dedicated to Coriolis force, a Coriolis effect? See, why sometimes people say force, it is basically an effect and outcome of the rotation that is taking place, right? So it is sometimes not even called as a law also. So please understand, it only says certain statements, the other statements are added by Ferrell's law. See what is the difference here. Coriolis force or Coriolis effect is basically an outcome of the rotation of the Earth. First of all, it is an outcome or effect of the rotation. What it says is, it simply says that the force of deflection due to rotation of the Earth. That means it says simply, because of the rotation of the Earth, when the wind is moving, there is deflection. It does not say anything right, left, this and that. No, please understand this very well. There are certain books who have written it completely wrong. The actual description is that it basically says that there is, due to this effect, because what is this effect? Rotation of the Earth. There is deflection of the deflection, or let us deflection in the direction. That means the direction which is moving, it is deflected. It does not say anything else. Further, it affects the wind direction, not the wind speed. It is maximum at the poles. This is the only thing that is mentioned by Coriolis force or Coriolis effect. Now the concept whether it is deflecting towards the right or whether it is deflecting towards the left is mentioned by Farrell's law. Clear? So what is basically Coriolis force? Coriolis force is basically an outcome of the rotation of the Earth. That means it says when the wind is moving due to the rotation of the Earth, it will be deflected. What is the deflection not being mentioned? Now see, understand Farrell's law. Now Farrell's law is basically explaining you this particular diagram which you need to understand. What it says, see, I'm mentioning the exact statement, what Farrell basically stated. If one stands with his back towards the wind direction, let us see this. Supposingly, this is a man, right? And this is his back, right? This is his back. He's looking this way, looking forward, right? Looking this way. Right? So this is his back. Now what is it saying is, if one stands with his back towards the wind direction, that means the wind is blowing from this side. That means if I'm standing here, the wind is coming in this direction. It's coming from my backside, right? Coming from my backside. So that means on this backside, it is moving, right? So from my back, the wind is coming. The wind is deflected to the right in the northern hemisphere and to the left in the southern hemisphere. Now, supposingly, if this man is standing in the northern hemisphere, the wind which is coming will be slowly deflected towards the right. In where? In northern hemisphere. And if he is standing in the southern hemisphere, it will be deflected towards the left. In the northern hemisphere, left in the southern hemisphere. In the southern hemisphere, right? Now you need to understand something in simple words. What does it say? Supposingly, in whichever direction you are moving, you have to deflect towards the right, if you are in the northern hemisphere, towards the left in the southern hemisphere. Let's see here. Can I see that supposingly this is the direction in which the wind is moving. But this is what? This is the northern hemisphere. This is what? The southern hemisphere. What does Farrell law say? That it is, if the wind is moving, right, it is deflected towards the right. So what happens? It is deflected towards this right. Now supposingly the wind is moving in this direction. It is deflected towards its right. You forget, just when you are in the northern hemisphere, you just remember this, that whichever direction you are flowing, you will turn towards the right. Similarly, supposingly the wind is moving in this direction. See here. The wind is moving in this direction. It will be deflected towards its right. Now the wind is moving in this direction. It is deflected towards its right. So do you realize in the northern hemisphere it is deflecting towards the right. In the southern hemisphere deflecting towards its left. Now see here, if the wind is moving in this direction, it is deflected towards its left. If it is moving in this direction, towards its left. This is what is Ferrell's law. What happens is many people tend to write all this statement for Coriolis only. But see, you need to, people generally tend to, if you're writing also, you need to mention very categorically, this is Coriolis effect and this is Ferrell's law. I hope it is clear to everybody. This is a very basic concept and this is why you should be understanding. This is something that are repeatedly asked in your examinations. Let's move ahead. Frictional force. Now you know that very well. You know what is friction. Friction is basically resistance to the path of the motion that is taking place. Every single body that is present, if I am walking over here also, there is friction between the shoes that I am wearing and the surface. That is why I am able to stand, otherwise I would slip. Similarly, when the wind is moving, you know that very well there is going to be friction, particularly which are in the lower altitude, because there are going to be trees, there are going to be buildings, there are going to be a lot of stuff which is going to basically impact or resist the movement also. So see here, the force exerted by the Earth's surface which slows down and modifies the wind direction. Obviously, supposing there's a building here, or the wind is coming, it's going to hit, it's going to deflect. If there is, you very well know in case of the Himalayas also, if the winds are coming, if the moment a barrier, supposing any mountain barrier also comes, it is going to get deflected to the either directions. It works opposite to the direction of the wind motion, obviously, because why it works opposite? Because it is a resistance force. Strongest near the surface, decreases rapidly with height. How does it decrease rapidly with height? Because you know that very well, the trees, the buildings, and all those landforms are not present after a certain height. So let us assume here, that this is the movement of wind that is taking place at certain height from ground base till some kilometers high. Okay? Now what happens? Supposing at the base level, you have what? Certain buildings here. You have certain trees here. So what is going to happen? This will again be deflected some direction. It is going to be deflected certain direction. But over here, as you move beyond certain height, the resistance forces will obviously decrease. So this is again what is friction happening. Obviously, when there are so many landforms also, they are also impacting it in various ways. Okay. Last comes centrifugal force. Now, centrifugal force is an outward force. Centrifugal force is an outward force that appears due to the air moving along a curved path. It tries to push air away from the center of curve. Now, supposingly, some wind is moving in circular path. You know that whenever you are moving in a circular path, there is an outward force that is exerted at every point. This is known as centrifugal force. Centrifugal force, right? Okay. Now comes the next very, very important integral part. This is again the latitudinal distribution or the pressure belt systems. Now I'll just explain you one thing very clearly. This is the diagram which you generally see in most of the books when you are reading also, and most of the books when you have been studying since I think class 6 also, and even before. These pressure belts that you see are not as they are represented here. Actually, when you see, these are like these broken patches or in certain groups, not in continuous blocks. These are not continuous lines pressure belts. These are like these, right? Broken patches, broken areas, because to simplify it, we have drawn it in this manner. And we're continuing with this manner only just to understand it. Now, please understand these things. Every single pressure belt that is drawn here, I'm going to explain it also. Don't need to worry. Just quickly, when you are understanding, note these down. Again, these are please understand, when we are mentioning these latitudes, they are not exactly mentioned here, present here, because you know these are not simple zones. They might be broken, they might be twisted, they might be shifting up and down. And please understand, because you know the tilted axis of the earth, and along with it, you know that during the summer times or during the winter time, we see that the sun rays are horizontally over, let us say, over Tropic of Cancer or Tropic of Capricorn, or for that matter, over equator. There is shifting of pressure belts also. So we will be seeing that also. The shifting also happens. It is not fixed. It is just a simple representation that we are seeing here. So what happens generally, between 5 degrees north and 5 degrees south, there is equatorial low pressure. Between 25 to 30 degree, there is a subtropical high pressure. I'll be explaining you the reasons. Between 60 to 65 degrees Celsius, there is subpolar low pressure. And on the top, there is polar high pressure. Polar high pressure. Similarly, it exists in the southern hemisphere also. Now, please understand this thing. If you know that very well, I had told you, winds blow from a region of high pressure to a region of low pressure, right? And the winds which we talk about, some of them are the surface level winds, some are higher, upper atmospheric winds. You remember that? Why do these upper atmospheric winds flow? See here. These are surface level winds and there are upper winds also, upper atmosphere winds, because you have to balance this. If these winds, let us say the wind is blowing from here to here, because let us start here. If there is low pressure, it will rise. This is vacant space. So some other region, from some other region, the wind will come here from a higher pressure region. Similarly, this region has become empty, so it is moving and it will sink because it has cooled. So this is the two systems work together. One, the surface level winds, and there are upper winds, which surface level winds you can perceive also. Like you can generally aware, we are generally aware also, we read of this. The higher atmospheric winds are something geographically you study because these are not visible also. Now what we see is, not visible is not a correct word, not perceptible, you can say, because we cannot see air also as such. It is perception that we talk about. So see here, let's see. When I am talking about these winds, trade winds, westerlies, easterlies, these are surface level winds. What? Surface level. Now see it from the side. Firstly, I will tell you why these high and low pressures are created. Firstly, see the diagram and analyze it. I will be telling you why these high and low pressures are created. Leave that. Right now, just understand from a very simplistic perspective. Supposingly, this is a high pressure region and this is low pressure. So by default, you realize there will be certain winds will be moving from high pressure to low pressure region. So these winds which are moving from the high pressure to the low pressure regions, because they're coming from the northeastern direction, these are known as northeastern trade winds. Subtropical high pressure. From here also, some winds will move to a low pressure. So this is moving from the southeastern direction. This is known as southeastern trade winds. But you realize this, if there is high pressure, there is low pressure here also. So some winds will be flowing here, some will be flowing up there also from the high pressure, so from high pressure to low pressure. So these flowing from subtropical high pressure to subpolar low pressure are westerlies because they're flowing from the west. Similarly, westerlies over here. Now you know there is high pressure over here, this is low pressure. So from that cold region, there are certain winds blowing, those are known as polar easterlies because of the east, from there coming from eastern direction. That is known as easterlies. So these are what you are seeing, easterlies, westerlies, trade winds. These are surface level winds which you are talking about. Now, in order to compensate that, you have higher level winds also. See here. Supposingly, this is moving in this direction. These winds are surface level winds. So this is also surface. Now, when this is surface, you realize this is low pressure region. There will be air will rise. It will move. Now do you realize this above the trade winds? This is moving in the opposite direction. This is moving there, trade winds. Upper air winds are moving in the opposite direction. So these are also known as anti-trade. Above the trade winds in the upper atmosphere, the compensatory winds or the ones which are going in the opposite direction to compensate for the space that became vacant, those are known as anti-trade. So these trade winds are surface level, then they over here, when they move here, they rise because of the low pressure, and then they move here, then again they sink. Similarly here, now you will say why it is rising. Please understand. This is the region because it receives a lot of insolation, lot of heat. So there is very high temperature here. It will rise, right? So that is why the air will rise. Now when it will rise, it will diverge. It will move, some will move in the upper direction, some in the lower direction. So please understand, right now these words which I have mentioned, I'll explain you. Now it will move, go down. Now because of the sinking of the winds, there is high pressure here. Similarly, high pressure, it will move here, it will move here. Then again rise here because it is low pressure. Now the problem that arises is most of you will ask her how this high and low pressure are being created. Understand this now. Equatorial low pressure, this equatorial low pressure, you know that very well. At the equator, there is a lot of insolation, right? That is why this low pressure is induced by what? Because of the thermal factors. Thermal, that means heat. Majorly due to the thermal reasons. Thermal reasons over here means due to the insolation that is received from the sun. The temperature rises tremendously, and that is why it leads to rising of the air. When the air rises over here, it creates low pressure. So hence the surface winds or trade winds converge. Now see, understand here. Over here you realize these winds rise, these move. Now you realize that I'm showing you equatorial low pressure, but do you realize when these northeast trade winds and southeast trade winds will come, they will converge. The region where they are converging is known as intertropical convergence zone, ITCZ. The surface winds are the trade winds, converge. This zone of convergence is known as intertropical convergence zone. Clear? So that means the equatorial low pressure is created because of the thermal factors. Done. Now let's see. Subtropical high pressure. Now why is this subtropical high pressure created? This is something very interesting. Actually, this is created because of the dynamic reasons. What is this dynamic? Did I tell you something? If I intentionally make you sit on a chair, that iron chair, there will be pressure exerted on that particular chair. Though I have forced you to sit, then also there is pressure exerted, that is high pressure on that particular chair. Similarly, please understand, because of the high temperature in these regions, the pressure basically decreases because there is rising of these air. Now you know that very well that these anti-trade winds are moving in the upper atmosphere in order to compensate for the vacuum vacuum would be a wrong word, in order to compensate for the space that is left vacant by the trade winds which have flown from this region. So these will go and sink in this particular region. Because of this sinking, a high pressure is created. That is why subtropical high pressure is due to dynamic reasons, not directly thermal, formed due to the subsidence of the anti-trade. What are these? These are anti-trade because it is opposite of the trade winds flowing in the upper atmosphere. It is flowing and subsiding down. When it is subsiding, that is moving down, it is exerting pressure. That is why high pressure here and high pressure here. Clear? Now comes subpolar low pressure. You'll be thinking, sir, it is a cold region. How can low pressure be created? Because you had mentioned that low pressure is associated with temperature. Over here, low pressure is not associated with temperature. We'll see this also now. Subpolar low pressure is formed due to mechanical reasons. See, these points you will study when I'll be teaching you fronts concept after about a few minutes. Not directly thermal, but due to the formation of atmospheric fronts along with warm air mass forced to rise, causing the low pressure. What happens is, we will be studying the concept of air masses. What happens over here is, see, the concept of the front formation takes place. Over where what happens, see, where the warmer air is forced to rise, causing low pressure. Supposing this is a warmer air, a colder air is coming. It is air masses. We'll study that concept. Because of that, the warm air, because of that, is pushed up. Why it is pushed up? Because colder air is more denser. So warm air will be pushed up. If the warm air is pushed up, it is a mechanical force due to which a low pressure is being exerted or low pressure is being formed in that region. That is why the reason where subpolar low pressure is created is because of the mechanical reasons, which we will see in the topic of fronts when we will be going there. But when I talk about polar high is because it is such a cold region, such a low temperature is there. So that is why high pressure is created there. So polar high is due to thermal origin because of the low temperature. So what do you see over here? Now what you have understood? You have understood why equatorial low. Now let us revise it again. Equatorial low pressure is created for the reason that because of the thermal impact. Thermal impact means because it is receiving sun rays throughout the year, and that is why the temperature is high, and the temperature high means that there is the air over here will rise vertically upward. If it is rising vertically upward, what is happening? The low pressure is being created. Now when low pressure is being created, so this is why it is equatorial low pressure. Now the equatorial low pressure is created, so from the surrounding regions, the winds will come to take that place. Now these winds which are coming are northeast trade winds and southeast trade winds. Now when the air rises over here, obviously it will move in either direction because it cannot go beyond tropopause, you know that. It cannot go beyond tropopause. So it will move in this direction. After rising, moving in this direction. After some time, it will cool and subside. Where it's subsiding is creating a high pressure here, creating a high pressure here. So that means the high pressure created in these the 25 to 30 degrees north is or south is because of the dynamic reasons, because of the subsidence of the anti-trade. When you go to the subpolar low pressure, it is because of the creation of fronts where the warmer air mass, which we will be studying, is basically forced to rise because of the colder air mass. Because of that rising, there is a mechanical action that leads to the formation of low pressure here. The polar high or high pressure is created because of the low temperature that is present. Very low temperature is basically leading to high pressure. Similarly, as low temperature leads to as high temperature leads to low pressure. Similarly, very high pressure leads to just to correct it, when a very low temperature leads to high pressure, very high temperature leads to low pressure in a normal sense. Obviously, there can be when mechanical forces or dynamic forces are acting, there are changes. Similarly, that is why as thermal factor is important here because of the high amount of insolation that is being received. So high insolation, high temperature leads to low pressure. Low insolation, low temperature leads to high pressure. Clear? Okay, so we have done. This is a basic representation how it actually appears on the map also. Let's move ahead. Now see this very well. This is tricellular meridional circulation. A very simple version of what we had done over here. This is also Headley, Ferrell and Porelcel I've already mentioned here. If you see over here, do you realize I've just taken the northern hemisphere? Do you realize this, that these are northeastern trade winds moving? And over here, you saw the air rising from the low pressure region, equatorial low pressure, moving. These are what? Anti-trades. What are these? These are anti-trades. And it is then sinking down here, creating a high pressure over here. So you saw here, subtropical high pressure, right? Subtropical high pressure. So over here, subtropical high pressure is being created. So this box of circulation is known as Headley cell. Headley cell. Similarly, if you see over here, these are westerlies at the ground surface. Similarly, see here, westerlies. It rises over here, then moves and then sinks over here. So this is known as Ferrell cell. This is known as Ferrell cell. Similarly, over here, we saw what? The polar easterly is moving because of low pressure rising, because of the front creation, and then moving upward and then sinking. So this cell is known as the polar cell. This is how, in a way, you realize this, that concept can be asked also. This is the way circulation is taking place, right? Heat energy is also being spread to the various parts also. So this is something very important that you should understand. Similarly, it's taking place in the southern hemisphere. If you have understood this, it is easy to understand this also, right? Now, important. You know that very well. This is how the wind belts shift. I have marked here 5 degree, 25, 30, 35, 60, as we have seen over here, right? So I've simplified this by making this particular diagram. See the middle one. The middle one is at the time of equinoxes. Equinoxes means that when the sun rays are vertically over the equator, which is on 21st March and 23rd September. Now, you see the wind belts are moving in this manner. These are what? The trade winds. These are what? Again, so this is a similar manner which you have studied. See, if you see here, what are these? The trade winds and westerlies. We have taken this part only. Similarly, what you see? These are what? The trade winds and these are the westerlies. Clear? Now, you realize that during the time of 21st June, you realize that the sun rays are directly over the Tropic of Cancer, northern hemisphere. So the wind belts will shift upward. Now you see wind belts have shifted a little bit upward. During the time of December, you will realize this, that the sun rays are directly over the Tropic of Capricorn in the month of December. So sun rays will be falling directly on the Tropic of Capricorn. So the wind belts will shift a little southward. Now, why this shifting is very important is, please understand, this impacts the weather conditions of various regions. One question that is repeatedly asked in the civil services preliminary also and mains also. One question, please understand. Why Mediterranean region, which lies between 30 to 45 degrees, western parts receive rain in the winters? See here, 35 to 40. Now see here. If you realize over here, this is December. Now Mediterranean region is receiving rainfall during the month of December, but not during this time of summers. What happens is, during the time of summers, the Mediterranean region, which is between 30 to 40, comes under the influence of what? These winds, trade winds, which is not actually giving them rain. But on the other hand, when during the time of winter, they come under the influence of these westerlies. And because of that, they are carrying some water or moisture, and their western parts are basically coming under the influence of giving them rain. That is why the western parts of the Mediterranean region receive rain. This question which I mentioned over here, I want the answer also written in the comment section. Let's see what you answer. This question has been asked also repeatedly. Just analyze the pressure belts again. I said 35 to 40. Now, do you realize during the summertime, it is this part. So rain will be received during that time. Over here, it is coming under the influence of the westerlies, right? Westerlies. So that westerlies are basically carrying rain from the oceans or seas, and they're full of moisture, and they give it to the western parts of the Mediterranean region. That is why they receive the rain. Clear? So I want this answer, let us say in few lines written in the comment section. Let's see how you write the answers. I will be commenting and replying to the answers also, right? Okay, let's move ahead. Let's see the local winds. Now, when I talk about local winds is a very simple concept, that they are located to a certain region and impacting a certain particular region only. Questions have been asked repeatedly on these. So these are wind systems which are generated purely by the local factors, and zone of influence is quite limited. That means when I talk about trade winds, westerlies and all, these winds are on a massive scale. On the other hand, these are local winds which will be influenced very small regions. Over here we see land and sea breezes, mountain and valley breezes, and other local winds, which I'll be showing you on the map. When I talk about land and sea breeze, let's see. If you understand this, it will be easier to understand the other concept also. During the daytime, you know that the first you should understand if you want to understand the land and sea breeze. This is again very simple, you have done in the schools also. Land has a property that it heats also very quickly and cools also very quickly. Sea takes a lot of time to heat also and cool also because of the specific heat, right? During the daytime, you realize that the land heats up very quickly. It's heat up, so what will happen? The temperature becomes very high quickly. So the air over here will rise. When it will rise, it will move to this direction. Why it will? Because this, see, when the air has risen from this region, it becomes vacant here. So obviously, wind from some other region will come here. That means wind is basically blowing from sea to the land. That is why it is known as sea breeze. So that is why while it is moving here, the air rises here, moves and then settles down. Moves here and settles down. So this is again what is sea breeze, because the winds are moving from the sea to the land, because during the daytime it heats very quickly. The reverse happens during the night time. The land cools very quickly. So that is why you realize it's moved from this direction and the opposite happens. This is what is the land breeze, where the air is moving from land to the sea, and this is what is the representation. Why? Please understand, this is also relative. During the night time, the land becomes more cold. The sea is relatively warmer. So it is again relative. Over here, just a minute. Over here, what happened? During the daytime, the land got very hot. So the air rose up. The sea took a lot of time, because it will take a lot of time to the temperature to rise, right? It will take slowly. But land will become very hot. So that is why air rose over here, and this is the direction. And movement from movement of wind from sea to land. This is the major important thing, sea to land. On the other hand, during the night time, the land becomes very cold because it gives out heat very quickly, but the ocean or the sea is warm. So because relatively it is warmer, the air is rising up, it is moving in this direction, settling down. So the movement of air is from land to sea. Because it is from land to sea, it is known as land breeze. Clear? Okay, clear everybody? Land to sea. Let's move to the next thing, mountain and valley. Now please remember, during the daytime, these valleys and all also become very hot. Very hot. So what happens? The wind, or let us say the air, basically starts moving upward. Because why? It is heated. So it will rise. So this rising of this particular wind over here across the valley upward is known as the valley breeze. This happens during the daytime. During the night time, again it cools down and this basically comes down here. It is because cooled. So this moving down is known as the mountain breeze during the night time. This is again simple concept, local concept happen during the valley regions. This is something very clear. Okay, let's move ahead. Now comes the other local winds. These are some things, names that you should remember. The ones in the red are ones which are of hot nature. The ones in the blue are cold. Clear? So you should know the names. I could have simply mentioned the names and the reasons, but maps basically helps you. So over here you have Chinook, across the Rockies, again Santa Ana. These are again warm. These are cold local winds because these local winds are basically influencing the local regions. If let us say blizzard come, it is basically going to decrease the temperature very tremendously. Supposing it's Chinook, basically it helps as a increasing the temperature. It helps to lessen the melting of the ice in these regions. So these local winds are basically influencing the local factors. Chinook and Santa Ana, North American region, warmer. Blizzards and norther, again, these are the colder local winds. If you come here, Harmattan, again warm. Sirocco, again warm. Khamsin in the Egypt region, again warm. Then you have the Fohn, again warm. You have Bora and Mistral, which are cold. If you come to Australia, you have the Brick Finder, again, which is warm. And Nor'westers over here in New Zealand, again warm. So these are the local winds that you should know. Quickly note it down also. You can draw a map also later on. Okay, let's move ahead. Now, next concept comes air mass. You would be very shocked to hear that this question has been already asked in the examination. What are air masses? And unfortunately, many people who do not study, because in the NCERT only one small paragraph of air mass is written. Nothing else is written. So people think that how can a question be asked? But the question was asked. Yes. So 15 marker question was asked. So you should be aware of the concept. If you are aware of the concept very clearly, you can write your answer also. But if you do not know it, how will you write it? Now please understand. When I talk about air mass, what do you understand? A mass of air. But if mass of air to be called an air mass, there have to be certain dimensions. Now see here. When an air mass remains over a homogeneous area, what do you mean by homogeneous area? Homogeneous area, let us say, which has specific uniform characteristics like temperature or humidity. So when an air mass remains over a homogeneous region, I am talking about, let us say there is a surface. Why it is homogeneous? Because let us say of its characteristic, whether it is warm, hot, and a mass of air is lying on top of it. This is a surface, homogeneous region or area, and a mass of air that is lying on top of it. For us, when an air mass remains over a homogeneous area for a sufficiently longer time, it acquires the characteristics of the area. That means if this surface is, let us say, warm, and an air mass is lying on top of it, if it is on top of it for a very long time, it will acquire certain characteristics of that region. Why? Supposing the air is warm, this region is warm, the temperature will be transferred to that air mass also, and it will also become warm. If the region is very cold, the ground surface is very cold, and that air mass is on top of it for a sufficiently longer time, this will also become cold. Yes. So it is basically acquiring the characteristics, provided it is there stagnant for a longer time. That is why if an air mass remains over a homogeneous area for a sufficiently longer time, acquires the characteristics of an area. Done. The homogeneous region can be vast ocean surface or vast plains. Why we are saying vast? Because if there is a small region with and then another small region having different characteristics, then it is difficult to form proper air masses. Because there is variability, it is not homogeneous then. It will become heterogeneous region. Homogeneous means large area with similar or uniform conditions. That is why then the whole air mass that is on top of it will be having uniform characteristics. So what do we see? Let's see the definition. The air with distinctive characteristics in terms of temperature and humidity is called air mass. Air with distinctive characteristics. Now air over here, let us see, a region is there and a large amount of mass of air is there. And because of this contact, it has acquired certain characteristics with respect to temperature, with respect to humidity. Now this is known as air mass. That is why the air with distinctive characteristics. Distinctive, that means it has its own characteristics, which is uniform also, almost uniform in the across this large mass of air. This is known as air mass. Now the homogeneous surface on which the air mass forms are known as source region. Now till now we were talking about the region and the mass of air that is on top of it. The mass of air on top of it is known as air mass. This homogeneous region is known as source region. Why it is known as source region? Because this is the source through which this air mass is acquiring its characteristics. Clear? It is acquiring its characteristics. That is why it is known as the source region. Again, let's see it again. If supposingly, we'll see that through the diagram also, don't worry. A large mass of air, let us say this is the region of, complete region of, let us say North American region, huge. Let us say northern part, let us say United States or Canadian region. Huge mass of air is there and the region over here is very cold. So the air on top of it will acquire that cold characteristics. Plus it is continental part also, it will be a continental air mass also. Then we'll see the continental, polar, continental and marine also, but this is the region what that simply understand that air mass will acquire the characteristics of that particular cold environment uniformly, almost uniformly. So that means the region through which it is acquiring the characteristics is the source, and that mass of air on top of it is known as the air mass. So see here, so we see the air with distinctive characteristics in terms of temperature and humidity is known as air mass. Homogeneous surface over which the air mass forms is known as a source region. I'll be telling you through the diagram, it will become easier for you. Now see, before this also, let us see for 2 minutes. Leave the terminology that I mentioned, MP, CP, leave that for 2 minutes. Do you realize this large mass of air is present here? Now, if it is there for a very sufficiently longer time, it will acquire the characteristics of the source region which is below it, and it will have similar characteristics because it is there for a long time. This is known as an air mass. Now this air mass can be on top of continent as mentioned, that will be known as a continental air mass. It can be formed over an ocean also, it will be known as marine air mass. Yes, so we'll come to that, right? So let's come back here. We have understood what is air mass. Now let us understand the major source regions. What are the major source regions? This is mentioned in the NCERT also, you should be aware of. Warm tropical and subtropical ocean. These are those regions, if the mass of air is there, it acquires those characteristics. Subtropical hot desert, it will be warm air mass again. Relatively cold high latitude ocean, relatively colder air mass. Very cold snow covered continental high altitude, and then again permanent snow covered Arctic and Antarctic. So these are those regions where very often you see the air masses. If the mass of air is on top of these regions, it will acquire the characteristics of these source regions. If it is in a cold region, it will be a colder air mass. If it is in an environment of a hot region, it will be a hotter air mass, right? Or warmer air mass, you can say. So these are the source regions, right? Now let's move ahead. A classification that you should know. This is a very simple classification. There are many classifications. If you want to ask, this was given by Trivartha, which you do not want to know, you should not know also. There is no need for general studies. There are a lot of classifications, but I've just mentioned so that you understand it. Polar air mass is conventionally known by P. Tropical air mass by T. That means polar is in the higher latitudes and tropical air mass in the lower latitudes. If it is formed on the continent, it is known by small c. If it is formed in the marine region, it is known by small m. What are the possibilities now? Cp means continental polar air mass. Small mp means marine polar air mass. Small ct means continental tropical air mass. Mp means marine tropical air mass. Now see the example of North America which I've shown you. CP, continental polar air mass, because it is colder, it is cold and dry. MP, marine polar, it is cool and wet. When you come over here, southern, this is marine tropical. Marine because it is in the ocean. It is warm and wet. Wet because it is the region of, let us say, ocean. And T because it is tropical, right? Over here, marine tropical again. This is cool and wet again. See, this is again marine polar. Clear? So this is again a simple representation of various air masses from the perspective of North America. Clear? Now, let's move to the concept of fronts. Very, very important. If you've understood the concept of air masses, now let us understand what is fronts, which we had studied when we were studying the pressure belt. So that is why you should understand what is fronts. When two different air masses meet, the boundary zone between them is known as a front. Very, very important topic. Just note it down. What is written here? Let's see. What do we understand by fronts? Come on, tell me. What do we understand by fronts? What we understand by fronts is, see, when two different air masses, see here, two different air masses, why? Because if two different air masses are there, they will be having different temperature, different humidity, different parameters. That is what is important. If there are no differences, then the front will not be formed. So, supposing that this is an air mass, which is, let us say, colder. This is a warm air mass. Let us say these masses come and collide. Let us say come together. The boundary, the zone where they are basically meeting, this zone basically forms the front. What does it form? It forms a front. And the process of formation of fronts is known as frontogenesis. Frontogenesis. Let's see here, simple. Very simple diagram. Let us say this is an air mass. Let us see here. This is a mass of air. This is supposingly another mass of air. This is moving, let us say this side. Let us assume, let's see this. Now, after some time, what happens? What is this? This is a front. I'm taking this as, let us say, warm, this as cold. Simple understanding. The two different air masses meet, the boundary zone is known as a front. Two different air masses, because these air masses, greater the variation, stronger is the front. If greater the difference is in the temperature or humidity, temperature predominantly is there, greater is the intensity of the fronts that are formed, right? That is why you will see certain questions, why fronts are not formed in the equatorial regions. Why? Because the temperature uniformity is there. But when you go to the regions which are present here, over here, see, let's see. Over here, you realize there are certain warmer also regions, warmer air masses also coming and cooler air masses also coming from that region. So we realize there are certain regions where fronts very often happen. See here, subpolar low pressure regions, if you see. Over here, warmer air masses also going and colder, very cold air masses also coming. That is why this is a region where subpolar low pressure regions are the where you find a lot of front formation taking place. Because warmer air masses from the lower latitudes are moving and colder air masses from the upper region. While in the equatorial region, you realize it is uniformity of temperature is there. So you do not see front formation, because for that, the air masses should have a lot of variation in their distinctive characteristics, which I had mentioned in what? While defining the air masses also, right? So let's see here. So this is frontogenesis, formation, process of formation. Fronts is the boundary. Now let's see, there are four types of fronts. First is stationary fronts, cold front, warm front, and occluded front. What happens is, this is red color warm air mass, this is cold air mass. Now when the air masses are not moving against each other, they're not moving against each other, they're just coming close here, right? That means there is no temperature gradient because they're not crossing, they're not moving against each other. So this is a stationary stage right now. their stationary stage. This is known as a stationary front. It is not a proper front that is formed. It is the initial stage. There is some convergence taking place, but they have not crossed each other, right? So, or moved against each other. That is why it is just stationary stage. That is why it is known as stationary front, just the beginning stage. Cold front. When the cold air moves towards the warm air, the contact zone is known as a cold front. When the cold air is moving towards the warm air, this is known as a cold front. Warm front. When the warm air moves towards the cold air, this contact zone is known as a warm front. When the warm air is moving towards cold air, it is known as the warm front. Now what happens? After some time, when both the airs are coming, what happens? It is possible that the air might be lifted up. If the air mass is fully lifted above the land surface, it is occulted. Over here, see, over here you realize this warm air over here is completely pulled upwards. So this region is known as the occulted front. Occulted front. So that when an air mass, when a part of air is again lifted upwards, over here, when the air is fully lifted upward, then this part is known as the occulted front. That means finished, right? Okay. These are the 4 fronts. Please write it down, make the diagrams. The question is why subtropical low pressure belts is a very prominent zone for the front formation. This is question number 2, which you have to write in your comment section. Briefly, these are questions which are asked in your civil services preliminary as well as mains examination. Okay, let's come to the next topic, that is cyclones and anticyclones. Now see, please understand this is a diagram that you should always remember. What are cyclones? Cyclones are low pressure systems, right? Low pressure systems where the movement is taking place in an anti-clockwise in the northern hemisphere and clockwise in the southern hemisphere. As anticyclones are opposite of that. Anticyclones are high pressure systems where the movement is basically, the pattern of wind movement is basically clockwise in the northern hemisphere and anti-clockwise in the southern hemisphere. Let's see here. When I'm talking about, let us say something like this. This is low pressure. These are what? These lines are what? Isobars, right? Now just see this. First thing, tell me, when you see a surface which is, let us say the winds are moving in a circular path over here, right? Second thing, do you see there is a low pressure? When the low pressure is there, what will you say? It is a cyclone. First. Now it is moving. Do you see the direction of movement is in an anti-clockwise manner? Anti-clockwise. It is not moving in this direction. It is moving in this direction. So what it is? Anti-clockwise means northern hemisphere. Clear? Similarly, when you realize, you will see if it is moving in a clockwise manner, it is what? If it is low pressure and moving in a clockwise manner, what? Then it is going to be a cyclone which is present in the southern hemisphere. Anticyclones also you will study later on in this chapter only. So broadly you have got an idea. Cyclones, again, these are low pressure systems which are moving in an anti-clockwise direction in the northern hemisphere and clockwise in the southern hemisphere, whereas anticyclones are high pressure systems which we will be seeing after cyclones completion, which are moving in a clockwise direction in the northern hemisphere and anti-clockwise in the southern hemisphere. Now we'll see this. Wait. First, let us see cyclones and study them. When we are studying the cyclones, and then we'll study them in detail, and then we'll study the anticyclones. When I talk about cyclones, these are what? Low pressure systems. When I talk about the types, please understand there are 2 broad categories. First, temperate cyclones. Second, tropical cyclones. Now for temperate cyclones, it was very important for you to understand the concept of fronts and air masses. If you do not know that, you will not be able to understand the temperate cyclones. And then why the reason why temperate cyclones are located in these regions, you will also get to know this. So let's see. What are temperate cyclones? First of all, when I say cyclone, what will you understand? It is a low pressure system. Second, if it is, see, cyclones are what are they? You know that basic understanding is clockwise in the anti-clockwise in the northern hemisphere, clockwise in the southern hemisphere. Leaving that point, you should know that. Now let's see. When I say temperate cyclones, that means formed in the higher latitudes, temperate regions. So that is why there are various names also assigned to them. System developing in the mid or the high latitudes beyond the tropics are known as mid-latitude, extratropical cyclone, or temperate. Extratropical means outside the tropical zone. Please remember, in the exam they can ask you tropical and extratropical cyclone. You will get confused otherwise. The temperate cyclones are also known as mid-latitude cyclone, extratropical cyclone, and temperate cyclone. Clear? Let us understand certain features before I explain you how they are formed. See, these are formed due to horizontal temperature differences between two air masses. That means because of the air masses, the front formation takes place, and that leads to the rotatory path, which leads to the formation of temperate cyclone, which we will be seeing. That means for temperate cyclone, frontogenesis is a major dimension. Without that, temperate cyclone is not temperate cyclone, right? So front formation, that means frontogenesis, is something very important. That is why the fronts is the basis of this particular concept. Velocity, it rarely reaches more than 100 degrees. So that means the velocity is relatively less. In tropical cyclone, it is very high, right? We'll do that. Diameter from 150 to 3000 kilometers also. Vertical extent is 9 to 12 kilometers. It is never completely circular, please understand. Frequent in regions between 35 to 60 degree latitude, because you know these regions are where front creation is very common. Can form both on land and ocean. It can form on land and ocean both, because it is basically dependent upon the front formation. Special compartments or cell exist, or sectors exist, which I'll show you, which is not present in a tropical cyclone. Whatever points I've written here are also points of differences with a tropical cyclone. You will see when I will be doing the tropical cyclone. Now this is the formation. Now please understand. Please see there are certain standard connotations which I'm using here. Let us assume that this is a blue colored is a what? Cold air mass. What? Cold air mass. This is a warm air mass. Now, this symbol of these lower sided arrows of blue color and red color, this is known as stationary front representation. That means right now they just come, but they have not again, just let us say they have not collided properly right now. They are just in the process, in the close to each other, right? There is little bit convergences, they are not but proper. So that means this is right now a stationary stage. That is why this is known as stationary front. Now what happens? The moment it is coming, there is again upliftment, the air mass is being uplifted, the warmer one, and some twisting happens. So the moment the upliftment happens, the lower pressure is created and this twisting is happening. This is again the representation of warm front. This is a cold front. The moment it starts rotating, this is again a circular motion is being established. So this is again what? A cyclone is being established. Now this again starts turning more. Again it is mature stage. When it basically combines, you see this purple color is a occluded fold. That means the ending stages begin and then finally it dissipates. So it is basically the fronts which are coming together, and because of that obviously the warmer air will be uplifted, and you know that the turning will start. The moment the turning starts, this cyclonic conditions starts, and it is why temperate cyclone, because it is in a temperate region and fronts are basically involved in this particular process. That is why it is known as again basis. The front or frontogenesis is the basis of the temperate cyclone. So this is the formation stages. So let us write it 1, 2, 3, 4, 5, 6. Clear? Red color is associated with warm and warm fronts, blue with cold or cold fronts. Now please understand this. when you see these dimensions, there are a lot of things that are associated with each and every element that I mentioned here. Now let me show you this. This is known as the warm sector. This is known as the cold sector. This red color, this is because of the air mass that was warm. So can I say this is what? Can I call it let us say warm sector? Warm sector means this region. This region is warm sector. This region is the cold sector, right? This is the warm front. This is the cold front, right? So let's see here. This is what? The warm front. If you see over here, I have mentioned here was sector. So see here, this is the warm sector. That means where warm air mass is this. This is what the warm sector is here. Similarly, this is what is the cold front. And this is what is the cold sector, where cold air mass is there. Now, related to this, there are weather associated with, different weathers are being associated within a particular temperate cyclone. That is why I told you there are compartments existing, cell existing, and within a temperate cyclone, you realize there are variations existing within the temperate cyclone with respect to the weather conditions. Let's see. The warm sector, please understand, let's see the warm sector. What's the warm sector? See, what happens is sky becomes cloudless and clear, sudden rise in air temperature and increase in specific humidity seen. The warm frontal region has precipitation, thick clouds and very heavy rainfall happens. So you know, when I'm talking about warm sector, increase in temperature, warm front over here, very heavy rainfall happens. Cold front is marked by decrease in temperature. Cold frontal precipitation happens, heavy downpour and thunder and lightning happens there. And in the cold sector, there is sharp fall in temperature. Now, this is again something not present in the NCERT. I have drawn these formation, I have drawn the sectors which are there, I have drawn the fronts there and the related associated weather also. Clear? So, the question which were asked in the examination was something that you should have the knowledge of this subject or this topics. Otherwise, you would have not been able to write in the examination. Let's move ahead. Tropical cyclones. You know, when I talk about tropical cyclone, you're talking about the tropical region. So tropical cyclones are violent storms that originate over the oceans in the tropical areas and move towards the coastal areas, bringing about large-scale destruction caused by violent winds and very heavy rainfall. Please understand this, that first of all, unlike the temperate cyclones, the temperate cyclones are formed because of the frontogenesis. That means fronts can be formed over the land also, and they can be formed over the oceans also. So their formation is dependent upon fronts, so that means they can be formed over the land and oceans also, no problem. But tropical cyclone basically derives their energy from the water. Now what happens is, when water gets heated, it basically, let's just say vapors rise. When they cool, latent heat is released, and that is why the tropical cyclone works like an engine, right? Heat engine. And that energy is continuously supplied and keeps on going. That is why tropical cyclones are formed only over the water bodies or oceans or seas. The moment they come across the coast, they might cause a lot of destruction, but as they enter the coast, because their supply of water ends, so the tropical cyclone also finishes. Unlike the temperate cyclone, because it is based on frontogenesis temperate cyclone, this is based on water as a means of energy, because when water gets heated, it rises in the form of vapors. When it rises, it cools. When it changes state, the latent heat or the hidden heat is released, which again cycles the whole process, again that convective cycle to take place. This can only take place if the water supply is there. If it is not there, it will end. So that is why we say that these rise over the tropical oceans, tropical areas, and originate over the ocean. And when they move towards the coastal region, they bring a large destruction because they are very strong. But as they move inside the coastal region, they will die because the source of water is ended. Favorable conditions, large surface area with temperature higher than 27 degrees, large sea surface, again sea surface, higher the temperature, better it is. Presence of Coriolis force, so that again Coriolis force basically helps to form the cyclones, right? Because of the because of deflection that is caused. Small variations in vertical wind speed, pre-existing low pressure might be existing, which basically helps. Upper divergence among the sea level, again, basically helps in the formation of the tropical cyclone. Now, what are the features here? Latent heat, again, as I said, hidden heat that is released when you change from one state to another, latent heat is basically released. So that hidden heat is basically boosting this particular process. Velocity is from 20 to 30 kilometers per hour to even 300 kilometers per hour. That means very fast speed. Diameter 80 to 300. Vertical extent 15 kilometers up to 15 kilometers. The location is from 5 degree north to 5 degree south only. So this is a limited portion. Forms only in oceans or seas, as I've told you the reason. It is basically known by various names. Cyclone in the Indian Ocean. This has been asked in the civil services and PCS repeatedly, right? Cyclone in the Indian Ocean, hurricanes in the Atlantic Ocean, typhoons in the Western Pacific and South China Sea, and willies in Western Australia. So these are certain things that you should be aware of, and please note it down, pause the video. Let us see the formation of the tropical cyclone also. We have seen the temperate cyclone. So what happens initially is, initial stage, the isobars are ill-defined and only center core is little bit there. So that means certain convergence is taking place. Slowly what happens in the formation of the infant stage, this center part is the eye is developed and isobars are more circular. That means the cyclonic conditions is basically intensifying a little bit. Beginning. Juvenile stage where you see there is certain again convergence and there is certain, let us say, rising, the air will rise, warm air in the form of vapor, and then certain cloud formation will take place and certain rain will also take place. So again, cyclone is again developing now. Mature stage, similarly over here you realize this, there is intensification of this particular stage over here where series of clouds are fully formed, full developed eye means this particular center region, and large size and high speed basically develops. Now if you want to see this, what the NCERT shows you is only this diagram. They do not show you these stages. So NCERT, what does it show? This is the eye, which is again basically because it is a region of subsidence. That is why it is again very region of calm. But as you see over these regions, as the air rises, you realize there's cloud formation taking place over here, and these cloud formations again lead to a lot of rainfall, a lot of speed, a lot of destruction when it enters the coastal regions. But this eye is a region of subsidence, which is a region of generally calm, right? Okay, so this is what is the tropical cyclone. What are the weather associated with it? Sudden increase in air temperature and the wind velocity. Marked decrease in the air pressure, obviously, because these are low pressure systems, so there will be decrease. Cyclones are low pressure systems. Emergence of high waves. The region in the center is region of calm breeze and clear sky. Clear? Okay, now let us see what are anticyclones. Please understand. Again, do you realize this is high pressure system? High pressure system means wind always moves in the outward direction and it is moving in the clockwise direction. So that means this is in the northern hemisphere. What did I say? What did I say? I had mentioned that anticyclones are high pressure systems. That means if this high pressure system, that is means it is an anticyclone because cyclone was a low pressure system. Now, if it is moving in a clockwise direction, cyclones are anti-clockwise in the northern hemisphere and anticyclones are clockwise in the northern hemisphere. So this is clockwise, moving in the clockwise direction. So this is clockwise. So this is what? In the northern hemisphere. So this is representation of a anticyclone in the northern hemisphere. These are high pressure systems. Defined as high pressure systems where wind blow outwards. Right? Now see here, features: circulate clockwise in northern hemisphere and anti-clockwise or reverse in the southern hemisphere, usually circular in shape. They are very large size. Diameter may go up to 9,000 kilometers. This is huge. Velocity from 30 to 50 kilometers per hour. Associated with it is rainless and free of sky because it is high pressure. So see, please, the climatic condition variations and large rainfall basically is one of the reasons where air rises from a particular region. That is why there is instability and lot of rainfall. So there is sinking of air. So you realize there is generally associated with aridity and clear skies over here. So this is what is the anticyclone. So water in the atmosphere. Now please understand, when we are dealing with this particular topic, what topics are we going to study? See, firstly, we'll study what is humidity, the types of humidity, something that very often students find it difficult to comprehend because you generally study one definition of humidity, but there are a lot of types also. So you need to analyze and understand each and every one because these questions have been asked repeatedly in your prelims. Then what is the concept of evaporation? What are the factors that are impacting evaporation? These topics, though, you have studied in your school days also. But again, UPSC test you on the understanding part. Next is condensation, clouds, and then precipitation. So we're going to study all these topics, and let's begin with today's lecture. Okay, humidity. Whenever we talk about humidity, the simplest definition that comes into your mind is what it basically refers to the water vapor that is present in the air, right? But something that we make mistake is, please understand, whenever we talk about water vapor over here refers to a air, a component of the air. It has got nothing to do with dryness or wetness. This is something very, very critical. I'll explain you here also. It has got nothing to do with the dryness or wetness indirectly when we talk about the atmosphere. It is itself an air. Now see here. In general terms, it refers to the water vapor content in the air at any one time and place. So this is the generic definition of humidity. We'll go into the types also. So what does water vapor refer to? Water vapor basically refers to the water vapor, humidity refers to the water vapor that is present in the air at any one time and place. Now, when I talk about water vapor, I am not directly talking about other things. See, this term is not used to describe liquid droplets. Please remember that. We are not talking about condensation here right now. Please understand that. We're not talking about condensation. It is like an air. Water vapor is also a component of an air, right? Over here, that is why please understand, we are not talking about any fog, cloud or rain. Condensation, how it takes place is a different scenario altogether. Whenever we talk about water vapor, it is simply refers to the water vapor in the air, and it is not used to describe the liquid droplets. Later on when condensation takes place, how those phenomena take place, that is a different scenario altogether, right? Water vapor is dry like any other gas, right? It is a component of an air, and like any other gas, like you have nitrogen, you have oxygen, water vapor is also what? A gas. Like any other gas, it is dry. It has nothing to do with dryness or wetness of atmosphere. See, it has got nothing to do with dryness or wetness of the atmosphere. Like any other gas that is present in your atmosphere, nitrogen, oxygen, argon, similarly, water vapor is also like a gas that is present in your atmosphere. By default, it has got nothing to do with that wetness or dryness. Yes, when we go ahead with the concept of condensation, then we will talk about these things, but humidity, no, right now it has not got nothing to do with that. There is spatial and temporal variations, but amount of atmospheric water remains nearly constant. See, there will be certain variations. For example, in the regions which are close to the, let us say, oceans or oceanic regions, will have a higher supply of water available there. So obviously the humidity might be more in comparison to the interiors of the continent, right? Similarly, humidity, or let us say the available water supply is more in the equatorial region than in the polar region. So it will be more in the equatorial region. Yes. So that is why when we see the variation of water vapor, let us say in the air, varies from 1 to 4%. This is a variation which even your NCERT very categorically mentions. So you should be very, very clear about it. It varies from 1 to 4%, right? So, but moreover, it is this constant percentage that is there, right? So you can note it down also, you can stop the video. Now the question comes, having understood humidity, because again, many people will again have a problematic issue. Why? What they face is that, sir, when humidity is there, then it is little wetty feeling. Please understand, it depends upon a lot of atmospheric conditions along with it. In the phase of, let us say, it is about to rain or condensation has taken place, and all those phenomena also impact a lot. So right now, when we talk about water humidity, we're talking just about the water vapor that is present in the atmosphere, and it is like any other gas that is present. So do not confuse it with the phenomena of condensation, because when we talk about rain, clouds and all, it is basically the condensation that has taken place, and then those phenomena take place. So right now when we talk about humidity, that is water vapor in the atmosphere, we are not concerned with another phenomena that are taking place right at the moment. So that is why it is considered like any other gas, which is itself dry in nature, and it has got nothing to do with the dryness or wetness in the surrounding atmosphere. Clear? Now, when the question comes, okay, now let us now please tell us, sir, there are a lot of types of humidities also we study. I'm going to tell you about certain humidities which possibly you might have not studied or have a little problem in understanding. So we will make it clear also. Please remember this, that there are a lot of phenomena, a lot of concepts that have to be understood if you want to understand the concept of humidity. Under the humidity category, you need to understand what is humidity capacity. You need to understand what is absolute humidity. You need to understand what is relative humidity. Once you have understood these concepts, it is very easy that what humidity basically means. When I talk about, let's go with the first concept. Humidity capacity. When I talk about capacity, what do you mean by capacity? Supposingly, I have a bowl, right? Now, the maximum water that I can put in the bowl is 1 liter. So what is that? That is the capacity. Now, similarly, when I talk about humidity capacity, it is the amount of water vapor that at a given point of air can hold at a given temperature. So if there is, let us say, some amount of air at a particular temperature, what is the amount of water vapor that this air can hold? That is why, see, the amount of water vapor that a given parcel of air, let us assume this is a parcel of air. Now, let us say at temperature T degree Celsius, right? It can hold certain amount, let us assume 10 grams, let us assume, clear? And there is certain volume present here. So based on that, what I am trying to do is, I'm trying to measure or calculate in a way, what is the amount, that means it is, we're talking about the weight only. You can say that is why it is measured in grams per centimeter cube. That in certain amount of weight that can be present in certain volume of air. So it is the amount of water vapor that a given parcel of air can hold at any given temperature. Why temperature? You know that very well, when the temperature changes, the humidity capacity will change. Why? Because there is expansion of air. If at a certain temperature, this is a parcel of air that is present. When I increase the temperature, what will happen? The expansion will take place. Intermolecular spaces will increase. If it will increase, the capacity of the air to hold water vapor will be more. So with increasing temperature, we will see that the capacity of the air to hold more water vapor will be present. So that is why the concept of humidity capacity, that means it increases with the increasing temperature. So again repeating, the amount of water vapor that a given parcel of air. So it is the amount of water vapor that any given parcel of air can hold. Importantly, at a given temperature. This is known as humidity capacity. It is measured at grams per centimeter cube. That means the amount, and in the what specific volume of air it is present. Next is moisture holding capacity of air increases with increasing temperature. Now, how? As I've told you, if at certain temperature, this is, let us say, a graph representing the temperature increase. This is the humidity capacity. At, let us say, certain temperature, let's assume it hypothetically that at this particular point, let us say the temperature is, let us say, 10 degrees Celsius. And over here, let us say it can hold, let us say, 10 grams. Now, similarly, the temperature increases possibly at 30 degrees Celsius. It might go to, let us say, 20 grams. Let us assume hypothetically. So what does it basically mean? It means that with the increasing temperature, the humidity capacity will increase. Is it clear? The concept should be very clear. Now comes a very interesting topic. After having studied the concept of humidity capacity, let us move on to the concept of absolute humidity. Now, humidity capacity is a basic concept which helps us to understand the humidity definitions as well as the other concepts. What is absolute humidity? It is the weight of water vapor per volume of air. What it is? Earlier one was just telling about the capacity, right? It is telling about the capacity it can hold. It is not telling about the humidity. Please remember that. When I talk about humidity capacity, it is the capacity, that is the amount of water vapor that can be held in a parcel of air. It is not a form of humidity. It is not a form of humidity. But a concept. but a concept to understand humidity. That should be very clear. It is not a type of a humidity, it is a capacity. What it can hold. What it is holding or not holding, that is a different scenario. Okay? Chaliye. Now, remember, capacity means the maximum level it can hold. When I talk about absolute humidity, it is referring to the weight of water vapor per volume which is actually present. Capacity means that what it can hold, and absolute humidity is what it is holding. Now, why it is important is, like for example, your parents believe that you are going to get, let us say in a mathematics paper in class 10, 100 marks out of 100. That is the capacity that we believe that you will be getting. That is the maximum. But you actually get 95. So what you are holding, right? Similarly, absolute humidity is the weight of the water vapor per volume of air. That was a capacity. So obviously over here also it is grams per meter cube. It decreases from equator towards the poles. Why? At the equator you will realize more amount of water vapor is available because it is again lot of rainfall is also happening. Over the oceans, from ocean towards the continent it decreases. Why it is more over the oceans? Because over the oceans you realize there is more supply of water vapor that is available. At the continents there might not be the case, right? Similarly, you can see as the temperature is increasing, the absolute humidity is also increasing. Now please remember one thing. It is quite possible, this is fact, with the absolute humidity which is increasing with temperature, it might not be meeting the exact capacity. When it reaches the capacity, it becomes saturated. Do you realize this? Now, humidity capacity means that to what extent water vapor can be held, but what is present actually is basically referring to the absolute humidity. Clear? Next, we have done with the absolute humidity. Let's begin with specific humidity. See, one needs to analyze this. This concept is a little different from the previous concept that we have studied. Now see here, specific humidity, sometimes people find it very difficult because over here a very important line is written that it is not affected by changes in temperature and pressure. Now you'll be thinking it is humidity and how it is not being impacted. So let us understand that. It is not because it is humidity in per se, it is basically the concept that we are dealing with. Now see here, it is basically what? It is a ratio, right? It is a ratio. Now in this ratio, it is what it is? Mass of water vapor upon the total mass of air. The total mass of air includes the mass of water vapor plus the other gases, that is the dry air. So this is the ratio which we are talking about. Similarly, let us read it. It is the weight of water vapor. It is the weight of water vapor per the weight of a given mass of air, including the water vapor. Clear? Clear? It is measured in grams of water vapor per kg of air. Grams of water vapor per kg of air. Now, it is not affected by changes in temperature and pressure. Let us take an example. If I increase the temperature, what will happen? The humidity capacity changes. That is why the previous phenomena where we were talking about aspects of humidity capacity and all, are we dealing with humidity capacity here? No. Are we dealing with volume over here directly? No. What are we dealing with? We are dealing with the mass, weight. So, with the change in temperature, there is change in humidity capacity. But is the humidity capacity being changed here because we are taking the mass only? So, by changing this temperature, there is no change in these ratio. It will not be changed. That is why it is not being impacted by change in temperature also, and for that matter, pressure also. So that is why please remember specific humidity is not impacted by changes in temperature and pressure. But you will see that there is relatively higher specific humidity near the equatorial region. That is because more amount of mass of water vapor is present there. Just because of the supply, the more mass is present, that is why we see a little bit increase over here. That is it, nothing else. And it keeps on decreasing as we move towards the poles. Now please understand, because we are not changing the humidity capacity, that is why it is not affected by changes in temperature and pressure. Clear? Let's move ahead. Relative humidity. Now relative humidity again is a concept that is expressed in a percentage. What it basically means? It means absolute humidity upon humidity capacity. See, the previous initial two concepts that we had done, we had talked about humidity capacity and we had talked about absolute humidity. It is basically the ratio of these two. What does it mean? See, I told you that there is, let us assume, a humidity capacity where a certain parcel of air can hold, let us say, 100 grams maximum of water vapor. But in reality, you see that only 50 grams of water vapor is present. So that means there's a difference between the capacity and difference between actually what is the water vapor present. This is what is being referred to here, over here. That absolute humidity upon humidity capacity into 100. So that means it is referred to as or expressed in the form of percentage. Let us see. It is defined as a ratio of the amount of water vapor in the air to the amount of air it can hold at that temperature. Yani at what specific temperature? At any specific temperature. So because you will see, because over here humidity capacity is present, so by default there will be certain change present there if there is change in temperature. Let us see this. Relative humidity changes if there is more addition, if it will increase if there is more addition of moisture. How will it increase? Please understand. Humidity capacity is there. Humidity capacity is fixed for any specific temperature. Now let us assume at any specific temperature there is, let us assume, humidity capacity of this circle. Let us assume this circle is capacity and this is what? Humidity. If let us say there is capacity of, let us say a humidity capacity is, let us say 100 grams, let us say for a parcel of air, for a certain parcel of air. What do you mean? That means per volume. Now, this is, let us say, 100 grams. Initially, what we saw, humidity capacity was, absolute humidity was, let us say, at any specific temperature, let us say 50 grams for a parcel of air, because it is in a ratio of weight upon volume, right? Parcel of air. What do you see? 100 upon 50 into 100, that means 50%. Now, I'm not changing the temperature. That means there is no change in humidity capacity. Now, let us assume I'm not changing the temperature, still the humidity capacity will be 100 grams. Now, let us say I add more moisture. From 50, it has become to 70 grams for a parcel of air, So that means now the ratio will be 70 upon 100 into 100. What does it mean? 70%. That means with more addition of moisture at that specific temperature, I am not changing the temperature, please. With change in temperature, there will be a lot of changes. So, with more addition of moisture at any specific temperature or without change in temperature, the humidity, relative humidity will increase, because the denominator remains same, the numerator increases. So, if the numerator increases and the denominator remains the same, it will be increase in the relative humidity. Now, concept comes is, sir, you have written here, it increases with decrease in temperature. How? Just remember this. Let us assume, let us understand this decrease in temperature. Supposingly, at initially, there was some temperature. Let us say initial condition is temperature is, let us say, 20 degrees Celsius. And I say at that particular temperature, the humidity capacity is, let us say, 100 grams for a parcel of air. I could have written it grams per meter cube also. It is same, right? Parcel of air. That means for a volume of air. But the absolute humidity over here is, let us say 50 grams per centimeter cube. Over here, this can be written as 100 grams and so on. Let us say I'm taking the same unit, centimeter cube for here for the timing. Just understand. Just imagine it. Now, this is a temperature, this is a humidity capacity, this is the absolute humidity. Capacity is 100 grams, humidity is, let us say, 50 grams, temperature is 20. Now, if I decrease the temperature, let us assume now over here, what is the relative humidity? It is basically 50 upon, let us say, 100 into 100. It is basically coming out to be 50%. Okay. Now, let us decrease the temperature. Temperature becomes 10 degrees Celsius. Temperature becomes 10 degrees Celsius. Now, you know one thing, that with the decrease in temperature, the humidity capacity decreases. Let us assume initially the humidity capacity was 100. Now, it becomes, let us say, 50 grams for a parcel of air. for a parcel of air. What has happened is, with the decrease in temperature, the humidity capacity has decreased. But the absolute humidity, let us assume the amount of water vapor, this amount of water vapor that was present is the same. So, let us say the absolute humidity that was present is 50 grams only, because the moisture that was actually present is 50 grams only. Now you realize that the denominator has decreased, but the numerator is same into 100. So it is 100% now. So the relative humidity is 100% now. So that means earlier it was 50%, is 100%. Now, so what happened? Relative humidity has increased with decrease in temperature. Why it is happening is, simple concept is, with the decrease in temperature, the humidity capacity decreases. The absolute humidity is similar, because why? Because it is basically having a parcel of, that is the water vapor that is present. So that is in grams, that is same. Capacity will decrease, that means the numerator is same, the denominator is decreasing. In the specific aspect also, if you studied basic mathematics, if the denominator is decreasing and the numerator is same, the ratio will increase, or the percentage will increase. That is why there is increase in relative humidity with decrease in temperature. Clear? Let us understand this. Okay, let's move ahead. When we come here, let us say similarly, this what I have explained you over here, this is basically a representation of the similar content which I have explained you here also. Clear? So let's move ahead with these similar concepts over here. Having done humidity, let us go to evaporation. Now please understand, when we talk about evaporation, there is a big misconception that for evaporation you need to have a very high temperature and all. See, yes, temperature helps, but it does not mean that merely at a boiling point it is going to happen. No. Boiling is a very different phenomena. Remember that whenever a liquid surface is present, let us assume, there is certain kinetic energy that is present. Even little bit temperature that is present has some kinetic energy that is being supplied to the water molecules. The ones which are on the top layer, surface layer, whenever they get certain amount of energy which helps them to escape, because if let us say intermolecular spaces is weak, if they get certain energy and they free themselves, these water molecules basically escape, and that is why that is a phenomena where there is change from the liquid state to the gaseous state without actually reaching the boiling point. So evaporation is taking place continuously at all the temperatures. Boiling is obviously at a higher temperature, it depends upon the nature of liquid. So you will realize that at the surface layer, when a kinetic energy at certain temperature is being supplied, the water molecules or whatever molecules, if they are able to free themselves from the intermolecular spaces, they will escape, and they will escape in the form of the gaseous state. That is why these are high kinetic energy molecular escape. In the liquid state, this is the gaseous state, which is because of evaporation it has happened. Now, the evaporation is a process in which the molecules on the surface of the liquid escape into the gaseous state before actually reaching the boiling point. So please do not assume that only at a boiling point the water changes into, or liquid changes into the gaseous state. No. It basically, this is a continuous phenomenon that takes place. Even if certain amount of, let us say, energy is supplied, let us say you are sitting in a room and there is some liquid kept, not necessarily water. If let us say you put on an air conditioning, let us say where heating is being done, possibly little 2-3 degree temperature increase also might give sufficient energy for a liquid to surface layer, because surface layer is the one having the higher kinetic energy, lower layers lesser. So that amount of energy which helps them to escape and leave the liquid state. So that means that evaporation is taking place continuously at all temperatures. Okay. What are the factors impacting evaporation? Now, these are certain factors which are very important. Let us understand, because this is a question which is asked in UPSC very often. See here, temperature. You know that very well when I talk about temperature. With increase in temperature, the capacity of water evaporation increases, right? Because why? Because where the temperature increases, the amount of energy that the molecules will get, but at the surface level of a liquid will increase. So there is greater tendency for them to leave the liquid and change into the gaseous state. So in higher temperature, higher the temperature, more the evaporation. Greater the evaporation. Greater the evaporation. Clear? Humidity. Now you please understand, humidity basically refers to the water vapor that is present in the air, right? If there is already very high humidity present, then there is lesser capacity for the air to hold more water vapor molecules, let us say water vapor. So if there is already a lot of humidity present, there will be lesser tendency for more evaporation to take place because the air cannot hold that amount of water vapor. So greater the humidity, lesser is the tendency of evaporation. Why? Because the evaporation basically changes a liquid state to the gaseous state. Now water is being added. Let us take the example of water. If water is being added to the air or the atmosphere, let us take air only. In that particular case, if already a lot of water is present there, it cannot hold more water because it might go beyond humidity capacity. So that is why already if more the humidity is present, lesser can be the evaporation rate. Wind speed. You know that very well that, as I've told you, when certain region has, let us say, certain humidity or whatever be the conditions, if the winds are flowing, they might remove whatever moisture is present in the air, and then the more evaporation can be there because there is, let us say, lack of water vapor in that particular parcel of air. So greater the wind speed, there is greater tendency of more evaporation to take place. Chances of more evaporation. Please understand, when I am talking about one factor, I am taking that factor only. I am keeping other factors constant, because if I take all the factors together, the result is very different. When I'm talking about one factor, I'm taking just one factor. Greater the wind speed, chances of more evaporation. Surface area. Now please understand, this is the surface area which is exposed to evaporation, and this is the surface area which is exposed. So greater the surface area, greater is the chance for evaporation to take place. More is the evaporation because more is the area, because it is a surface level phenomena. So greater the surface area, more is the area through which basically evaporation can take place. So greater the surface area, greater the surface area, greater the surface area, greater is the possibility of evaporation. Nature of liquid. Now please understand, every liquid is different with respect to boiling point and its characteristics. Please understand, when I talk about nature of liquid, there are certain liquids which are more volatile. Let us say they have lesser intermolecular forces that are binding the water molecules. Let us say if you keep a glass of water and you keep a glass of alcohol, you will realize that evaporation with respect to alcohol will take place at a very rapid pace. Or let us say the spirit that is used in the paint job. When you do painting in your houses, painters would have come, they would have used spirit to dilute the paint. You will realize if you leave the spirit outside, it will evaporate because lesser intermolecular spaces are existing between the molecules in that liquid, particular liquid. So nature of liquid, more volatile liquid, more or greater is the rate of evaporation. Greater is the rate of evaporation. Atmospheric pressure. This is something very important. You know that very well that atmospheric pressure refers to that pressure that is being exerted by a parcel of air on any object, or us also for that matter. If the atmospheric pressure is less, let us go to hilly regions. That means there is, let us say, a liquid pressure being acting, and then there is the atmospheric pressure. Now, if the atmospheric pressure that is exerting as a weight, column of air, a weight is being exerted, it is less. Greater is the chances for evaporation to take place. So, lesser the atmospheric pressure, greater is the possibility of evaporation to take place. Lesser lesser the atmospheric pressure, greater the chances of evaporation. So you have seen certain factors: temperature, humidity, wind speed, surface area, nature of liquid, and atmospheric pressure. These are important factors which you should know because these are repeatedly asked in your civil services preliminary examination. This can be asked in your mains examination also. Let's move to certain questions which are here. Please understand these questions are for your practice. The answers will be put in the comment section by me. So I'm not going to discuss the questions here. I'm just going to show you and we will be discussing. I would request you to write the answers in the comment section. First, consider the following statement regarding evaporation. Evaporation is a surface phenomena. Evaporation can occur at all temperatures. Evaporation always increases with increase in atmospheric pressure. Which statements are correct? 1, 1 or 2, 2 or 3, 1, 2, 3. You can pause the video here. Answer. This is question number 1, right? Next. Consider the following statements. Evaporation increases with increase in wind speed. Evaporation decreases when relative humidity is high. Evaporation is independent of the nature of liquid. A, 1 and 2, 2 and 3, 1 and 3, 1 and 2, 3. Pause the video here. You can answer in the comment section. Third, consider the following statements of evaporation at high altitudes. Evaporation is faster at high altitude due to the low atmospheric pressure. Water boils at a higher temperature at high altitudes. Lower pressure reduces the energy needed for the molecules to escape. 1 and 2, 2 only, 1 and 3, 1, 2, 3. You can pause the video, answer this question in the comment section, right? So these are the 3 questions which I expect you the answers in the comment section. So please do it. It is for your practice. These are the types of questions that are asked in the civil services paper also. Condensation. Now please understand, it is a simple phenomena where we see that condensation is a phenomena where the water vapor basically changes to the liquid state. Now, you remember that time when I was talking about water vapor being present in the atmosphere. Now, when I'm talking about water vapor, there is a difference. For example, humidity capacity and what it is holding, absolute humidity. I told you that simply talking about water vapor in the air does not mean we are talking about water droplets. It is like a gas that is present. Now, that gas to change into certain other form, there have to be certain conditions, like it must be saturated. What do you mean by saturated? That means the amount of air, the amount of water vapor that is present is equivalent to the capacity that it can hold. Saturation is that means the absolute humidity or the humidity capacity, they're equal, right? So that means 100%. So that means the relative humidity is what? 100%. Necessary surface or object on which it can condense. Now please understand, for the condensation to take place, you need a certain condensation nuclei or surface. For example, rain droplets also, if there is certain condensation nuclei, let us say a small ice droplet, let us say a dust particle, then it can condense on them. That is why condensation surface or condensation nuclei is important. This is again very critical conditions which should be there in order for the condensation properly to take place. Let us take the types of condensation. Now please see. Dew. Very often nowadays you are seeing the dew being present. Before we study this, let us see the photograph. Do you see these leaflet that is there? These are water droplets that are present on top of it. Yes, these are water, not ice particles. These are water droplets. This is basically referring to as dew. Now what it is? When moisture is deposited in the form of water droplets on the cooler surfaces of the solid objects like stone, glass plates, it is referred to as dew. So in solid, in the early mornings you will see that water droplets being deposited on surfaces. Let us say in the morning, today's time when it is already cold, in the morning you get up, you see water droplets on the car, windshield and all also. So this is also the similar phenomena. For dew, it is necessary that the dew point is above the freezing point. So because it is in the liquid state, it should not be beyond the freezing point. It is beyond freezing point, then what will happen? It will be possibly in the form of ice particles, right? So it should be less than the freezing point. Ideal conditions: clean sky, calm air, high relative humidity, and cold and long nights. So these are the ideal conditions which are present in your NCERTs also, and these are the questions that have been asked in your civil services. So these are something that you should keep in mind also. Now comes frost. Now please understand the difference. Dew over here is the water droplets being deposited. Frost is, let us see, these only are in the form of, let us say, ice, right? So forms on cold surfaces when the condensation takes place below the freezing point. So you see ice particles over here rather than water droplets, because the condensation is taking place below the freezing point. That is why it is all icy crystals and particles that are present here. So this is the difference between frost and dew. It is taking place above the freezing point. It is taking place below the freezing point. Clear? Next comes fog. Now again, something which has been there in the news repeatedly. Yes, Delhi has smog. That means an outcome of, again, pollution also. But majorly this is the condition which you see, very dense fog. Now see, when the temperature of a parcel of air containing large quantity of water vapor suddenly decreases, condensation takes place itself on fine dust particles. Now let us assume there is moisture in the air, yes, and you realize that the temperature suddenly decreases. When the temperature suddenly decreases, you realize the humidity capacity decreases. And then obviously it will help in what? The condensation to take place, because the air might become saturated at that time. Now, that time, whatever dust particles are present there, it will saturate, it will basically condense on those particles. And that is why you see such types of condition. That is why in the winter months, you see such dense fog where the humidity, capacity, that is the humidity capacity decreases suddenly. And that is why such conditions are there. During the daytime, why does this fog vanishes? Because of the sunlight, the capacity of air to hold water vapor basically increases. Water vapor is present in the air, but it increases because there is expansion of air. That means the humidity capacity is increasing because of the increase in temperature. But during the night time or evening time, when the temperature cools, the humidity capacity decreases. So what happens? The air might become saturated. And that is why you will realize the condensation takes place on the dust particles over here. Mist, it is also same as fog. The only condition is that there is more moisture present here. So this is fog and mist, again, go parallelly. Now see clouds. Now clouds, please remember, is also a form of condensation. Also a form of condensation. Now I have taken a very standard classification which internationally United Nations also uses, and NCERTs also mention it. They give a simplified form, but these are sometimes have been asked in various examinations, so you should be having an idea of it. I have labeled so many clouds here, right? I have drawn the diagram of the clouds also, and I've explained what these clouds are, the knowledge that you should have. So quickly we'll do it. This is something that you need to just revise it twice and thrice and 4 times. You will be in a condition to understand it. Now clouds are again aggregate of innumerable water droplets. Yes, you know that very well. This is an outcome of the condensation that has taken place of the water droplets. It might have ice particles and mixture of both in the air, generally above the ground surface. So it is taking place above the ground surface. Now formed due to the condensation of water vapor around hygroscopic nuclei. Hygroscopic nuclei against condensation nuclei, because for even the clouds also, they need a medium through or place through which they can condense. So that is why when you do the cloud seeding, you are basically providing a means for the condensation nuclei to be there. Clear? So condensation nuclei being present, only then they can basically condense. Now based on that, you realize that there are a lot of clouds at a classification that is present. There are certain high clouds present at a very high height, a greater height, 6 to 20 kilometers, like cirrus clouds, cirrocumulus clouds, and cirrostratus clouds. Let us do it along with it. Cirrus clouds, cirrocumulus cloud, cirrostratus cloud. You see here, cirrus cloud, cirrocumulus cloud, and cirrostratus cloud from 6 to 20 kilometers. So see here, cirrus clouds are high altitude, fibrous, like a fiber, cotinid type also. Fibrous, silky appearance, indication of dry and fair weather. When I talk about cirrus cumulus, these are white colored. These appear as ripples. Can you see? These are like small ripples that are present. Rare and associated with bad weather conditions. Cirrostratus over here, again cirrostratus. Like a milky, like thin sheet is present here. Form halos. You can see halos here. Form halos. Represents rising warm air along the front, and intense rain is associated with it, right? So it is basically a very, very important 3 categories under the high clouds. Let's come to the middle cloud. The middle cloud is basically from 2.5 to 6 kilometers. It represents altostratus, altocumulus, and nimbostratus. Now see here, you will see nimbostratus here, altostratus over here. So let us see a little bit about them. Middle clouds, altostratus, thin sheet of grey or blue having fibrous or uniform appearance. Altostratus, see this. Thin sheet of grey color, it is greyish in color, or a bubble having fibrous or uniform appearance. They do not form halos. Unlike the previous cirrostratus where you see halos, they do not form halos. Widespread precipitation and bad weather conditions are associated with altostratus. Now, altocumulus, wave-like layer of globular form, white or gray in color, associated with bad weather conditions. Nimbostratus. Now, please understand, sometimes people get too confused over here. So, please understand, this is what nimbostratus. Right? Nimbostratus. Dark colored clouds associated with rain and snow, but not hail. Low clouds. Stratus clouds, cumulus clouds, stratocumulus clouds, cumulonimbus. Now, cumulonimbus is associated with convectional activity. Now, it is basically rises to a very high height because of the convectional currents. And that is why we have, it is present in all these dimensions. It rises from here and goes on up, right? So, though it is present in all the layers, it starts from the lower layer. That is why we have mentioned in lower clouds. Its length, its height, in fact, depends upon the case how strong the convective currents are. Stratocumulus, gray or whitish color, generally arranged in the line and are wavy and occasional rain is there. Stratus, dense. Where is stratus? See, stratus here. Stratus, dense, dark gray color, but seldom close to the ground. It is associated with good weather and sometimes rain. Cumulus, it is like a dome shaped. Let us see here. It is like a dome shaped. Dome-shaped, flat base, sometimes thunder. Last is the cumulonimbus, which is largest cloud which you see. This is again associated with lot of convectional currents, right? Intense updraft of air that happens. That is why these might range even go to let us say 12 kilometers height. Depends upon the nature how strong it is. It might restrain to lower heights also depending upon the nature, right? Now, these are thunderstorm clouds. These are associated with vertical development, heavy rain, snow, hailstorm, and lightning. We have already done this in the previous concept where we saw a lot of tropical cyclones, cyclonic activity associated there, where we had mentioned about the these cumulonimbus clouds being formed. So, these are again associated very heavy rainfall. So, these are very important or critical clouds. Please note it down quickly. Let's move on further. Precipitation. When I talk about precipitation, what is precipitation? It is a process by which the condensed atmospheric moisture falls to the Earth's surface. Now, you know that we had earlier studied about humidity, we studied about evaporation, we studied about condensation. Now, condensation, after the condensation, if moisture is falling on the Earth's surface, it is precipitation. Under the gravity in liquid or solid form, such as rain, snow, sleet, hail, or drizzle. Now, moisture that is falling on the surface of the Earth after the condensation has taken place is known as precipitation. Now, please understand, it is a final stage of hydrological cycle, right? Or water cycle as we talk about. Now, see here. Condensation, necessary conditions, high humidity, that is means water vapor is present. Saturation of air, that means obviously saturation will take place and condensation will take place, that is important. Condensation nuclei on which it condenses. And last, growth of droplets and ice crystals. Now, this is a phenomena. There are a lot of theories also which people study in the geography optional, right? How these crystals grow. That is not necessary for your general studies for that matter. Burgeon cycle and all that is there. But over here, we simply see that growth of droplets. That means one droplet is added to other droplets and the size of the droplet increases. Why it is important? Please understand. If a droplet size is very small, please understand, if let us say rain happens, but it will not reach the surface as the droplet size is very small. Yes, there might be a lot of, because when the water droplets are falling, they might even themselves get, let us say, evaporated. Why? Because they are falling from a large, very high distance. Let us say from a very high height, they are falling. That is why the size of the water droplet should also be larger, so it falls down. That is why most of the cases, even when it is raining, it might not reach the surface. That is why growth of the droplets and having an appropriate size of the droplets, whether it is in the form of liquid state or whether it is in the form of solid state. When you see hail also, we saw large ice particles that are falling, possibly in the air, let's just say 10 kilometers or 7 kilometers above, it might be such large sizes. But by the time it reaches the surface, a lot of melting activities, let us say reduction in the size happens. That is why even in spite of that, you see large sizes of boulders of ice that are present. Those are hail. We'll see that. Forms of precipitation. Now please understand there are certain aspects you need to study. Raindrops where the diameter is greater than 0.5 millimeter. It falls in a liquid state and temperature of air column is generally greater than 0 degrees Celsius. That is why it is in a liquid state. Drizzle, it is very fine, uniform droplets with a diameter of less than 0.5 millimeter. That means lighter rain. Falls slowly with slow intensity, common in stratus clouds. You know that rain, the lesser version of rain is drizzle, right? Then comes snow, precipitation in the form of ice crystals or flakes. The entire air column which is falling is less than 0 degrees Celsius. That is why snowfall is happening. Sleet, intermediate form between rain and snow. So it is basically a mixture of snow and rain that is falling. Hail, precipitation in the form of hard layered icy balls. It might range from few millimeters to even large centimeters also. Types of precipitation. Now please understand, this is again very, very important and critical. When I talk about precipitation, you have studied these concepts in your school days also. So what do we see here? First is the convectional rainfall, then you have the orographic rainfall, and then you have obviously the cyclonic. Cyclonic we have already studied in the previous chapter where we studied the tropical cyclone and the temperate cyclone. So we will not be repeating it over here. We've already done in detail. See here, convectional rainfall. What happens is due to, let us say, rapid, in this, see in simple form you see, there is updraft of air that takes place because of the convectional, and it leads to the formation of convectional currents. As moisture-laden wind rises over here because of the convectional current, it over here is expanding, but as it reaches certain height, it will cool. After cooling, the temperature is decreasing, it will become saturated, and then condensation will take place. Now, this leads to the formation of large cumulonimbus clouds. This CN that I have mentioned is basically cumulonimbus clouds. And what is taking place? Convectional currents. This is a type of rain that occurs when the sun's energy intensely heats the Earth's surface. Now, the Earth's surface is intensely heated. Ground heats the air directly above it and causing the air to expand and become lighter and rise. Now, if the surface is being heated, the air will become lighter and it will rise. Obviously, it has water vapor, and water vapor is also a gas at that time, right? As it reaches a higher altitude, it cools and forms cumulonimbus clouds. Now, please understand, when the ground is being heated, this is a heated surface, the air will rise. The air itself has all its constituents, including the water vapor, which is a gas right now. Now, because of the heating, the expansion takes place and it starts rising. After a certain time, you will rise, cooling will take place. Cooling will take place and saturation, and with time you will realize that cumulonimbus, huge clouds will be formed. Now it depends upon the temperature that is there, the conditions that are available there. It can be very huge also. And later on you realize there is condensation, and you realize very heavy rainfall is also associated with it. Usually occurs as heavy, short-lived downpours accompanied by thunder and lightning. This is what the convectional rainfall. Other is relief or orographic rainfall. Very often, like for example, in the Western Ghats region, you would have seen like moisture-laden winds are coming from the Arabian Sea. They encounter the Western Ghats. The moisture-laden winds basically try to rise. As they rise, what happens? They cool. When they cool, obviously condensation will take place over there, formation of clouds take place, and there is again precipitation. Right? So this is what is the concept. This side where rainfall is taking place, this is known as a windward side. Over here, most of the precipitation, whatever the moisture was present here is shedded over here. Over here, you realize lesser amount of rainfall is there because most of the moisture is shed on the windward side. This is known as a leeward side, which is on the opposite side from where the moisture-laden wind is encountered. So this occurs when an air mass is physically forced to rise a mountain or highland. So that means air that is full of moisture has come here and it encounters a mountain, let us say Western Ghats for that matter. It will be forced to rise. As it will force to rise, it will lead to cooling, and then slowly what will happen? It will lead to the formation of clouds and then condensation. Because of that, condensation process happens, and then what happens is clouds formation itself is a form of condensation, but you realize it will lead to a lot of rainfall in this particular region because of that. So the moist air blowing from the sea hits the mountain, forced to raise upwards, where cools and condenses into clouds. As the condensation takes place into clouds, obviously with time you will realize that rainfall will be there in this particular region. As Yes, this region will have received certain rainfall, very minimal, but this is the main region. That is why it is known as a windward side. Let's move ahead. Cyclonic rainfall. Now, this is associated with the presence of low pressure regions in the center. You know that very well. We have done in the previous chapter also. Anticyclones are high pressure regions that they are associated with what? Stability, right? Clear skies. Cyclonic conditions are associated with the center region being low pressure, and obviously it is of two types. You would have studied in the previous chapter the tropical cyclones and the temperate cyclones. Both are associated with a lot of rainfall activities. We have done this in the previous chapter, so please revise that because both the concepts are done. In the temperate cyclones, we have even done the various sectors also within a temperate cyclones where rainfall, various kinds of rainfall that is happening. Rainfall variation. Now, see, this is a classification which we are going to do in the next chapter, but just written over here. If you see, this is how a classification is done. From 0 to 10, you have the equatorial rainforest. On the eastern side, you generally have monsoon, in the middle savanna, and the side tropical or subtropical desert. Let us say if you go from 30 to 45 degrees, on the western side, you have the Mediterranean type of climate. In the middle, steppes or temperate desert. On the eastern side, the temperate, the China type. If you go from 45 to 60 degree, you have on the eastern side, the Laurentian type. On the western side, the British type. And between them, Taiga type. From 60 to 80, you have the tundra, and beyond that, ice caps. We will be doing this in the next chapter, the classification, but just a reference. Why? Because I'll be using them in this classification, right? Now, rainfall variation, how it is varied. Let's see this. Greater than 200 degrees Celsius is present in the equatorial rainforest in the regions of Amazon forest, Congo Basin, Indonesia and Malaysia. Monsoon region, that means over here if you see, monsoon type of climate is present here. Like the western slopes of the Western Ghats, northeastern India, Vietnam, Philippines, Thailand and coastal Myanmar. British type, areas of Washington State, Alaska, Colombia over here, right? Next, 100 to 200, west of the monsoon areas, the areas on the west of the monsoon areas like in parts of India and Southeast Asia. China type, in the regions of East Asia receive these 100 to 200, East Asia and Southeast United States. Laurentian type, coastal areas of parts of China, Korea and Japan. Parts of British type and large parts of the Savannah region receive close to 100 to 200 centimeters of rain annually. 50 to 100 in the interior parts of the monsoon climate like we see in India. Rest of the Savannah, coastal Mediterranean region, interiors of China type, Laurentian type and British type and parts of Taiga. 25 to 50 centimeters is basically referring to the semi-arid conditions which we see in the boundaries of the desert like the steppes. We see in the shrub Mediterranean, continental parts of the British, Laurentian and the Taiga type. When we go to the arid region, which is less than 25 degrees Celsius, we come across subtropical desert and the temperate desert. Tropical, subtropical desert include like the Atacama, Sahara, Arabia, Thar, Namib, Kalahari, etc. We've already done this in all these labelings have been already done in the mapping series which we have completed it. And one short video has already been uploaded. Temperate desert, Patagonia, Central Asian deserts and Mojave desert. So these are the temperate. So they have received less than 25 centimeter of rainfall. Now, though this is part of India, but I'm just covering it because we are doing the concept of rainfall. Let us do it from the perspective of India also. If you see, this is a handmade diagram again, a map. The regions which you see are in red. These are areas of high rainfall. This can be asked in your paper, so be very careful about it. 200 centimeters, greater than 200 centimeters is over here, this part and this part, right? Now, if you go to the regions from 100 to 200, you will realize that the regions adjoining the high rainfall regions, these coastal regions and this belt which is present here, this is basically medium rainfall from 100 to 200. If you see from, let us say from 50 to 100, this region, interior part, even this are from 50 to 100. If you see the least, the conditions where rainfall is less than 100, you see the regions of Rajasthan, over here Karnataka region, some parts of Madhya Pradesh also, and the Ladakh region. Let us see this now. Average annual rainfall in India is 125 centimeter. Areas of high rainfall, rainfall greater than 200 centimeters. Western coast of the Western Ghats, you have seen sub-Himalayan areas in the northeastern region and hills of Meghalaya. Khasi and Jaintia, rainfall greater than even 1000 centimeter, right? Areas of medium rainfall, which is from 100 to 200 centimeters, right? Southern parts of Gujarat, eastern Tamil Nadu, Bihar, eastern Madhya Pradesh, northern Ganga Plain, Kachar Valley. Manipur, Odisha parts, not all, only the parts of Odisha. So make it very clear about it. When we move ahead, we realize that areas of low rainfall, that means rainfall between 50 to 100 centimeters, Western UP, Delhi, Haryana, Punjab, Jammu Kashmir regions, Eastern Rajasthan, Gujarat and Deccan Plateau. When I come to the areas of inadequate rainfall, that is less than 50 centimeter, which we have already seen in this yellow part. This is basically parts of peninsular, especially Andhra Pradesh, Karnataka, Maharashtra and Ladakh. And Ladakh parts, right? And the Ladakh region. Okay. Variability of rainfall. Variability means between that how much variation is there annually when the rainfall bed is received throughout the year. So if you see the desert regions, they have a very high variability, greater than 60%. If you go beyond towards the eastern side, this is a region which have 30 to 60%. If you see the other parts, these are what? 15 to 30, and the regions which receive very heavy rainfall throughout the year, they have the least variability, like this region 15% or 15%. This is something that you should know. Why? Because the questions can be asked on them also. The topics which we are doing is climate classification of the world and the climate classification of India. Though this is, we don't have to do the climate classification of India here because we have already done this in the Indian geography when we were doing it earlier. So what is important is over here that you can refer to that, but I am going to put a map here and briefly explain it so that it basically helps you to analyze how Köppen had basically given these alphabets. When I analyze, you will be able to understand it. Now let's see. This is a beautiful photograph of the earth. You realize that this is a patch which is in white, this is in green, referring to the Sahara Desert. This is again the region where you have permanent ice cover. So you realize that why we are studying climatology or the classification, again very important. In whichever region you are lying or staying, there's a climate associated with that. And with that climate association, you know that everything is associated with that. For example, what type of vegetation is going to be there, what type of precipitation is there, what type of, let us say, human activities are there. Why? Because now you know that very well. If you are in close to the region of Arctic Circle, you cannot have cultivation going on as you have in the Gangetic Plain. Yes? So similarly, you will have the dietary habits that are going to be changing completely. People might indulging in, let us say, lumbering activities in those regions. They might be indulging in hunting and gathering activities in those regions, right? They will be indulging in heating activities or heating the region continuously because it is so cold. So things are going to change completely. That is why studying the climate topic comprehensively becomes very, very critical here. So let's move ahead and study. So this is something that is mentioned in the NCERT, this particular slide which I have modified to make it good. This question has been asked in UPSC as well as the PCS papers, Uttar Pradesh and Uttarakhand also. So if you want to study the world climate, there are three broad approaches. There are three broad approaches or ways in which you can study the climate. First is the empirical classification. Empirical classification means that you are going to various places and you are gathering the data. Let us say precipitation data, temperature data, pressure data, whatever. And based on that, you have a data for all the regions, and based on that, you are classifying the regions into various groups based on the parameters that you have. That is why it is known as empirical classification. Now, if you want to classify based on the causes, what is the cause behind this climate, then it is basically referred to as genetic classification. Genetic classification, that is according to the causes. Third is a classification where you basically see that you require certain classification because you have a specific purpose in mind. Let us say you want to know the climatic classification because it is associated with vegetation, or let us say agroeconomic zones. For that, climate is required, agroclimatic zones, whatever be the case. In that particular case, you have a specific purpose for which you are making this classification. Then it is known as applied classification for any specific purpose. Over here, the word is missing, specific purpose. These are three categorizations. Now, you can be asked in the paper. They can put genetic, they can put empirical, applied, and then they will help you, they'll ask you to match them. Possibly if you haven't studied these three things, you will get it wrong. So please know them. Clear? Okay. Copy it. Next. Again, I'm repeating that for general studies, you do not have to go beyond Köppen. You do not have to go beyond Köppen. Why? Because if you have optional subject of geography, then you have to do 4 or 5 thinkers, different classifications, again or all the explanations. For GS, only Koppen, that is it. Now, Koppen's classification, again, why? Because it is famous also, it has been revamped. So let us see these things. Please remember, this has been asked in one of the PCS papers also. It can be asked in UPSC. Now, Koppen's, it is an empirical classification. That means it is using certain data and analyzing them. So what are the data he's using? It is based on the mean annual and mean monthly temperature and precipitation data. So he has gathered all the mean annual temperature and precipitation data, and based on that he has classified. Used capital and small letters to designate the climatic groups and types. So now please remember, what he has done is he has labeled various groups and their various types and used letters, capital letters and small letters, to categorize them. The capital letters, if you realize, these are the basic groups, and then small letters you will see other types. So these have been used for his classification, right? It was developed in 1918 and it has been revamped after that also. That is why it is again one of the most common and the most famous classification that you come across. So these 4-5 statements which I have written here has been asked in the PCS itself. That whether it is empirical, they might simply write that Koppen's classification is a genetic classification. Or they might write Koppen's classification is an applied classification. You will say, okay, fine, it is applied, it can be applied anywhere. No, please remember, that is why. What is mentioned in the NCERT is what is considered right by UPSC. So you should be very clear about these statements. That is why whatever was required to be picked from the NCERT, I have picked them very, very categorically and put them on the board. Where you might make mistakes, that is the reason. Now, let us see the various characteristics with respect to the climatic groups. These are the groups, broad categorization. Then there are subdivisions of B and E, and there are types. Now you need to remember them also. Why? Because UPSC has repeatedly asked these questions in its various examinations, whether it is CAPF, CDS, even NDA papers, whether it is PCS papers. So please be very well aware of this. A basically represents tropical. What is the characteristic? Average temperature of the coldest month is 18 degrees Celsius or higher. That means it is lying in the equatorial region. So it is obviously the temperature is going to be all the time high only. B is a dry climate. Again, referring to regions like the desert, arid and semi-arid regions where the evaporation or potential evaporation is even more than the precipitation that is taking place. So when there is more evaporation that is taking place than in comparison to what is the precipitation coming, so what you realize that it is going to be arid condition. So that means it is going to reflect approximately a desert-like climate, right? We'll see that. C is a warm temperate. Average temperature of the coldest month is higher than -3 degrees Celsius but below 18 degrees Celsius. D is a cold snow-covered forest climate. Average temperature of the coldest month is -3 degrees Celsius or below that. E is a cold climate. Average temperature for all the months is less than 10 degrees Celsius. And last is H is highland, cold due to the elevation. Elevation, that means supposingly if you realize certain regions which have a very high altitude, and because of the altitude, whichever region they belong, at the top you will realize there is going to be the characteristics are going to be very cold or snow-covered regions can be there. Why? Because as you move up, there is decrease in temperature. You've already done that. Normal lapse rate says that there is a decrease in 6.5 degrees Celsius per 1000 meter. So similarly, the temperature will fall, and at the top you will see snowfall. Even a lot of mountain peaks in the African region which are close to the equator, but the tops are covered with snow. Why? Because of the altitude, right? So this is due to the elevation. Now B and E are categorized into two further subcategories. B is dry climate. It is further classified into S, that is a steppe, that is the semi-arid. Now steppe, please remember, in simple words, these are again the temperate grassland type region, right? Some of them can be semi-arid also. Steppe is basically, we'll go ahead and we'll study all of them also. So what are the characteristics? Meanwhile, W represents the desert, right? E represents the cold climate. It is further divided into T, that is a tundra. F is a again, ice cap, permanent ice cap is present there. Now, further climatic types. These are small letters which we had mentioned earlier in the introduction to Koppen. Small a, hot summer, average temperature of warmest month is greater than 22 degrees Celsius. C, cool summer, average temperature of the warmest month is less than 22 degrees Celsius. F, there is no dry season. W, dry season in winter. S, dry season in summer. Now, if you realize that's dry season in summer, you say, how come dry season in summer? If you realize regions like Tamil Nadu, which receive rainfall majorly during the northeast monsoon, you will see they will be having S type of climate also there. Subgroup. Obviously, there are going to be other categorization. We'll combine them. These major groups and types are combined to have an exact climatic type that is present. So whatever I have mentioned over here, these and these small, these are combined. These alphabets are combined to represent what the characteristic classification of a region is. H, average annual temperature less than 18 degrees Celsius. M is a monsoon type, short dry season. So these are the climatic types. These are the climatic groups. Now, based on these explanation and types, please understand, Köppen has basically classified into a lot of types, right? Some might not be present in India, some might be present. But again, from the world perspective, what we're going to do is we'll explain them after this basic understanding. We'll go on to all these things, right? Now, tropical humid climate is divided into three categories. Tropical wet, that is AF, no dry season. Tropical monsoon, AM, short dry season. Tropical wet and dry, AW, winter dry season. If you realize this, AF, how come this has come? If you see A is tropical, that is average temperature of the coldest month is 18 degrees Celsius or higher. F, no dry season. Where will you find no dry season? In the equatorial region where there is continuous rainfall. That is why, how does this alphabet come? AF, that means tropical wet. All the time it is wet. So there is no dry season. So no dry season. So these alphabets have been combined. Understood? Tropical monsoon AM, short dry season. Tropical wet and dry AW, winter dry season. B, that is a dry climate, which has been divided into further four categories. Subtropical steppe, BSH. B was a dry, S is a steppe. Again, B was divided into two categories, B, S and W. So BS. H, if you realize, we have already understood that average annual temperature is less than 18 degrees Celsius. So low latitude semi-arid or dry. Subtropical desert, BWH, low latitude arid or dry. Mid latitude steppe, BSK, mid latitude semi arid or dry. Mid latitude desert, BWK, mid latitude arid or dry. Warm temperate mid latitude climate, that is C, this is divided into three categories. Humid subtropical, CFA, no dry season, warm summer. Mediterranean, very important, CS, dry hot summer. Marine west coast, CFB, no dry season, warm and cool summer. D, snow covered forest is divided into two categories. Humid continental, DF, no dry season, severe winter. Then subarctic, DW, winter is dry and very severe. Cold climate is divided into two categories, tundra, ET, and polar ice cap, EF. Tundra is no true summer and this is perennial ice covered. Highland, it is H, high with snow cover. So this is again the possibilities that he has given. These are the possibilities of the type of climate that you can come across the world. Now, based on these, I am going to make you understand what is now mentioned in G.C. Leong with their explanations. I have covered the NCERT part also inside them and added more content from G.C. Leong so that you do not have to go or get confused with respect to this classification. Many times, multiple times, let us say, they will ask you Mediterranean region or Mediterranean type of climate is found in what regions or which regions? The British type is found in which region? The Laurentian type is found in which region? You are blank in that case, right? So we have added that. So I have covered all these things over here, so you will not face any problem. Let's see. Tropical wet climate AF, right? Now AF, geographical distribution typically found near the equator between 5 to 10 degree north and south of the equator. Now found in the lowlands of Amazon, Congo, Malaysia and East Indies. Let us see the map first of all. When we are doing geographical distribution, see, this is the region of the Amazon basin. This is a Congo region. Then again you have the Southeast Asian region. So this is where you find AF. Keep in mind the map. That is why I have drawn map for every single climatic type now. AF. Now let's come back to this point. AF. Temperature. So the temperature over here again, you know, it is lying close to the equator. The temperature is going to be high. The average temperature is throughout there 25 degrees Celsius, which might range from 20 to 30 degrees Celsius, right? Precipitation, abundant rainfall throughout the year, greater than 2000 millimeter or more. So there is tremendous rainfall throughout the year and it continues. So there is abundance of rain here. Vegetation, again, this is again a region of tropical rainforest. right? Dense canopies there, dense forests are present there. You know, you have imagined the Amazon rainforest itself, which is known as the lungs with respect to the oxygen. Mahogany, ebony, cabinet wood, dyewood are found here. Epiphytes are also found. These are those plants which basically grow on the surface of the other plants. These are epiphytes, very characteristic feature of this type of climate. Life and economy, this is basically practice shifting cultivation, livestock farming and plantation. Plantation of coffee, sugar cane, cocoa, spices and tobacco are very common presently here. There are certain regions which are again have certain mineral resources, like if you see Congo, it is the largest cobalt reserves also. So cobalt mining on a large scale is done here. Along with it, Brazil and Peru also have gold reserves. And that is why gold mining is also done in these regions. So this is again, we are covering the economic activities also, climate also, life also comprehensively. Clear? And then we have already done this map wherever it is present. So we have done with AF, that is tropical wet climate. Let's move on to the next, tropical monsoon climate. Now tropical monsoon climate, you remember AM. Geographical distribution, they occur between 5 to 30 degrees north and south of the equator. It is obviously present in the Indian subcontinent, Myanmar, Thailand, Laos, Cambodia, parts of Vietnam, South China and northern Australia. Now let us see the map. These are the regions where you see the AM is majorly present. True monsoon is present here. AM. Clear? So having studied this, let us come back climate. Now you know that very well. You have already done the monsoon with me in physical geography of India very clearly. And you know that how the reversal of winds take place. Southwest monsoon, northeast monsoon. So the characteristic feature of monsoon is the seasonal reversal of winds. And this is where seasonal reversal of wind is being mentioned. So there are distinct seasons are present. Hot dry season, cold dry season, again the rainy season. So there is, because you know that specific season is for rainfall, right? Rainy season. If you realize that southwest monsoon, when it comes, it brings a lot of rainfall, major amount of rainfall. So there is a specific rainy season in India, or for that matter in the monsoon type. Temperature, monthly temperature is average monthly temperature 18 degrees Celsius, but again you need to know that this is average. There are again summer and winter temperatures vary greatly. Summer temperature might go to 30 to 45 degrees Celsius or even more, and winters might go from 15 to 30, depending upon there might be certain regions where it might go even further below. Rainfall, it is again wet and dry, distinct wet and dry season. As I mentioned, during the monsoon season it is very wet. Other seasons you might see dry seasons also. Before the monsoon season, you have a spell of dry season. Vegetation, wide variety, lush grain forest, deciduous forest. Now you realize you're moving away through a region receiving very highest amount of rainfall, that is the rainforest, that is AM. And you going to a region which has relatively distinct season where rainfall might not be there. So that means it has lesser amount of rainfall. So it might be having rainforest also, but it will be having other types of forest like the deciduous forest. So lush green forest to deciduous forest. You have the sal, teak, bamboo, mango, mahua, jamun, neem, shisham. Again, life and economy basically revolves around agriculture activities and lumbering activities. That means cutting the wood. We have done the map also, that is AM. Let's move on to the other, tropical wet and dry climate, savanna or the Sudan climate. Please remember, this is referred by AW. Whenever the word savanna comes, something should come in your mind very clearly. These savanna means tropical grasslands. These are alternative words which you might be asked. Savanna is a tropical grassland. It can also be known as Sudan type of climate. It can also be known as tropical wet and dry climate and represented by Köppen as AW. When we are talking about steppes, those are basically temperate grasslands. These are tropical grasslands. You can be asked questions on these also. Clear? Now see, geographical distribution, Africa, South America, North Australia and India. It is known as Llanos in Orinoco Basin, Venezuela, and Campos in Brazilian highland. Now, you can be asked a question where they might be mentioning Llanos, Campos, they might mention steppes, they might mention prairies, they might mention pampas, and they will ask you which among the following are tropical grasslands. Because these two are tropical, the others are what? Temperate grasslands, which we are going to do. So you should be very well aware which are tropical and temperate. Now let's see the map, you will analyze it. Tropical grasslands over here, it is Llanos, again you will realize in the this is region again, in the Venezuela region it is present. Campos you will realize in the Brazilian region it is present. This is the African savanna region, the upper part is known as Kano and this is known as Salisbury region. This is known as the Australian savanna. So you can be asked any of the words and asked in the question in the prelim examination also that which among the following refer to as the tropical grasslands. If they want to twist your leg a little bit more, they might ask you which among the following are associated with Sudanese type of climate or savanna. So you should be clear that these are the same names: tropical wet and dry, savanna, Sudan climate, AW. Clear? Next, there are distinct summer and winter season. There is no distinct rainy season present over here. Mean annual rainfall is 800 to 1600 millimeter. Temperature, if you realize, again, average temperature is 20 to 32 degrees Celsius. Again, it might go a little further also, but consistent warm to hot temperature throughout the year is a classification, a categorization. If you see the vegetation, as I told you, these are tropical grasslands. So the grasslands and the scattered vegetation is a characteristic feature where again the grasslands are present, again there are scattered trees also present here. So scattered trees towards the arid region, rainfall decreases and you see a thorny scrubland. Now please understand, from the region of AF, you went to the region of AM with lesser rainfall, then you went to the region of AW, which is basically referring to as a tropical grasslands. Now, along with that, other extreme would be the desert region. Now, where the boundary of the tropical grasslands end and you have the region of desert, you will realize that in that zone, you have certain characteristic feature which are closer to desert. So that will have the thorny scrubland also as you move closer to that arid region. Life economy, livestock rearing and agriculture, again in some regions where it is possible. Like for example, the Maasai tribe in the East African region are involved in pastoral activities, whereas Hausa tribe in the West African region are basically cultivators or practice settled cultivation. Clear? Next, we have already done the map. Next comes the hot desert. You remember BWH? Now please remember one thing. The hot desert again are those regions which you know very well, can be asked in your paper, that which of the following are referring to as hot desert or the cold desert. For example, if I mention Gobi desert, right? If I mention Patagonian desert, now those are cold deserts, but these are hot deserts. So you should be very clear which are hot deserts and cold deserts, which I'm going to tell you now, right? We'll do hot desert and we'll do cold desert also, which are known as temperate deserts also. These are the questions which you had been missing till now. You were thinking of where we should we study these, from where shall we get the answers. It is basically this climate classification from which you were being asked and you were not aware of that, right? So BWH, these are also known as trade wind deserts. Why trade wind deserts? You know that very well, that trade winds, when they come to this region, those trade winds are offshore. When they come to these regions, they basically have no moisture. So they basically lead to arid conditions in these regions. What do you mean by arid conditions? See, any winds that are flowing, which are not bringing moisture, they are not going to add value with respect to the water vapor or let us say the rainfall over there. So what is going to be their arid conditions majorly? So they are conditions of permanent drought. There are various deserts like Sahara, Great Australian Desert, Arabian Desert, Kalahari, Namib. So let us see these aspects also first of all. Now when you see the geographical distribution, you will see the hot desert climates are typically found near the Tropic of Cancer or Capricorn on the western coast of the continent. They are found on the western coast of the continent, usually between 5 to 35 degree north and south of the equator. Certain things you will analyze is why western coast. And when I mention these statements over here that they are found in, these are the deserts that are found. Let us see the map first, as we have done for the earlier ones also. If you see the regions of North America, you see 3 major deserts. So you remember that we have done the mapping series also in this particular channel. I've done all the deserts there also. So you should be very well aware of it. If you haven't done, please go through the one short video of the mapping series which we have done. Sonoran Desert, you have the Mojave Desert, some people call it Mojave also, but again, however you pronounce. Chuham Desert over here. These are what? Hot deserts, right? Then you have the Sahara Desert, you have the Somalian Desert, Arabian Desert, Thar Desert shared by India and Pakistan. If you go further south, you have the Namib Desert, you have the Kalahari Desert, all hot deserts. Then you come to Australia, which is known for a large number of deserts. See, so some of them are the Great Australian Desert, you have the Simpro Desert, then you have the Tanami Desert, you have the Great Sandy Desert and the Gibson Desert. So these are the deserts. Simpson Desert again is one of the Simpson Desert is also one of the important deserts which you basically have studied when we were doing the Australian mapping series also. So all these deserts which I've shown you here are the hot deserts. Now you can be asked, they can mention certain names of the cold deserts also, and they can ask you which among the following are the hot deserts. So you should be aware of them. Clear? Let's see the characteristics. I had already mentioned they were found between 15 to 35 degree north and south of the equator, and basically on the western coast. Why western coast? Why western coast? There are certain reasons behind them. First, offshore trade winds. I have already told you the offshore trade winds which are flowing are not carrying moisture with them. And if they are not carrying moisture sufficiently, you realize that they are not going to produce rain. If they are not going to produce rain, they will be not contributing to any rainfall. So that means there's a possibility of aridity being there. Second is cold currents. The cold currents that are flowing along the coastal regions, remember that they hinder the precipitation to take place in those regions, because they might, they are like the barriers towards, because they create cold conditions there. So it is not going to be possible for the rainfall to take place there, right? So when we talk about these cold currents, these are also a very important contributing factor. Descending wind circulations. It is quite possible that in certain regions where wind is descending now downwards, it might create certain high pressure region or acidic condition. And that is why you know that very well when we are talking about desert conditions. The important thing that happens is that for the rainfall to take place, if there is certain convection, there is updraft of wind, updraft of air in the form of wind. It might move upwards. If it has sufficient moisture, it might move upward. It might, let us say, cool. It might condense because of the saturation, and then cloud formation, possible rain. But if there is descent, right, what happens? It creates to relatively high pressure condition. High pressure conditions again are somewhat that is not favorable for the precipitation to take place. That is why descending wind circulation is again also responsible for that. Temperature, daytime temperature may be above 40 degrees Celsius or even more in certain regions. In Libya, you have recorded more than 55 degrees Celsius also. Diurnal range is very high. Why diurnal range? What do you mean by diurnal range? Diurnal range means that day and night temperature difference is very high. Why? See, these are regions where you know that I have told you moisture is lacking, so there is no cloud formation also. During the daytime, so the complete insolation is coming, and that insolation heats the land to a very great degree. And that land heating basically heats the surrounding air also, which is in contact. So the temperature is very high. It might go to 50-55 degrees Celsius also. Now during the night time, you know that because of the specific heat of the land, it cools down very quickly. Cooling down very quickly basically leads to the terrestrial radiation that is in the long wave being thrown out or radiated. The clouds are not present there, so what will happen is there is no barrier towards restricting the going out of the long wave terrestrial radiation. So what will result in that it will quickly lose the heat also. So the night temperature might fall down tremendously. It might fall down to, let us say, 5 degrees Celsius, 4 degrees Celsius, or even more. And that is why the range is relatively high between the day and the night time. Next, precipitation is less than 25 degrees Celsius. What are the reasons? Again, the same reasons. Why it is less? Because again, subtropical high pressure belt is there, offshore trade winds, low humidity and cold currents. So everything that is mentioned here, similar reasons why the rainfall is less. Vegetation, if you realize, xerophytic vegetation like cactus, which has basically adapted itself to these extreme climatic conditions where they have adapted to that condition. They have long roots because in search of water, the roots go deep. Then they have few or no leaves. Leaves are a means through which again transpiration processes take place along with other processes. So in order to prevent the loss of water, they might not have any leaves. A few leaves or no leaves. Another feature that they have is waxy, leathery, hairy or needle-like structure, which basically help to reduce the loss of water. So these are modifications that are present here, right? Life and economy, nomadic pastoralists like they might be indulging in pastoral activities related to camel and goat or even sheep. Oasis farming of dates and vegetation, mining, oil and minerals might also be possible over here. These are the economic activities which they basically indulge in. Now, this is the map which we had done. Let's move to mid-latitude desert. Now, this is BWK. Now, these are the temperate deserts or the relatively colder desert which we had discussed. Let's see this now. See, these are temperate deserts because again, you know that very well, they either are because of the continentality effect. Continentality means that they are located in the interior regions of the continent where they do not receive sufficient rainfall. Or the rain shadow effect, that means by the time the winds reach them, they are not carrying sufficient moisture for them to shed there. So that means these are regions where are again acidic conditions, but they are cold desert. Reason, we'll see them. Geographical distribution found at the higher latitudes. So automatically higher latitudes basically contribute to the weather conditions being relatively colder also. Usually between 30 to 50 degree north and south of the equator. Now let us see the map over here to analyze where they are. This is something very, very important that you should know. That you can be asked. You can be given a list where hot and cold deserts are mentioned and you have asked which among the following are hot or cold. Great Basin over here, above the Mojave or Mojave Desert as you say, is the Great Basin. If you come to South America, you have the Peruvian Desert, Atacama Desert and Patagonian Deserts. These are cold deserts. Do not get confused. Then you have the Iranian Desert, Kizilgum Desert, Gobi Desert and Taklamakan Desert. All these are cold deserts. Colder deserts, right? Let's see here. They experience greater temperature variation than hot desert. Why? Now please remember, if you see them, during the summertime, the temperature, because see, again, the cloud cover is not there. So during the summertime, they receive a lot of insolation and the temperature increases to, let us say, greater than 30 degrees Celsius also. But during the night time, it might go much below the freezing point. So if you see the variation or diurnal range, you will see it is much more than even the hot desert. Because in hot desert, it is not necessary that freezing temperature is going to be there. No, but here it might go a lot below the freezing temperature also during the winter time. So we realize that the variation or the diurnal range with respect to the temperate desert is even more than the hot desert. This is something that you can be asked as a statement in your preliminary examinations. Precipitation less than 25 degrees Celsius, as you know, this is an arid condition. But unlike the hot desert, they have a more predictable rainfall pattern. See, in the hot desert, it is very sporadic. When it is going to rain, nobody knows. But in this region, it is relatively predictable. Yes, you can know there is going to be specific, some rainfall is going to be there. It can be predicted. Unlike hot desert, because those regions are where any sporadic instance might happen and it might rain, but not here. It is more predictable in these regions. Vegetation, drought-resistant shrubs, grasses, and some trees are adapted to arid conditions. Life and economy, again, nomadic pastoralism, trade and exchange between the tribes that are present in these regions are basically involved in them. So let's move ahead. Warm, temperate, western margin, very, very important. This is Mediterranean climate. Now please remember, this is known as winter rainfall climate. It is denoted by CS. When we were doing the chapter of the pressure belts, I had very categorically mentioned what is the reason behind this type of climate. If you realize or revise that concept, I had told you during the time of the summers, Mediterranean region is under the influence of the trade winds, which are again offshore and they do not provide them with moisture. During the time of the winters, due to the pressure belt being shifting, the region of close to 30 to 40-45 degree latitude comes under the influence of the westerlies. Now the westerlies pick up moisture while crossing and they provide moisture to the western margins of the continent. And that is why they receive the winter rainfall. So this is the reason which you should be very well aware of. This can be asked in your preliminary examination as well as the mains examination. So it occurs along the western coastlines of the mid-latitude between 30 to 40 degree north and south, as I've already mentioned in the western coastlines, commonly found in the western coastline regions of Mediterranean basin of southern Europe, coastal California, parts of South America, regions of Chile and South Africa. I'll show you the map also, but remember, though it is based on the name that is around the Mediterranean basin, but the best region which is suited for the description of this particular climate is central Chile. Central Chile. So if you are asked in the examination, they mention these four options and they ask you which among the following represents or the best representation of the Mediterranean region. You will say, "Arey, all of them are a representation of Mediterranean region." But the best is central Chile. So remember that this can be asked in your papers also. Let us see the map. This is the California region again. This is the region of Chile. Again, western margins if you realize. Then this is the Mediterranean basin. This is again South Africa, and this is Australia, southern part. So these are the regions which are experiencing what? The Mediterranean climate. And you have understood the reason also. I've explained you the concept of the westerlies during the time of the winters. Westerlies because they flow from west to east, right? Easterlies are the ones which flow from east to west. Clear? Okay. So if you see temperature, they have mild winters with temperature rarely falling below freezing point, and hot dry summers around 25 degrees Celsius. Then also it is pleasant only. Temperature of the coldest month is less than 18 degrees Celsius but greater than minus 3 degrees Celsius, and the warmest month is greater than 10 degrees Celsius. So it is pleasant almost throughout the year if you see. Rainfall from 35 to 90 centimeter. Summer experiences minimal rain, while winters obviously experience rainfall due to the westerlies, and there might be certain sunny days also associated between the rainfall that happens. Now if you see vegetation, please remember this, that this word again has been mentioned in the G.C. Leong and certain important books. This can be asked in your papers. Chaparral word. Now this is again consists of the drought resistant shrubs and evergreen trees like olives and cork and certain grasslands which have adapted themselves to the Mediterranean climate. That climate where it is going to rain during the winter and it is generally dry during the summer. So this is a characteristic feature, chaparral, along with mealy, Matorral, Maquis or Gorecchio and Fenbos. These are the characteristic vegetation of the Mediterranean Sea, and you can be asked question on any of them, like which among the following is associated with the Mediterranean climate or not. Species like pine, fir and cedars are also found. Bush and shrubs again are very common or predominant over here. Life and economy, agriculture, citrus fruit export, viticulture and cattle rearing. Please remember, these are regions which are very famous for wine. So citrus fruits are grown because this climate is very suitable for them. Citrus fruits are grown on a large extent. Again, grapes, cultivation of grapes for making wines is viticulture, right? So large number of brands associated with wine making are concentrated in these regions also, right? Okay. Next, temperate continental or steppe climate. Now steppe climate, do you realize, if I had mentioned it earlier also, I told you these regions are temperate grasslands. Savannas were tropical grasslands. So you associate them with BSH and BSK, both of them. They are found between 40 to 55 degree north and south of the equator. It lacks maritime influence because it is located in the interior of the continent. They are far away from the ocean, and that is why you realize there that these climates that are found are because of the continental effect also, right? So they are away from the influence of the maritime, being entirely in the continent. Great plains of North America, Eurasia, steppes, parts of Central Asia and Pampas. We are going to see the map. Don't worry about that. Don't worry that I'm reading it. We will see the map also. Now let us see the map which I have mentioned. Prairies are the are what? The temperate grasslands of North America. Pampas, South America. Steppes again in the regions of Eurasian region or Russia region. Then you have the Manchurian grasslands. You have the downs in what? Australia. You have Canterbury grasslands in New Zealand. Now comes the veld, V-E-L-D. Please remember, whenever you read this veld, it is associated with South Africa. You know that very well. But now there is further classification. In South Africa also, in the northern region, the veld is known as bush veld. In the southern part, it is known as high veld. So please do not commit this mistake. Bush veld in the northern part of South Africa and high veld in the southern part of South Africa. So these are what? The representation of all the steppe type of climate or the temperate grasslands. So you should be very well aware of them. Please note them. That is why I made the map, so that you remember it throughout your life whenever you're giving the paper. Now see, temperature. Summers are generally warm to hot, 18 to 20 degrees Celsius, while winters are cold, temperature is less than 0 degrees Celsius. That is why again temperate grasslands, because during the winter months it is again regions have massive snow cover also. Precipitation, low rainfall 25 to 75 annually. Dominant vegetation is grassland, as you know, these are grassland regions. Grasses are tall, fresh and nutritious. Moving poleward, as you move towards the polar region, you realize wooden steppes with conifers are also found there in the upper latitudes. Life and economy, agriculture, wherever it is possible during the months when it is not covered with, when there is not extremes of temperature, then during that time agriculture is possible. Cultivation of wheat, barley, maize and other grain crops are possible, and otherwise you realize pastoral activities or sheep rearing is also very common activity in these regions. This is again the representation of the map. Now comes the warm temperate eastern margin, that is the China type. Now please understand, China type, which is named by CWA. Now this CWA climate is basically a modified type of a monsoon climate only. It is not only found in China, found in other parts also. So you can be asked a question that China climate is found in China only. No, other parts also you'll see them. That is why these regions become very important. Now see, in central and north China, including southern Japan region, southeast USA, natal East Australia, southern Brazil, Paraguay, Uruguay and northern Argentina. Let us see the map now. This is the distribution. You see these regions of Northern American region, you see the Southern American region, you see the African region, you see the China region, and you see the Australian region. So based on this type of climate, the other regions have also been named. Clear? Now let us come back. Temperature, warm, moist summer and cool and dry winter. Average monthly temperature fluctuates between 4 to 25 degrees Celsius. Now rainfall over here is 60 to 150 centimeter. It is moderate. Vegetation over here is lush vegetation, feathering both evergreen and broadleaf forest and deciduous forest. That is why we call it a modified form of monsoon also. Life and economy, agriculture over here, corn, cotton, tobacco, rice, tea, sugarcane and dairy. Dairy forms an important ingredient in these regions. Let's move on to the next. That is the cool temperate western margin. That is a British type of climate. It is known by CFB. Now, it is named after again the British Isle region, that is the UK and the Ireland region where the climate is found, and similarly found in other regions also. You will realize that this is again those type of climate which is considered to be very optimal for humans to survive or live. Right? Now this was also a basis of the reason why Britishers used to say that we are the people who were born in this land, that is what they call as a father's land, the Great Britain, and they were bound to be rulers. Right? They used to use it. They said that this is a region where best of the climatic type is present and which is optimal for the development of human beings and to be intellectual enough to rule the world. So again, now the thing was that this region or the climate which is present in these region is suitable throughout the year. So that is why it is considered most optimum for the human efficiency. Please understand why it is known as human efficiency. See, when there is extreme of warm, let us say very hot temperature, a very high temperature is there, 40 degrees Celsius, you are unable to work properly. When it is extreme cold, you are still unable to work properly. Why? Because extremes are present. You experience this in India itself, in the northern part of India. What do you see? That means there are going to be hindrances with respect to climate also. Now these regions have moderate climate, so that is why on an average it is considered to be highly optimal for the human efficiency. Now these are found in the western coast of the continent in the middle latitudes between 40 to 60 degree latitude, found in British Isles, western coast of Norway, parts of New Zealand and certain areas of Pacific Northwest. So that is why these regions are again considered very suitable to live. You can see here, you can see these regions of United States, Canada. You can see the regions again in South America. You can see the regions of again the Scandinavian countries, the Ireland and United Kingdom region. You can see the parts of Europe and Tasmania along with this New Zealand region. So these are considered as British type of climate, again very suitable for humans to live. Let us see what is special in them. Mild temperature throughout the year. So temperature is mild throughout the year. Summer are cool to warm with mean annual temperature from 5 to 15 degrees Celsius. So it is very moderate, cool for everybody to stay. Warming effect of the northern Atlantic drift makes the winters relatively mild. Now what happens is, this region, even during the time of the winters, see, you know that Gulf Stream moves and extended in the form of North Atlantic drift. Now those are warm currents which tend to make these coastal region even during the winters very favorable to stay. That is why the coast in these regions are not frozen even during the winter months. Right? You have seen the isotherm maps. I've shown you during the winter months the isotherms move northward. Why? Because of the ocean currents. This question was asked in the UPSC paper itself. Then I think in 2025 also. So please remember what I'm teaching right now. If you have a conceptual understanding, you will be able to do those questions also very well. Clear? Okay. Now comes rainfall 50 centimeters to 200 centimeters of rainfall annually, consistent, even and relatively high rainfall throughout the year, no distant dry seasons. There is no distant dry season. There is again rainfall throughout the year that is happening. Westerlies bring heavy rainfall. Again, westerlies begin heavy rainfall. That is why in the western coast are also experiencing a lot of rainfall. Next, vegetation, deciduous forest, and the deciduous forests were present, but they have adapted to this particular climate. So the type of vegetation that is found includes oak, elm, ash, birch, beech, and poplar. Willows are also found. You have very well understood that you would have heard Sachin Tendulkar using English willow. Now the willows are over here found in the wetter regions, which are very useful, very good for making the bats, cricket bats. Life and economy, agriculture, grains, fruits, vegetables, dairy farming, mixed farming, and market gardening very well over here, grown to a great extent, very well developed. Along with it, you realize these are regions of industrial belts also. Britain, France, Germany, hub of industrial hubs, along with Denmark, Netherlands, and New Zealand also. You see regions of dairy development also over here, market gardening and mixed farming also grown. So these are also very developed regions. So that is why it is told to be as one of the most optimal for the human efficiency. Clear? This can be asked in your papers also. Okay, let's move ahead. The cool temperate eastern margin, Laurentian type, it is denoted by CFA. Many people can ask you, or UPSC can ask you in the Laurentian type also. It has asked in previously also. Because you at that time would have not heard the word also what is Laurentian type of climate, so it is very difficult for you to attempt also. So that is why I have covered everything very clearly over here. Geographical distribution, these are basically found in two regions. One is a North American region as the Asiatic region. North American region in the eastern Canada and northeast USA, Newfoundland. In the Asiatic region, it is found around eastern Siberia, North China, Manchuria, Korea, and northern Japan. Let us see the map. This is the region in North American region, and this is the region in the Asia region, which is found, the Laurentian type of climate is found majorly. Now, please understand temperature. It is cold and dry winters and warm and wet summers. Winter temperature might even go below the freezing point, and summers are as tropical region climate that you experience. So the winters are very harsh here. So the temperature is from minus 10 to 20 degrees Celsius. So that means summers are good. Temperature is around 20 degrees Celsius, 25 degrees Celsius, it is good. But the winters, you realize it is very harsh. You would have realized by now also, right now New York is again undergoing extreme waves of cold, frozen. So those are extremities that you find, right? Rainfall, 75 to 150 centimeters of rainfall distribution throughout the year with a maximum during the summer. See, unlike the Asiatic region, see, Asiatic Laurentian type as American Laurentian type are two different. Similar characteristics, but little bit differences also there. What is the difference? The North American region has uniformity in precipitation with the late summer maxima or the summer maxima. That means in North American region, there is a tendency that during the summer months, larger amount of rainfall is going to take place. Unlike in the Asiatic region, it is very disruptive, or it is not very systematized whether the rainfall will take place this, when, or at particular period. So it is not very well, you said, say uniform, that it might not be well distributed, it not be happening at the exact time. Over here, the North American Laurentian type is relatively more predictable. Vegetation, coniferous forest north of 50-degree latitudes, like dominated by pine, spruce, firs, and larch. Deciduous forest south of the 50-degree latitude, oak, beech, maple, and birch. Now, extensive logging. Both temperate hardwood and softwood have been extensively harvested for this region, again for lumbering activities. Life, again, lumbering of birch, pine, and larch. Fishing. The regions of the Grand Bank of Newfoundland are the regions where mixing of the cold and the warm currents take place, which create the best of the atmosphere for the fishing ground. So these are regions where fish economy is also very predominant, right? Okay, so these are the regions which you have seen. Next comes cool temperate continental, Siberian, boreal, or Taiga type, DWC. So you can be asked question of Taiga, boreal, Siberian, or cool temperate, same. It occurs only in the northern hemisphere where the high latitude continent have wide east or west spread between 50 to 70 degree north. See here. These are the regions. The upper regions, if you go, you will see the tundra type of climate or the polar. Below that is the Taiga type. This is the region. Again, colder region only. But you see this is the region. Below the extreme cold, you have this which is known as the Taiga type. Clear? Temperature brief warm summer with temperature reaching 20 to 25, but winters are see the summers are very brief with temperature close to 20, 25, 22 degrees Celsius or even 25. Winters are very long and very extreme. Temperature might go to minus 40 degrees Celsius also. Rainfall 38 to 63 centimeters. Boreal forest grasslands adapted to harsh conditions. Conifers are again the most common type of vegetation that you find here. Life and economy, again, you know that lumbering activities, agriculture in the limited time, grains, potatoes, and some vegetation are found here. Tapping. Tapping means that you catch an animal, kill it, and obviously remove its fur and sell it. So tapping is for you are basically catching animals and using them to get their fur, which can be sold in the market as a very at a very high rate also. Why? Because this is in great demand in international markets. That is known as tapping. Now comes the tundra, that is Arctic. Now this is the last categorization, the extreme cold. It is found in the polar regions near the North Pole Arctic and the South Pole Antarctic. It is ET. Now see here. It is in the extreme north coldest region and in the Antarctica region also. Extreme cold, complete frozen. Extremely cold climate. Winters are always below minus 37 degrees Celsius only. It might go to even severe conditions, minus 50 also. Summers are close to 10 because of the direct, again you might be receiving sun rays, and during that time the insolation might raise the temperature also. Now you please realize that this is just an estimate, this is just an approximation. Even in the summer, the temperature might be even close to zero also in extreme cases. It is very common. That is why I've said approximately. Rainfall very low, mostly in the form of snow. Vegetation limited to hardy grown plants, and majorly these are mosses and lichens are found there because the conditions are such that it is not feasible for very large vegetation to be possible. Life and economy, you said semi-nomadic activities are taking place. Tribes including Eskimos, Lapps and Semers are present here, right? So these are the reasons. Indian classification. Now we have done the world classification. Indian classification we've already done in the Indian physical geography. In the previous series, you can see the one-shot video also. But let us see, because this is one of the map here. This green region is AMW, which is monsoon type with short dry season. Clear? Receiving the extreme form of rainfall. Then you come to this region AS, monsoon with dry season in summer. You know that because it comes under the influence of northeast monsoon, and that is why it receives winter rain during the winter times. Otherwise, during the time of the summers, it is parallel to the southwest monsoon. It does not receive much rainfall over here. So this is AS. Next comes this region in pink. This is BSHW, that is steppe type of climate. Again over here also. BWHW is hot desert, that is a Thar desert. This region in brown is AW, tropical savanna type of climate. You've already done that. This blue region is CWG, that is monsoon type with dry winters. This region is E, that is polar type of a climate. And this is red, DFC, cold humid winters with short summer. So this is basically the representation of the Köppen with respect to India. Now you know the world also, now you know India also in this particular classification which we have done. So my request would be to you that please follow this lecture very categorically, religiously and properly. If you do this, you will not face any problem in the question that are asked from this chapter. Every single preliminary examination, at least 2 questions are going to be there from this, directly or indirectly. Because they might ask you indirectly without naming the climate also. So 2 or 3 in cases I have seen in previous years, even up to 4 to 5 questions have been asked from this. So please remember them, do it well, because they can link the concept with respect to economic geography also. Then also the questions can be asked. So you've done the climate, you can easily solve them. And in PCS papers and other UPSC papers also, this topic is one of their favorite topics. So please do that well. If you have any queries, let me know in the comment section. When we're dealing with the oceanography, see, we are not studying that, oh, this is Pacific Ocean, this is Atlantic Ocean. We already know that. We've already done that. What we are going to deal is what it lies beneath that. Beneath, when we just go underground, under the water, what is it that is basically present there? Are there some kind of mountains present there? Are there some kind of canyons present there? What is present there is again a very important point of discussion for a mere reason. that this is something that is not directly visible to us. Now, for example, if you're on the top of the land, let us say you are in Africa, you're in India, you're in Australia, the things, the vegetation, the animals that are present are easily visible to the naked eye. But something that is present deep inside is something that is beyond the reach of human beings also. That is why it raises a curiosity also. So what lies in the ocean floor? Or what type of life is present in the ocean floor? What form of landforms are present in the ocean floor? So what type of structures? Are there mountains even taller than Mount Everest present? Yes, there are. That is why, please remember, that study of oceanography or the oceans is also very critical for your geography as well as the civil services preparation. Now see, over here, a diagram, a map which we have already used multiple times that I have drawn by hand also. This is again, the parts in blue are referred to the oceans and the green bit basically referring to the continents. Now see, certain observations which I'm going to tell you, we have done this part also earlier just to remind you these parts so that when we begin with the oceanography, you have certain things in mind. Water covers 70.8% of the surface while land only 29.2%. More than 75% land is in the northern hemisphere. Pacific Ocean occupies close to 1/3 of the surface area of the Earth. North Pole is surrounded by water and the southern pole by land. Why? Because the northern pole lies in the Arctic Sea. It is basically a sea that is frozen. While Antarctica is where you know that South Pole is located in Antarctica, and Antarctica is a continent, and that is why there is a land mass present there. Next, continents roughly are triangular in shape except Antarctica and Australia. Now, this has also got to do with the plate tectonic movements and the movement of the continents, movement of the plates that have taken place, which have resulted in their shape being roughly triangular. Not all, as you see, Australia and Antarctica are not triangular in shape. But if you see other continents like North America, South America, the regions like, for example, Africa, they appear to be triangular in shape. So this is what is being said. A rough estimate, not exactly for every continent, but yes, you can be asked this statement in your preliminary examinations also. So these are rough guidelines which you already know about the oceans and the land. Now, when we begin with the ocean topography, now let us come to the topic that we're dealing with. This is ocean topography. When I talk about topography, a lot of things come into our mind, right? When I was talking about the land surface topography, in the topic of geomorphology, which we had done earlier, you would have seen that, sir, you had discussed about what type of landscape are present on the surface, what type of mountains are present, what type of plains are present, what other volcanoes present. So we have done all these things when we were studying the topic of geomorphology. Similarly, in the oceans also, you realize that ocean topography refers to the shape of the ocean floor and the subtle hills and the valleys on the sea surface. Now, what type of landforms or shapes are present in the surface are again an important consideration where we are studying in ocean topography. I've used the word bathymetry here. Why bathymetry? Please understand. What is bathymetry first of all? Bathymetry is a measurement of the ocean depth, charting the shapes of topography of the ocean floor. Now, bathymetry is a means through which we basically are trying to understand what is the depth of the ocean. What type of shapes means what type of landforms are present in the ocean floor. Are they tall? Are there deep trenches associated with them? Are there small hills? What is associated? What is present inside? That is what is being done by bathymetry. So bathymetry are ways in which the ocean topography is basically charted out or seen what type of topography is present. Now, the question arises, sir, how do we do it? Now, please remember, this methodology has evolved over the time and it is still evolving. It will depend upon the level of technology that we achieve. As the technology increases, we're going to have better methodologies in order to calculate and measure the ocean floor also. Now, earlier what used to happen, how we basically do it, see, measurement of the ocean depth and the shape. The common techniques. Now, first is, let us see, first is depth sounding. Now, depth sounding is one of the oldest methods that were used. Now it is not very accurate also, but what it involves is, let us assume you are moving, let us say there's a ship that is moving. They will extend a weight using a thread, let us say thread or a rope, using a thread. Now let us assume this, let's see, this is, let us say this is a weight, right? Over here is a weight, and this is being extended down. Now, when it touches the floor, we'll get to know that, okay, this is when touched. Then you start moving and then possibly you calculate using that how much time it is taking to touch the floor.
Let us say it has taken this much time. Now you know the density of water, you know the density of the substance. It is going to take some time to reach the floor. By calculating that, you get to know that this is the possible depth. Okay, then after some time you will again move ahead and then you will drop it here. Then you'll get to know, okay, this is the depth. So possibly if this is the type of landscape that is present, let us say there's a depth and there's a hill. So if a ship is over here, it has dropped this, it has gone down. It's just taken some more time. Over here, it will take less time. So you know that there is some sort of hill that is present here. Using these repeatedly dropping a rope with a weight, and you are calculating the time it is taking to reach the floor, using that it is basically being calculated. This is known as depth sounding. Throwing a weighted rope from a ship and recording the time. This is a highly inaccurate method because you can get to know that this particular point the time is more or less, but you cannot chart out a proper topography that is present deep within the earth, deep within the ocean floor. Then came the echo sounders. Now, echo sounders basically use the sonar techniques, right? Now, what happens over here is sound waves are sent from the ship and detected by the receiver. Let us take it again. See, let us understand this again. Supposingly, there's a ship here. It sends sound waves. Now, this is a surface. This is an ocean floor. The sound waves go there and come back. Right? We know the distance because the time it is required, and we know the speed of sound also. So based on that, we get to know what type of ocean topography is present there. Now sonar is again a very effective methodology and a much more improved form than over the depth sounding methodologies. Now, in spite of this, you realize it is very difficult to map the ocean floor properly using sonar also, because it is a very time consuming method. It might not cover every aspect. So that is why we have even better technologies. Satellite altimetry. Now the satellite altimetry basically uses radars and laser altimeter, which basically use the pulse electromagnetic radiations in order to know what type of topography is lying. Now these are again advanced technologies through which you get to know the exact possible details that are present inside the ocean floor or in the ocean, what type of landscapes are present. That is why these techniques, again, this can be asked in your examination also, in your mains as well as your prelims examination. So these are the important techniques which are used as means of bathymetric techniques. Because see, seafloor spreading and all we have done. We have done the aspect when we are doing plate tectonics. So these are now advanced concepts that you are doing in the topic of oceanography. Let's move ahead. Having studied that what type of methods are used, we will now get to know that based on these measurements, methods and techniques that we have found what type of landforms are present inside the oceans, there are various categorizations in which we have divided. Some of them are the major oceanic landforms and relief features, some the minor. So let us say the major ones first. This is a diagram that I have made using hand. This is a continental crust and this is an oceanic crust, just for a representation purpose. Now, there are a lot of depositions also that take place here. Now, please remember this part, first part, we will be studying each and everything over here. Don't need to worry about that. This part is known as the continental shelf. Now, this continental shelf basically lies beneath the water only, but it is very shallow. It will vary from place to place, but it is generally shallow, or most shallow part with respect to the complete ocean, because as you move ahead, the depth will increase. Then you have this slope that is present after the continental shelf. This is known as a continental break. This part is known as continental break. We'll see that. This is known as a continental slope, where a rapid decrease in the a very steep slope is present. So rapid decrease in the depth is very often seen here. This is continental slope. So the slope is the gradient is really very high. Then you have again this part which is known as a continental rise. The slope is not very steep here. After that lies a very uniform plain which is known as an abyssal plain or deep ocean plain. And also one more ingredient which is not present here, which you'll see the diagram, are the trenches. The trenches that are present, right? So along with these, continental shelf, continental slope, continental rise, abyssal plain, and the last being the trenches, form the major oceanic relief features. You should keep in mind, in the examination, you can be asked, which among the following are the major oceanic relief features? So you should please remember that the NCERT mentions about these and the trenches. So those are the ones which lie under this category. Let us study each one of them now. You know this is the continental shelf, right? This part. Now let us see what is the continental shelf. It extends, it is the extended margin. It is the extended margin of each continent occupied by relatively shallow seas and gulf. Now you know that very well. These are again the extended margin. This is the continental crust, extended margins of the continent. Now these again are underwater. Now it might be a little bit shallow in the form of, let us say, shallow seas might be present, some gulf might be present. It is a shallowest part of the ocean, showing an average gradient of 1 degree or even less. So as you know that as you move ahead into the deep ocean, you will realize that the gradient obviously will vary, but the depth will definitely increase. Because over here, you know it is first of all shallow, the gradient is not very steep. Why? See, till here the gradient is less. After that, when you move ahead, the gradient will rise because the slope is steep here. The slope is not steep here. That is why if you see the gradient is of 1 degree or even less, then you have this typically ends at a very steep slope called the continental shelf break. Now see here, this particular point where the continental shelf ends and the continental slope begins is known as the shelf break. So we can put it over here also, shelf break, right? This particular point. And then the average width is about 80 kilometers. Now it varies place to place. So it is almost absent or very narrow along the margins of the coast of Chile and the coast of Sumatra. So over here you realize that it is almost absent, it is not present. While in the other regions you will realize that in Siberia or Arctic Ocean regions, it is up to 1500 kilometers. So it can be very huge. So it will vary from place to place. Depth also varies. Now very often you will say that, sir, you said these are the shallowest parts. Does it mean that it is very shallow? Now again it will vary. See, over here the depth can be few meters to even in the distance of 600 meters also. From 30 meters to 600 meters. Now this is again 600 meters itself is huge, but again it is still the shallowest part. As you move ahead into the deep seas, into the deep seas, you will see the depth will definitely keep on increasing. So the average depth of this particular part also varies, right? Now let's come to the next part, that is continental slope. After continental shelf, there is a break. That break basically is again pointing to the rapid or a very sharp gradient, which is represented by continental slope. Earlier it was shelf. It connects the continental shelf and the ocean basins. It begins with the bottom of the continental shelf and sharply drops, and there is a steep slope. So there is a very steep slope that is being marked in this, very steep. Now the gradient or the slope of the slope varies from 2 degree to 5 degrees. Now 2 degree to 5 degrees, again very steep with respect to this ocean topography. We have already seen that the continental shelf are 1 degree or even less than 1 degree. But with respect to the continental slope over here, you guys see that the gradient is 2 degrees to even 5 degrees, in some cases even more. So the gradient that is really high, that means the slope is very steep. The depth of the slope region varies between 200 meters to 3000 meters. Again, it varies place to place. It can vary from 200 meters to even 3000 meters. The slope boundary indicates the end of the continent. Now please see. Sometimes it is written that continental slope marks the end of the continent. Please understand why. Now many will say, sir, you've already mentioned continental rise here. So how can this be marked as a continental end? Or over here you have written that it connects the continental shelf and the ocean basins. Why have you not written that it connects the continental shelf and the continental rise? These two issues might have come in your mind. You would have observed that. The reason behind it is, please remember, this continental rise that is present here is not present everywhere. It depends upon the supply of the sediments that is brought by a lot of rivers and other remains. So sometimes what happens is, if the continental rise is not very clearly visible, it is considered a part of the continental slope only. So in NCERT, if it writes that the continental slope connects the continental shelf with the plain, this plane, it is not wrong. If they had written even it connects the continental shelf with the continental rise, then also it is correct. So both the statements are correct. There is nothing wrong in that. When I have written here, it marks indicates the end of the continent. Yes, because various books consider continental rise as a part of continental slope. So that is why these statements are written. So it is not wrong. In either case, it is correct. Clear? Okay. Canyons and trenches are observed in these regions. We will see what submarine canyons are, what trenches are. These are also observed in this particular region. Okay. Continental rise. Now you see, post the continental slope, you have this continental rise present. It does not have a steep slope, right? It is a type of seafloor feature that consists of gentle slope of sediments from deep oceans to the continental floors. Now, please understand that the sediments are basically carried by the rivers and the streams, which are basically deposited then in the oceans. And more the supply of the sediments are, then there will be possible presence of the continental rise also. If it is not present, there is a lesser chances and possibly continental slope or major extension of that is considered, or it is considered a part of the continental slope in that case, if the sediment supply is relatively less. It merges with the abyssal plains, common in regions where there is sediment supply is large. Now, please understand that is why, if let us say a river is coming from here and a lot of supply is being there from the sediments, possibly you can see a continental rise here. If it is less, possibly you can just see this continental slope extending. There will be no specific features like continental rise in that case. It is possible. That is why sometimes continental slope is shown in the diagram, but continental rise is not shown. It is because it might not be present everywhere, right? So this is again continental rise, but you have to mention in your examinations, right, that continental rise is present. Deep sea plains. Now, if you see, move ahead, then there is this flat plain, right, above the continental crust. Now see, this plain basically refers to the deep sea plain. Now, this plain is why, because see, again, this is referring to the oceanic crust, the oceanic crust. On top of the oceanic crust, you have a lot of depositions might have taken place. Now, see, large number of plants are decomposing, large number of animals with respect to fishes and all are dying. A lot of calcareous remains, cilious remains, other biogenic and non-biogenic substances are basically falling on at the bottom level, and that leads to a lot of deposition be taking place, right? As you go in the deeper level, you will see more of silica, siliceous remains more, less of calcareous. That is also true. We'll understand that when we are doing the ocean deposits. Now see, abyssal plain are the underwater plains of the deep ocean floor. The depth might be from 3,000 to 6,000 meters or even more. They are flat areas of the ocean floor with a gradient well below 0.1 degree. The important thing is the gradient is well below 0.1 degrees. Why? Because these are very flat plains. Obviously, there will be some relief features, but these are plains these are very flat in nature. They are formed by the spreading of the ocean floor and melting of the oceanic crust. Now, see, you know that very well that we have already done in the plate tectonics chapter that the oceanic crust is basically an outcome of the spreading of the ocean floor. As this ocean floor spreads, you know that fresh magma comes out in the form of lava and it is deposited, and you have the mid-oceanic ridge in between, and this keeps on moving, because if this is a constructive plate boundary, over here this side is going to be destructive plate boundary. That means over here the crust is being destroyed. Yes. So the oceanic crust is relatively newer in nature. It is young in nature. We've already done that. Similarly, there will be a lot of depositions taking place also in the form of some sediments, in form of certain animal remains with respect to siliceous remains, a lot of stuff. So that basically forms the deep sea plain. Now, they are flattened and smoothed regions and covered by marine deposits. As I told you, marine deposits basically cover it. That basically forms the integral part of the deep sea plains or the abyssal plains. Now, this is again the representation. Now, let us see the oceanic trenches. Over here, the diagram is showing you a trench, but it does not show you how it is formed, which I'll tell you now. Please see. Do you see here? You have seen this is the continent part. This is the continental shelf. This is continental slope. This is continental rise. The flatter part is known as the abyssal plain. You might have small hills like the abyssal hill. Then you have the sea mount. We'll also study this. You have some volcanic island here, and then you have these great depths over here. These are referred to as the ocean trenches. These are the deepest part of the ocean. Now the question arises, sir, you have shown this, but how are they formed? If you remember, when I was telling you about the seafloor spreading, I had shown you that trenches are very often found at the destructive plate boundaries, that is the converging plates. Let us see the diagram. Let us see the diagram. Now see here, this is the ridge, mid-oceanic ridge. This is, let us say, the plate that is moving. This is a plate under which it is subducting. Now see here, very well, very nicely see it. Supposingly, there are two plates, and you know that very well, the plate which is denser in nature is going to subduct, right? The plate which is denser in nature is going to move down. This is the, let us assume this is the oceanic crust. This is the continental crust. This oceanic crust is moving. It moves down like this. See this? Do you realize from this particular circle? Let us see this. Now see this in this manner. Do you realize from this particular point there is a decrease in height rapidly? If you're moving here, you see here it is rapid fall in height. This is what is a trench here. If you are moving in this region, if you see, oh, there is such a deep height, it can be various kilometers also. This is what is a trench. Why? Because the subduction in taking place here. See here, this plate is moving down here, so this particular part, the depth is more. So this part is known as trench. Now, it will depend upon the nature of the plate, it depends upon the nature of the region. You can realize the trenches can be very deep also, like the marine trench. It is very huge and very deep. So these are how trenches are formed. These are formed at where there is converging plate boundaries or destructive plate boundaries, because this plate boundary is being destroyed. So over here you will find the trenches. The ridges are found on those regions where there is divergence or constructive plate boundaries. We have already done this in the plate tectonics, so let's move ahead. Move back again. Trenches. So these are the deepest part. So these are the deepest part, right? But trenches are relatively steep-sided and narrow basins. So why these are? You see, these are very steep-sided and again narrow also. They're not huge. They are huge with perspectives to human being, but with respect to the plates and all, they are not that huge. Right? They are some 3 to 5 kilometers deeper than the surrounding ocean floor. They are formed due to the subduction of one tectonic plate beneath the another. You've already seen this. So one plate is subducting under the another continent, another plate. The one which is more denser in nature is going to subduct. Please remember, oceanic plates are more denser or much more denser than the continental plates. One fact. So that means, I know that we've already told you the plates which are more denser in nature are the ones which are going to subduct. First. Second, if there are two continental plates or two oceanic plates, you will say which one is going to subduct? Again, the one which is more denser is going to subduct. Clear? So that is something you should know. Now over here, when we see the oceanic plate and the continental plate which are basically converging, the continental plate is lighter, less denser. So the oceanic plate is going to subduct or move down. Clear? Okay. So they are large in number using the NCERT facts also. NCERT mentions that there are 32 in Pacific Ocean, there are 19 in the Atlantic Ocean, and there are 6 in the Indian Ocean. So these are again very often you can see in the PCS exams also, this is being repeatedly asked. These number can be asked, they can ask you in the UPSC paper also. Nobody can restrict them. So you should know because these are various important NCERT facts also. So please note it down. Okay, what we have done are the major oceanic relief features. Now these are the minor oceanic relief features. Let's see them. First, seamount. Can you see this seamount? Yes, there are a lot of phenomena, a lot of processes through which it can be formed. There is no one method or one technique or one, let us say, phenomena. But let's see. So these are like small mountains which do not have a flat top. These are basically volcanic origin. It is a mountain with a pointed summit. It can, see, there are two ways. Either it can be like this, it is not flat, or it can be pointed also. Both ways it can happen. But it is not plain or flat. So it is a mountain with a pointed summit rising from the seafloor and does not reach the surface. The important feature is that it does not reach the surface. It is underwater. They are of volcanic origin, possibly because of the volcanic eruptions. Hotspot activities also can lead to the formation. They are 3,000 to 4,000 meter tall, 4,500. These are again tall, but they do not reach the surface. Now, what are the possible methodologies through which it can be formed? We've already studied the hotspot activities and the mantle plume, so you know the phenomena behind it. So often they are from the volcanic activities associated with the hotspot. So because of the hotspot activities, some type of this volcanic origin structure might be formed, but it is not so tall enough to reach the surface. One. Also formed due to submergence, due to erosion, or due to sea level changes associated with a volcanic island. So it is one. Another phenomena can be that it was like this island, like a volcanic island was present, and a lot of erosion took place, and due to the erosion, the height decreased. One, that is possibility. Or there was submergence of the continental landmass. Due to the submergence, it has moved down. So these are also way through which this sea mount can be found. Clear? Okay, now this is one feature. Another is goyots. Goyots are completely same as seamount. The only difference is it has a flat top. It is a flat-topped seamount showing evidence of gradual subsidence through stages to become flat-topped submerged mountains. So, goyots simply mean that these are submerged, flat-topped seamounts rather than having a pointed edge or a crooked edge. They are simply flat. These flat mountains are known as the goyots. Next comes the submarine canyons. These are very interesting feature. Now see very well, this part is referring to as the continental shelf. This part is referring to as a continental slope, and this part is referred to as a continental rise. I've shown you through a different type of a diagram. Again, handmade. So please understand this very well. When you see the Grand Canyon where the Colorado River is flowing, do you realize huge structures that are formed? And you just imagine the scale of water erosion that has taken place through these thousands of years and the power of the river erosion. And you see such tall type of structures have been found because of the erosional activity that has taken place over these thousands and thousands of years. So over there you see those canyons have been found due to the erosion. Similarly, you realize that there are canyons like structures that are found underwater also. They are not found everywhere, but in large places. Now what happens is there are a lot of phenomena through which it can be formed. Some say that it is possibly because when the rivers are bringing the sediments, a lot of pressure might be exerted, so they might form, due to the density differences, they might form some canyons, that is said. Sometimes they say that it is formed by the tides that come. Sometimes it is from that continental ocean currents also play a very important role. So sometimes it is said that the turbidity currents might be responsible for the formation. So a lot of phenomena are there. Again, if you're doing geography optional, possibly you go to the theories, otherwise it is not required. So whatever I've said, these points are one of the reasons, various reasons responsible for the formation of the canyons. So what happens initially in the pre-canyon phase, let us say there is some form of structure, or let us say removal of the continental slope might be formed. Why? Because sometimes what happens, let us say some currents that have come, their deep water currents might be present. Let us say there is upwelling that is taking place. Please understand, there might be upwelling of water. Do you realize upwelling? Sometimes what happens is, if on the top of the surface, please see here, the top of the surface, if we'll see in the ocean current chapter, if the river, let us say, let's see this. Let us say this is again the region of continental shelf and slope. Due to the flowing of the rivers, it is possible that the ocean water is piled up here. Water is pulled in this side, it is piled up here. So what happens is water will move down. This is known as downwelling. Water sometimes, deep underwater ocean currents also might lead to just their movement, and they might lead to these type of structures being formed. That is also possible. And then they will rise up. So when you see or talk about the ocean currents which you see about Gulf Stream, North Atlantic Drift and all these, Agulhas current and all, these are surface level currents. You have deep water currents also. So those deep water currents might basically be one of the reasons for the formation of these canyons. Again, these are one of the theories. There might be these deep ocean currents, there might be turbidity currents, there might be even sometimes tides are also made to be responsible for that. It is also said that the sediments brought by the rivers due to the erosion activities might also be responsible for that. So there are multiple reasons behind it. So what we see over here is initially little bit of, let us say, scratching of the ocean continental slope takes place. This might further enlarge, two of them might be formed. Then further the depth increases and you see the size of the canyon also increases. Now this is a process that takes place in a very long period, not a very short period. Similarly, then after that, a hook-like structure might be formed, and later on you see a very huge canyon might be formed, which is extending to the continental shelf, continental slope, and continental rise. In the examination, you can be asked that the submarine canyons are found in which among the following features: continental shelf, continental rise, continental slope. All of them. All of them. But the question might be asked that among these three options, where there is a greatest possibility of the submarine canyon be found, it is at the continental slope. Why? Why? The reason is the steepness of the slope. If you ever see the diagram, here, let's see the diagram. If let us say a deep sea current is moving, it is very steep, so it is not very steep, it might not lead to massive erosional activity over here. But this is very steep, so what happens? It is more resistant to the movement of some, let us say, deep ocean current. That is also one of the reasons. That is why the possibility of the submarine canyon to be present more in the region or start in the region is the continental shelf, continental slope, rather than shelf or the rise. Obviously, when that size increases, you will realize that it will spread to the other regions also. So you have seen this, right? Okay, let's move ahead. They are like deep valleys comparable to Grand Canyons. They are found cutting down the continental shelf, slopes, and rise. Okay, let's move ahead. We have studied a lot on that. Now let's see an atoll, something very interesting. This is an atoll. You see these are the coral deposits and you have a lagoon. So let us see. Atoll is a ring-shaped coral reef that encloses a lagoon in the middle of an ocean basin. So it is what? A ring-like structure with there's a lagoon in between them where the depth is not very high, or let us say the depth is not much. So there's a lagoon which is being enclosed like this. Like there might be islands surrounding this, and there's a lagoon in between. Obviously, the ocean is on the side. Now, this is generally a ring-like structure if you see from the top. Now, this is an atoll. Now, how it is formed, let us see this. These are low islands found in the tropical oceans consisting of coral reef surrounding a central depression. This is another definition. Better definition is this one, which you can use. How it is formed. Before we study the formation, you should have a little bit idea about the coral reef. Right? Now, the coral reefs are underwater structures made of the calcium carbonate skeleton produced by tiny animals called corals. Now, these are the deposits that happen. That is why the coral reefs are found, because of the calcareous or the calcium carbonate depositions that are produced by the corals. Now, see, initially what happens, there is stage. This is stage 1. Stage, let us write it, stage 1. Stage 1, supposing there is an island. Now, this is the water level, right? This is the part which is above it is like an island. Now, surrounding, just close to it, you have certain reef formation that is taking place. Now, it might be completely joining this island, or there might be some depression or some small form of lagoon that is there, depends, right? So, this is known as a fringing reef. Grows directly from the shore, located very close to the land. So it is located very close, just close to them, the island. This is known as a fringing reef. The next stage that happens is, this is stage 2. In stage 2, what do you see? In stage 2, what do you see? This island has relatively moved down, or in a way there is submergence of land. Now this can happen through two methods. Either this stage can come if there is submergence of land, one, or there is rise in the water level. In both the cases, this can happen. You see this? Supposingly this was an island, if I say the water level rises to this level, so automatically you will have the increase in the ocean, because see, the coral reefs cannot be in deep sea water, right? Those are different types of corals. We're talking about these corals. So obviously there will be more deposition and rise, or there is fall in the, or submergence of the island, then also this can happen. So in both the cases, it can work. How will the stages proceed? Either there is rise in the sea level, or second can be where there is submergence of the land or the continent. In that case also the second stage or the future stages can come. So in this case, you realize that this is a coral reef which is again created. It has water enclosed in them, but the island is also visible. So extensive linear reefs complex that are parallel to the shore separated by a lagoon. So these are parallel, these reefs are parallel to the shore, but the island is also visible and there's a lagoon over here. So this is known as a barrier reef. Now third stage is stage 3. Now this is not a tool as such, this is a tool forming stage where you realize that again the third stage will come, either there is further submergence or the further increase in the water level. In that case, further the coral reef will further expand, right? So this again the stage will again have the lagoon, but the coral reefs has further increased in size. Last stage comes where either there is rapid rise in water level further or further submergence. In both the cases, you see this island which was earlier visible has gone down and this is covered by what? The reef. Now what has remaining is now, it is a ring-like structure will be there. If you see from the top, you will possibly see like this. Right? This is the top view and you will have the lagoon here. This is the form of lagoon here. So last will be again the ring-shaped coral reef that encloses a lagoon in the middle of an ocean. Example is Maldives. Now Maldives is a representation of a tool. Clear? So these are again handmade diagrams. If the question comes very repeatedly, very often these questions are asked, and when you use them, please remember that this is very, very useful for your preparation. You can make these diagrams by hand. Clear? Okay, let's move ahead. Mid-oceanic ridges. Now this is something we have already done in the geomorphology also. You know that very well. The mid-oceanic ridges is not simply that is mid-oceanic ridge is not confined to the Atlantic Ocean. It is present in various oceans also. It is basically formed at the regions where the divergence of the continental plates takes place. So as you have already seen that if there are two plates which are diverging, when the divergence takes place, again the magma basically is coming out. Magma is basically coming out. Magma comes out that leads to the formation of some ridge-like structure. That is very long because the plate is very huge where the divergence is taking place. So that ridge again is formed. Slowly, the mountain that was formed. Let us say this is a boundary where this ridge is formed. Slowly, you realize this will move apart. Why? Because the plates are moving, then new ridge will come here, new ridge will come here, new ridge will come here, while this will be moving apart. Similarly, let's see, supposing this ridge is formed here. Now you know, slowly this ridge over here also you can see small ridges. Why? Because earlier they were located here. Slowly they have moved this side. And further the erosion is taking place, right? So you see that this is a region where the convectional currents are basically moving. That is why you realize that the plate is subducting under the another plate because it is more dense, and the magma that is coming out in the form of lava is being deposited here, that is leading to a formation of a ridge-like structure which is known as a mid-oceanic ridge. So mid-oceanic ridge is a continuous mountain range spans across the entire ocean floor connecting different ocean basins. Why it is across so many continents, so many oceans? Because it is associated with the diverging plate boundaries. Now it is present in various oceans. So where it is present, you will see such structures being formed depending upon the scale, depending upon the level of movement that is taking place, and all that will basically be impacting the size of the mountain ridge. The most developed is obviously in the Atlantic Ocean. It is associated with divergent plate boundaries. You have already seen. What is divergent plate boundaries? This is what? Divergent. That means constructive. So this is what? Divergent plate boundaries. Divergent plate boundary. It is diverging. Over here you will have this mid-oceanic ridge. Clear? Okay. You know that very well. I'll not repeat it again. The evidence behind is we have done in the seafloor spreading that there is alternative bands of polarity that is present, right? This is a region where the ridge is being formed. You know that when the magma comes out, when the magma comes out, obviously when the magma is coming out, in that particular case, you know that it has a lot of magnetic substances, material in the form of iron, let us say. Now, when it comes out, the polarity of the Earth basically leads to the arrangement of the particles in the direction of the magnetism. What is the magnetic direction? Which is a north pole, which is a south pole, which is the magnetic north pole, which is a magnetic south pole. Based on that, the minerals are also arranged at the atomic level. So, we repeatedly see that because the magnetism of the Earth is caused by the convectional currents which is going on inside the mantle. Obviously, core is also involved in that, but majorly mantle. So, if there is the reversal in the direction of the convectional currents, it can lead to reversal in the polarity also. And this has happened repeatedly over centuries, multiple centuries. So when this deposition is taking place, we realize there is reversal in the polarity taking place on the either side of the oceanic bed, on the either side of the mid-oceanic ridge, and they are equally apart. Like this is apart, like this have the similar polarity, they have a similar polarity, this has a similar polarity. Why? Because possibly they both are moving apart. Why they have a similar age of rock? Because possibly they came out at a similar time. Possibly they were inclined at a magnetism which the polarity which the Earth had during that time. And this was basically measured based on the reversal of the polarity that took place within the Earth also. And it was calculated, yes, supposingly this has reached this position. Let us say it has reached from this position to this position in, let us say, a few thousands of years. And when it was calculated using a lot of techniques, it was found, yes, there's a possibility that in these thousands of years ago, there was a reversal in polarity also that took place. So this basically helped us that the sea is also expanding or moving from this constructive plate boundary. And yes, we know that the mid-oceanic ridges is present here. So this we've already done in the plate tectonics. So just a quick reminder, that is why we know these mid-oceanic ridge concept is very closely associated with the seafloor spreading concept, which we study. Now see, like the crustal material are spreading from mid-oceanic ridges and the floor is moving on either side is called the seafloor spreading. We've already done this. Okay, temperature of the ocean water. Now this is again a very, very important concept, temperature. Let's see them and study them. These are questions which are very often asked in your examinations also. So you should be very well aware of this. Let's see. First is what the factors influencing ocean temperature. First is latitude. Now if you see this, see, if the amount of temperature that is reaching, the amount of heat that is reaching the Earth will vary with respect to the latitude. The ones which are close to the equator receive the sunlight throughout the year. The ones which are in the high latitude receive relatively lesser insolation. Yes. Now see, latitude, the average surface water temperature. Surface, please remember, we are not talking about the deep ocean level. Surface water temperature of the ocean is 27 degrees Celsius. Now, as we move to the higher latitudes, we see a decrease in the temperature. Keeping other factors constant right now, the decrease is about 0.5 degrees Celsius per latitude as we move from 0 degree, that is equator, to the poles. So there is a decrease as you move from one latitude to another. An estimation, average estimation has been done that there is a decrease of 0.5 degrees Celsius. Now, this is how the latitude over here is also impacting it. Clear? Second comes the ocean currents. Now, if you see, ocean currents, again, we will be doing this chapter also. The warm ocean currents from the equatorial region carry warm water to the higher latitudes, whereas the cold currents basically bring cold water from the high latitudes to the lower latitudes. So, the warm currents and the cold currents are again responsible for changing the temperature also. For example, the Gulf Stream, which is flowing northward and then later on in the form of North Atlantic Drift, is basically responsible for increasing the temperature of the regions close to the Scandinavian countries, right? And those regions, you realize, are generally very close to the, again, in the higher latitudes should be frozen during the winter time, but they aren't. Why? Because the North Atlantic Drift increases the temperature of the oceanic region over there in the Northern Atlantic region, and it does not allow the region to freeze completely. So the ocean currents, again, warm currents
moving to a region, to any region, increase the temperature, increase the temperature. In simple words, while cold currents will decrease, vice versa for cold currents, vice versa for cold currents. I just now told you an example for the warm current. Let us take an example of the cold current. You know the Labrador current. The Labrador current, when it is moving along the Greenland region, then when it moves down, it comes close to the North New York region. Now, New York region is again, you realize, experiences this current, and it is so cold current. That is why during the winter season, very often the harbors are completely frozen. On the other hand, the Scandinavian countries which are at a higher latitude does not have the harbors frozen because of the North Atlantic drift, which we will see. These currents names which I am taking right now, this current name which I'm taking right now might be something very confusing that people will be saying, sir, what type of names you are taking? Let me give you just a hint of it before I actually do it. See here, the ones in blue are cold currents, the ones in red are in warm current. So the Gulf Stream moving here, it moves further in the form of North Atlantic drift. So this region does not have a frozen winter completely at the frozen coast. Why? Because these are warm currents. The Labrador current which is coming, which basically moves down, and it basically leads to this the New York region being completely frozen during the time of winters. So this is how it impacts. Even if you see the Peru current or the Humboldt current which is coming to the region of the South America, you realize you have the Patagonian desert over here, which is a cold desert. It is because of the Peruvian or the Humboldt current that is present here. Similarly, whatever regions you see over here, like the Benguela current is also responsible for the arid conditions in the African region. Please see, these currents are very critical in the temperature of the regions or the surrounding land masses also, right? So just that was a simple representation. We'll be doing it after some time. Next is the prevailing wind. Now prevailing wind, please remember, are again very, very critical. As you see the winds that are moving, right? Let's take an example. Winds are one of the major forces through which the ocean currents are created, right? Because if you see the permanent winds that are flowing in the form of westerlies, the easterlies and all, you see the ocean currents are also following the direction. So the prevailing winds are one of those winds which basically help in the movement of the water also. These winds basically again help in the spreading of the temperature of the region also. Directly also, indirectly also. So because when the winds are flowing, they basically there is friction existing between the water surface and the wind, and they try to drag the surface of the water, and that again leads to the distribution of the water also, a temperature distribution. So help in temperature distribution in the direction of the distribution in the direction of the wind. Land and mass. Let us see this. If you see the temperature of the northern hemispheric oceans is more than the southern oceans. Let us take the example of any ocean. Let us take the example of Northern Atlantic Ocean, and you take the example of the Southern Ocean. You will realize that the temperature, let us take the average temperature. Average temperature of the Northern Ocean, Northern Hemisphere oceans is more than the Southern Hemisphere oceans. Why? Because there is more landmass associated with the Northern Hemisphere. Now the land is also getting heated, it's going to give heat to the oceans also. So the temperature will increase. So that is why if you realize that in Northern Hemisphere, the temperature of the ocean is more as more land is there.
more land is there, right? Next, the axial tilt. What do you mean by axial tilt? It is the tilted axis of the earth. Now you know that very well, the region which is experiencing or getting more insolation is going to be more heated. Yes? The tilted axis of the earth basically leads to certain regions receiving more light, more insolation. So that means axial tilt basically leads to certain regions receiving more heat. So if they receive more heat, the temperature is going to be more. Which are, now see, during that time, when if the axial tilt is this way, this particular region will be experiencing more insolation rather than the southern hemisphere. Similarly, the axial tilt helps in the distribution of heat also, because sometimes the northern hemisphere is receiving more heat, sometimes the southern hemisphere. That is the reason. So it basically helps in varying amount of insolation, and thus more insolation, more is the heat, greater is the temperature. Upwelling and downwelling. Now please see, these two concepts are very important. Let me just show you this here. Let's see here. I've already explained you this. Let us still consider it. Let us assume that there is this surface. This is surface water, right? As you move down, these are like deep. This is the deep plane, right? Now, if I say that there is prevailing wind, just take an example of it. Prevailing wind or some wind that is going on. Now, if you see this, this is the original level. This is the original level. Now, the winds are original level before winds. Before wind. Now, when the winds are flowing, there is quite a possibility, let's see this, there is quite a possibility that the wind is dragging the surface water towards the direction in which it is moving, right? Just imagine, let's take this example. Let me bring you a paper. Supposing this is a paper, right? If the certain winds are flowing, possibly it might move this in this direction. Yes. Similarly is done with the case of the water also, at least the ones in the top layers. So what can happen is, slowly what will happen, the level over here might move down and the level over here might increase. I'm just exaggerating, it is not so, but yet to a certain extent, yes. Now see, because why? It is moving in this direction, so it will pile up. This is known as the piling effect, piling. So water over here, now this is the new level. It is not a permanent feature. It is because the wind is flowing, that is why it is happening, right? New level due to wind. Now this phenomena that has taken place, it is known as the water is piled here. What is it? Water is piled here. Water is piled here. Now water being piled, so what happens is, the amount of weight this particular column of water is experiencing is much more than this. Why? Because there is more piling effect here. So what happens is, this lead to water sinking. This might lead to water sinking. Why is it sinking? Because it has to balance the effect. Now, please remember one thing. When the water is flowing, do you realize when it is moving or piling up, what has happened? There might be this might be the what? The ocean currents. This might be the surface ocean currents. Ocean currents. That is why this is a movement like these are like the rivers in the ocean. This when certain water is moving here in the direction of the wind, you realize like these are ocean currents, like the rivers in the ocean, right? So that is what is piling. That is why this piling has taken place. Now, because this is creating a lot of weight, this will lead to water moving down. Yes. Now, what happens is because this is a temporary factor, this has to balance it. This movement of water down, this is known as, this is downwelling. Now what happens is, see, now what happens is, over here you realize that now water which has sinked, you will realize the water which is present here will try to rise because this has sinked. Now again, this will rise to balance it. So this water has to rise, right? Now this water will move to take its place. So you can see it in the form. This is moving to take its place. This is known as upwelling, where the cold water from the lower region is rising up to take the place which has been displaced by the ocean current or the winds which is moving. So this is what upwelling. Upwelling. The important dimension over here is, what do you understand? When there are surface currents that are moving, there is a reverse direction current which is flowing to balance that, and these are known as deep oceanic currents. These are known as deep oceanic currents, which are close to the bottom level or the almost the base level of the oceans, while these are the surface currents which are moving. This is the concept of downwelling. This is the concept of upwelling in order to balance the whole phenomena. So we have already done here. Please turn over, right? Clear? Upwelling and downwelling. Next comes the special variations. Now please understand, these are special variations, especially with respect to the nature. Let us say landlocked place, landlocked sea. Example, Mediterranean Sea. Mediterranean Sea has a higher temperature. Higher temperature. Why? Because it is landlocked. Being landlocked, it has greater amount of energy that is being given to the Mediterranean Sea. The temperature will rise. While on the similar latitude you see in the Atlantic Ocean, the temperature is relatively much colder. Why? It is landlocked. Then comes submarine barriers. It is quite possible. Let us say, if you go to the deep oceans, you will realize that there are certain regions where, let us see, like this is the coastal region. Let us say a region where a barrier might be there, and like this. Like this is the open ocean, let us say. This is the barrier. What happens is, because the temperature, let us say this is all water, underwater. Because the barrier is present, there is a possibility that the temperature at this level might be, let us say, 5 degrees Celsius. But over, not 5, let us say 15 degrees Celsius. Over here, it might be 2 degrees Celsius. Why? Because it is basically being surrounded by this barrier. So what happens is that temperature might not be exchanged too much with the outward or the open sea. So the heat that is gained is little bit preserved also, and further it is gaining heat from both the sides. So the temperature might be higher of this particular region. So this is again submarine barriers that influence the temperature of certain parts of the oceans. So these are again the various factors that are present. Hopefully it is understandable to you. Now let's come to this particular topic, very important. Vertical temperature distribution.
Vertical means as you go deep inside the ocean, how is the temperature basically varying? Let us understand this very, very clearly. Let's see. When I talk about the temperature variation, I'll be explaining this in detail in the future slides, so don't need to worry about this. I'm just showing you here what this diagram is representing. This is basically representing the temperature changes. How? The temperature is 0 degree till here it is increasing till 24 degrees. Till 24 degrees. This is the depth which is increasing, right? From 0 meters till the depth of 4,500 meters I've shown. Now I've shown you 3 layers over here. Important ones being, see, the important thing you need to remember is this is layer 1. This is layer 2. And this is layer 3. This is a surface layer. This is a layer which is known as thermocline, where the temperature decreases very rapidly, and this is the deep sea layer, bottom layer. This line is basically representing the fall in temperature as you move down. At the surface layer, let us say there is, 22 degrees Celsius over here. Further, the change is not very high, but as you enter this layer, there is rapid fall in the temperature. Then further, if you move, there is no rapid change. So in the deeper layer, the water density is, as it is very high, the temperature is already decreased. So you realize that the temperature is not varying to a great extent, but this is the layer where the temperature is going to change. This is what we're going to study now. Now see, what we are studying here is a first layer. This is the first layer. First layer of the upper layer. Now please see, why we have to need to study this very carefully. There's questions are repeatedly asked from this particular chapter. You'll see, understand why. This particular part which I've written, many times questions are asked. Let's see. I have made this diagram. The surface layer has a temperature of 22 or approximately that. The average surface temperature itself is 27 degrees Celsius, we know that. But I've taken just a representation here. This, let us say, represents 22 degrees Celsius at the surface. Now, temperature representing 22 degrees Celsius at the surface basically means that this region is not referring to the polar region. Why? Because of the polar region also you have a temperature which is very cold here. So in the polar regions, you will not see a very appreciable change in the temperature as you move down, because as it is, the temperature over there is cold. That is why in the tropical regions, this layer is present throughout the year. While in the mid latitudes, this layer develops only during the summer season, because in the winter season, the temperature is already low. So what will happen? You will not see any appreciable change. That is why this layer will only form in the mid latitudes or the high latitudes during the summer months. But equatorial region, as it is, there is high temperature throughout the year, so you will see the temperature being high throughout the year. So there is no problem in that. So that is why you see this diagram which I'm representing is present in the equatorial region or the tropical region throughout the year, but in the mid latitude only during the summer months, because in the winter months you will not see this rapid fall, because already the temperature of the surface layer is also going to be high. Clear? First of all, let's come here. The top layer represents the warm oceanic water and is about 500 meters thick, with the temperature ranging between 20 degrees Celsius and 25 degrees Celsius. So 20 to 25 degrees Celsius is the temperature that is ranging, right? Now, this is, I've already explained you that this layer, upper layer, is formed in the equatorial region throughout the year, but in the mid latitudes during the summer time. Second layer, this is the upper layer. Second layer is the thermocline. Now, this is a second layer called the thermocline layer that lies below the top layer or the surface layer. This is known as a transitional layer. Why it is known as a transitional layer? Because this is a region where the temperature rapidly falls as you move down. It is basically present from 500 meters depth to 1000 meter depth, and characterized by the rapid fall in temperature. So you see over here, let us say if it is close to 20 degrees, over here by the time you come it is close to 5 degrees or even more. Rapid fall. That is why this thermocline layer is very interesting layer, that is rapid temperature fall. Last is a lower layer. Now this is a third layer or the lower layers, and it is very cold over here. Represents the dense ocean water mass. So over here you realize that already the water is cold, dense. So there is no appreciable fall in the temperature. About 90% of the total volume of the water is found in this particular region. So you should be aware of this. This is the third or the lower layer where you have 90% of the volume of water. Temperature variation with depth in this zone is relatively very less or negligible, right? Okay, let's move ahead.
Now comes to, we have done with the horizontal distribution, let us see the vertical distribution of water. If you see the horizontal distribution, what does horizontal mean? That horizontal basically means that you are basically, if I see a map, what are the changes that are taking place? What are the variations that are present there? This is what is to be understood over here. Clear? So please write the heading horizontal distribution of horizontal distribution. Please write it down. So students, we have basically covered the vertical distribution of temperature, right? Now let us move on to the horizontal distribution. Let's see. When we talk about a horizontal distribution, what does it mean? Vertical distribution basically refers as you move deep inside the ocean or a sea. What are the variations in the temperature which we had seen through the upper layer, the thermocline, and the deep layer, the third layer. When we talk about the horizontal distribution, we see that when I see the map for that matter, let us assume these. What is the basically how the temperature is varying in the oceans, right? Let's see. The average surface temperature of the ocean is about 27 degrees Celsius. Now, this is something very important because these are small things which are very often asked in the examination also, which we tend to neglect. Now, we know that very well, as we have seen in the factors also, as we move in the latitudes, one after the another, in the higher latitudes, the temperature is relatively very low. And the decrease has already been seen. Please remember, do not get confused with the concept of normal lapse rate and all, which we have done with respect to the atmosphere. This is with respect to the oceans, which we are doing. Clear? So, average temperature gradually decreases from the equator towards the poles, and it is approximately, see, it is on an average we have taken approximately 0.5 degrees Celsius per latitude. Now, if you are 20 degree latitude, the temperature average, please remember, it will vary according to the landforms and a lot of other circumstances and situations. But on an average, 20 degree latitude has 22 degrees Celsius. 40 degree latitude has 14 degree. 90 degree poles less than 0 degrees Celsius or close to 0 degrees Celsius. It is obviously less than that. So, we see that the temperature is decreasing of the oceans which you move in the high latitudes, right? This is again important. Next to the northern hemisphere oceans record higher temperature. Why? I've already told you that the northern hemisphere has more land mass or more continent present. So the continents again heat up quickly. They tend to give their heat and energy to the oceans also. So they contribute or help in the heating of the oceans also. So that is why you realize that the oceans in the northern hemisphere are relatively more warmer than the southern hemisphere. Next. Decrease in temperature with latitude in the Atlantic Ocean is less. Now these are certain statements which can be asked in your prelims as well as mains. Decrease in the temperature within the latitude in the Atlantic Ocean is less. See, over here, the temperature which is, the rate at which the temperature is decreasing is very less. You see 0 degrees Celsius over here, though conventionally if you see, these are very cold regions, but the temperature should be much below 0. The reason behind it is the current, ocean current. We will do the ocean currents in this lecture, but let me give you a brief idea. See, over here, there's a current known as the Gulf Stream. Gulf Stream. This is further continued in the form of North Atlantic Drift, which we'll see later on, don't worry. This is taking the warm water towards the northern parts of the Atlantic Ocean. And that is why you realize that the warm water is spread or spilled over here. That is why you realize that the decrease in temperature is not very rapid because the warm water from the lower latitudes have gone to the upper latitudes. Secondly, this also is very advantageous. Why? Because these regions, which you see the Scandinavian countries and all, these regions even during the winter months have very often ice-free coastal regions. Why? Because the warm current that has been brought from the lower latitudes by the Gulf Stream as well as the North Atlantic Drift helps them to keep the coastal regions ice-free or non-frozen. This is very useful. That is why over here you see the statement is mentioned, decrease in temperature with latitude in Atlantic Ocean is less, right? Next is enclosed seas like Mediterranean Sea show higher temperature than the Atlantic Ocean. There's a very simple reason behind it. This is Mediterranean Sea, this is the region. You will see the Mediterranean Sea will show a very higher temperature in comparison to the Atlantic Ocean, which is just neighboring it. Why? Because Mediterranean Sea is surrounded by land. So the amount of heat that is garnered or gained by the land is also given to the these Mediterranean Sea, and that is why it raises the temperature also. Clear? Okay. So when we see this map, you can roughly get an idea that this is the temperature variation which you have seen, this is because of this is because of the ocean currents. Over here also, if you come, this because 25 degree isotherm over here is basically going down because of the south equatorial current. Similarly, you realize that Oyoshio current over here, Kuroshio current over here, all these currents are also influencing the temperature that is present. We will be seeing the currents, then we will be better able to analyze it also. Meanwhile, you can just keep in mind few things, that is the Mediterranean Sea, the Atlantic Ocean thing. This is something that is very often asked. Okay. Now, heat balance of the ocean. We have already done the concept of heat balance of the atmosphere. Now, that is something that is present in the NCERT. But this part is not present in the NCERT. And this is something that can be asked. So heat balance of the ocean, like the atmosphere, similarly there's a concept of heat balance of the ocean also. So let us see few concepts. You do not have to go into R&D, you can just listen to it. This is important. Addition of heat to ocean and heat lost. How the heat can be added to ocean, how it can be lost. Let us say heat can be gained through insolation, HI. Heat can be gained through, let us say, floor or continent from volcanism, through sensible heat, through kinetic energy due to the compression of the seawater, salt water, which has salt. So these are the ways through which heat can be added to the ocean, and there are mechanisms through which it can be lost, through evaporation, through convection, and through radiation. Now, having known these processes or factors through which heat can be added and through which it can be removed, let us see this. Heat added is equal to heat lost. If it is proved, that means it will help us to understand that heat what is gained is being lost. So there's a balance maintained. So through insolation 90 units, through ocean floor 9, kinetic energy 0.9, sensibility 0.01. So there's 100 units that is gained. What is lost? See, through radiation 41 units, through evaporation 54 units, through convection 5 units. So total 100 units again lost. So there is a balance that is maintained with respect to what is gained and what is lost. Clear, everybody? So understand that well. Now let's move ahead. Let's come to the topic of salinity of the ocean. Now please understand one thing before we move ahead. Very often you have studied, before I tell you this, when I talk about 7 like this is 7%. What does this mean? 7 per 100 parts. Can I say this? When I say 7%, can I say 7 per 100 parts? Or can I say 7 upon 100? Can I say 7 per 100 parts? You can say this. There is nothing wrong in that. Similarly, please remember, if you take that analogy, if I write this statement, 7, 2 dots, it is not now per 100, it is per 1000. It is now 7 per 1000 parts. Always remember this. When one dot and one dot over here, this means 100. If there are 2 dots here, this is out of 1000. If there are 3 dots, then that means out of 10,000. Clear? Now understand this. When we are going to talk about salinity, everywhere, even if I have not written this symbol, keep it in mind, it is per 1000 parts. Remember that. Because there is a map that I have drawn here. Where is it? Just let me show you. Over here, and I have just mentioned 35, 36, 37. So it is all of them are in per 1000. Clear? Okay. So what is salinity? Salinity is the weight of the dissolved material upon the weight of the sample of seawater into 1000. So based on that, we get to know about what the salinity is. The estimated salinity or average salinity of the ocean is basically 35 parts per 1000. Now, when I talk about the ocean, please remember it is not only the sodium chloride or the table salt which we talk about. There are other salts also that is present in the ocean or the sea water. Now this can be asked in your paper also, and then whether they can ask you to arrange them in order, because this has been asked in the CAPF paper also by UPSC. So it can be asked in civil services also. NaCl 77.8%, MgCl magnesium chloride 10.9, magnesium sulfate 4.7, CSO4 calcium sulfate 3.6%, potassium sulfate 2.5, calcium carbonate 0.3, magnesium bromide 0.2%. So this is an idea approximately of the salts that are present in the ocean. So it is not simply sodium chloride. There are a lot of other salts present. Their order can also be asked. So please be careful in your mind, particularly in the PCS, particularly in the CAPF paper, particularly such types of paper. These are very frequently asked, and in the UPSC paper also they can very well ask you. Clear? Okay. What are the factors impacting salinity? Let's see. First is evaporation. See, greater the evaporation, please understand why the ratio is, the question is weight of dissolved material, that is a salt that is present, upon the weight of sample of seawater. Now, if the evaporation is taking place, the weight of the sample of the water content will decrease. Obviously, the salinity content will increase. So, more is the evaporation, the salinity in that particular water will increase. That is why if you realize the Mediterranean Sea, in Mediterranean Sea, the salinity content is relatively very high. Why is it high? Because over there, the evaporation is taking place at a very rapid rate. Landlocked region and evaporation is high. So, salinity content is very high over there. Next comes precipitation. Now, when the more water is added, it is like, for example, if there is a glass of water, you have certain amount of salt that is added to it. You add more water, you will dilute it. Earlier, when you had added salt, you were not able to drink because it was the parts per thousand. If you realize it from that perspective, it was very high. But after that, when you have diluted it, it is not drinkable because the dilution of the salt has taken place, or the amount of parts per water have increased. The water content has increased. So, when I talk about the precipitation, more water is being added to the water body, so the salinity will decrease. Similarly, this example is Baltic Sea. When the precipitation takes place, the salinity is very low. Third is influx of rivers. Those regions where rivers or freshwater rivers freshwater is being added through the rivers, in those regions, the salinity of those particular parts are going to be relatively lower. If you compare it, that is why if the Bay of Bengal region where water is being added to it by Ganga River, Brahmaputra River, so you will realize the salinity content is relatively lesser. If you talk about the ocean currents, you should understand this very well, that ocean currents are also very, very important perspectives with respect to the salinity. Now, what happens sometimes is that the ocean currents are those drivers which take or vary the salinity. Supposingly, in a region, ocean current is going, it might carry certain water from a region to another region. Or let us say when there is upwelling, you will realize that there is a possibility, we've already done upwelling where cold, dense, saline water can come up. So that region where the upwelling is taking place, there's a possibility that more salinity can be present there. So with respect to upwelling and downwelling also, you can realize that ocean currents also very significantly impact the salinity of a region. Next, ocean atmospheric circulation. Now please understand, when I talk about atmospheric circulation, let us take an example. Example is high pressure. When I talk about high pressure, let us talk about, if a high pressure center is located, can I call it anticyclone? If the atmospheric circulation we're talking about is anticyclone, it is going to prevent the rainfall taking place predominantly. Obviously, there are a lot of other phenomena that are taking place. But if there is a high pressure region with an anticyclonic condition, then it is going to bring aridity there and it is going to prevent rainfall from taking place. So, if there is high pressure region and atmospheric circulation with respect to high pressure region or anticyclone, you will realize there is going to be prevention of rainfall taking place there and more aridity. And that means that there is going to be an increase in the salinity over there because it is going to be more arid. Rather than precipitation, there might be more evaporation taking place. So, the salinity will increase. Next is anthropogenic activities. Now, these are very discrete or very like broad category where it depends upon what type of activities human beings are indulging in. Supposingly, they are indulging in, let us say, some factories or some, let us say, some mineral factories are there, more mining is taking place in certain regions. Now, that might add salt to the coastal region. So, those all factors, wherever human beings are involved, their responsibility with respect to certain addition of salt or deletion of salt will be referred to under the category of anthropogenic activities. Clear? So, these are all factors which are basically responsible for the salinity. Vertical distribution of salinity, please remember something very similar to what we had done in the temperature. There is another similar category over here. Please see. When I talk about the region where these are two types of lines I have drawn, one in the lower latitude and another in the high latitude. Please remember, let us take the surface. This is the surface layer. There are three layers again here. The surface layer, Then you have the halocline. Halocline is very similar to the thermocline, but over there thermocline the temperature was decreasing rapidly or changing rapidly. Over here the salinity is varying very rapidly. So this is not a halocline layer, and this is a deep layer, third layer. Now see, first of all, let us see the surface layer. Do you realize in the lower latitude, the salinity is 37 parts per thousand, while in the upper latitudes it is 33 parts per thousand? Something very interesting to hear, that the salinity of the regions which are close to the equatorial region has higher salinity in comparison to those which are in the higher latitudes. Anybody has thought about it? This is something very confusing for some people. How is it possible, sir? Because many people say that there is a lot of rainfall in the equatorial region, so how come? Please remember one thing very clearly. Firstly, when we talk about the equatorial region, we need to understand if there is a lot of rainfall, there is a lot of evaporation also taking place. So the evaporation that is taking place is of a great extent. Now, evaporation is a force that is basically trying to increase the salinity, and precipitation is trying to decrease it. So overall, the balancing effect ends in close to 37, that is again the average salinity also. But when I talk about the coastal region, you know that it is a region where high pressure is located, and you know the rainfall is not there. Now in those particular regions, we should understand that it has fresh water. Those glaciers and the snow are stores of fresh water. The melting of those glaciers add fresh water to the regions of the colder or the high latitudes. And that means like over here, there were two contradictory forces acting. One is pushing the salinity higher, other is decreasing. But you realize overall balancing effect brings the salinity to an average value of 37 parts per thousand. But in case of the higher latitudes, you see that the melt, because there is no evaporation as such a great extent taking place, because there is, as it is, very cold conditions present. Yes, there is evaporation in every temperature, but the extent is kinetic energy is less with respect to the water molecules because it is already frozen most of the cases. So over here, the melting of ice is adding a lot of fresh water. Now the melting of ice adding fresh water decreases the salinity of this region. Yes. Now the important dimension over here comes. That is why at the surface layer, the water over here at the surface level, the colder region has less salinity. As you move down, this factor of fresh water being added over here is a predominant factor that decreases the salinity at the surface level. But as you move down, you realize there will be similarity over here. Over here, it is high because of the evaporation and all. As you move down, halocline, both the things will, again, this will decrease and this will increase, because both the factors in the surface level are not present over here. So slowly they will almost become close to each other. So this is the layer of lowest density also. Now please understand, it has thickness of 100 to 200 fathoms, carries 2% of the total volume of the water. Density is liable to obviously temporal variation, but what is important here is that the surface layer, at the surface layer, two things are important. First, the lower latitudes have a different salinity in comparison to the higher latitudes. How? Let us see. The lower latitudes have higher salinity. Why? Because of the arid conditions. Arid condition, the way, due to evaporation, not arid condition, just please write it again. Evaporation, not arid condition, evaporation, very high. Not arid, evaporation. Evaporation being very high, so that means greater evaporation. On the other hand, you realize that there is rainfall also, so the balance effect comes to be close to 37 parts per thousand. But over here, when you see, there is low salinity. This low salinity is an outcome of the fresh water that is added by the glacial melting add water. Now this is already fresh water. So this decreases the salinity at the surface level. So these two things are again the most critical over here. Clear? Now if you come to the next layer, that is halocline. The halocline is a layer just below the surface layer where there is rapid change in the salinity. At the ones with the lower latitude over here, you will realize that it is going to little bit increase. It is going to decrease, while on the higher latitude it is going to little bit increase, so that they come close to each other. Halocline separates the surface layer from the deep layer. Then you have the deep ocean. This is more or less uniform with respect to the salinity due to the accumulative effect of denser, saltier water from the evaporation and sinking processes limited freshwater input. So these are the basic aspects. In the deep layer, as we had seen with respect to temperature also, you realize that it is almost the similar site of salinity is present. Clear? Okay. Horizontal distribution of salinity. Again, as we had done with respect to temperature, we are doing this also. The average salinity is around 35 parts per thousand. The highest salinity is between 20 to 40 degrees, which is 36 parts per thousand. Now, the important thing is over here, why is the salinity highest around this, not at the equator? You know that the equator, again, please remember, again, evaporation is more, precipitation is also there. But if you see over here in the case of the region little bit above north of the equator, over there you realize the precipitation is also there, but precipitation is little less, but evaporation is very high. So in those regions you realize the salinity is again tremendously high because high temperature, high evaporation and low rain. Average salinity around 10 to 30 degrees south, that is 35 parts per thousand. From 40 to 60 degree north and south, again 31 to 35 parts per thousand. Salinity decreases around the polar regions because of the influx of melting ice. Overall, the northern hemisphere have 34 parts per thousand and southern hemisphere have 35 parts per thousand. Now, the important dimension is more fresh water added and less evaporation. That is why you realize that the salinity is 34 parts per thousand here. Write it down. Write it down here. Why? Please understand, na? Why southern hemisphere have more salinity? The northern hemisphere has higher temperature of the ocean, but the southern hemisphere has more salinity. Why? Southern hemisphere you do not have land, so the evaporation can take place more because of more water surface is exposed. In the northern hemisphere you have the continents also, so lesser ocean surface is exposed to what? To evaporation. Because you know that the surface area is directly proportional to the evaporation taking place, so lesser the surface area being exposed, lesser is the possibility of evaporation taking place. In the southern hemisphere, you have more area of water because it is more of a water body, because in the northern hemisphere, you have more continents. In the southern hemisphere, you have lesser continents, more water. So in that case, more water is exposed to evaporation taking place. So that is why the salinity is little more in comparison to this, because in northern hemisphere, because the land is also there, so water through the rivers can also be added. So that is also a fact. So fresh water addition and less evaporation. So these are the two major reasons. Clear? Okay. This is again roughly, just see here. Again, over here 35, but as you move ahead, 37 over here because of the evaporation being more. The salinity has gone. See, this is again the salinity is 35 over here because the North Atlantic drift is taking the salinity upward. Similarly, you realize these are the salinity distribution based on the 35 over here, 30 here, 32 here. 32 here, why? Because Antarctica melting ice is there, so it will decrease. In these regions, obviously, where there is 37 here, because these are the regions of high evaporation and lesser rainfall. That is why it decreases. Otherwise, this is how the distribution is. Little bit above the and below the equator, you have the higher salinity. As you move upward, it will decrease. As you move downward, also it will decrease. Next comes the very, very important topic, that is the motion of the oceans. Let us study them one by one. Okay. Movement of the oceans is basically again a very important factor which we're going to study with respect to the tides, ocean currents and waves. When we studied this chapter, there are two types of motion which are broadly described in the NCERT. First is the vertical motion, which is the tides. Horizontal motion includes the ocean currents and the waves. Now, you need to understand why this is so. Please see. If you see here, let us understand the reason. If I see the tides, now tides are basically rise and fall of the water because of the gravitational force of the sun and the moon. And that is why it is just rise of the water level. So that is why it is known as what? A vertical motion. So it is type of motion is vertical. Now let us see the ocean currents for the timing. Now ocean currents are like rivers in the ocean, which are basically following the direction of the prevailing winds or the winds. So they are moving from one region to another. So it is like a horizontal movement, that is sideways along the surface. That is why it is a horizontal movement. Now comes the ocean waves. Please understand, ocean wave is not the movement of the water. Waves are created because of certain disturbing force that is created or acted upon the water. Whenever you add certain, let us say there's a water surface, you add a finger there, there will be ripples created on all directions. A very miniature waves. Why? It is not that the water is moving. It is the energy that you have supplied to the water is basically being transferred. That is also being transferred in what? The horizontal manner. That is why that ocean waves are the energy moving sideways or in all direction in a horizontal manner. So these are categorized into horizontal motions and tides into vertical motion. Let us begin first tides. Now tide again is very interesting concept. We will be studying various dimensions associated with it. So please understand it. When I talk about tides, tide is what? A periodic rise and fall of the sea level. What it is? It is basically a periodic rise and fall of the sea level. Now, why it is being caused? It is basically being caused by the attractive or the gravitational force of what? The moon and the sun, right? Now you will say that sun is so far away and still it is exerting a force, and moon also. Yes, see, we need to understand that overall impact with respect to the tides, it is more of the moon than of the sun. The reason is we know that sun is tremendously huge, but it is very far off, while the moon is close by. So again the gravitation is also dependent upon the distance between two bodies, right? So when the distance is less, the force that is being exerted on other body is also more. That is why though sun is also contributing to the gravitational force, the moon is also contributing, but the impact that the moon causes is relatively more because it is just a neighbor of the earth, right? That is the reason. Now attraction by the sun and the moon. Now the characteristics. First, periodicity. Tides occur at regular intervals. Unequal height. The successive tides might not be of the equal height because again it is depending upon the gravitational pull, and that is dependent upon the position of the moon. Influence the coast. Now the tides that are coming also influence the coastline also. They might shape the coastline. Predictability. Because we know the movement, the speed of the moon, we know the speed of the rotation of the earth, the revolution of the moon, and all these factors are known. So astronomical calculations, you can basically predict very accurately where the tides are going to happen. Next is vertical motion. It involves rise and fall, which we've already studied. Next is ecological and economic importance. They're of great importance, particularly like navigation. Shallow ports, tidal energy or mangrove ecosystem protection are also one of the important means which are being met by tides. So these are what the characteristics that you all should be very well aware of. Clear? Okay. Let's move ahead. Let us understand, leave this diagram for 2 minutes. Let me hide it rather, right? Let us see this diagram does not even exist, okay? Let's come here. When I say what are the causes for the tides, something very, very interesting. So what causes tides? Please make us understand this. See, I've already told you something that it is caused by the gravitational force of the moon and the sun. When I've mentioned these, this is not so easy that it appears to be when I tell you, right? It is very easy to sound, or very soothing to sound that it is due to the gravitational force. Now, there are a lot of complex issues, types that are basically being dealt over here. We'll deal with them in the coming slides also. First, let us take only the moon. This is Earth, this is moon, and this line that I've drawn, it is basically representing that the water is being pulled by the gravitational pull. Water from the Earth is being pulled, and that is why the tides will come. So this is known as a tidal bulge, right? Gravitational pull basically leads to water being exerted, force being exerted, and that is why water in this side, which is facing the moon, will be pulled towards its side, right? Pulled towards its side. So this is known as a tidal bulge. Second things, for the timing, let us say for 2 minutes, let us forget this moon also. The sun's gravitational pull. Now, sun's gravitational pull is also being exerted on the earth. Now, it will also pull the water, whatever gravitational forces has. So, this will also create a tidal bulge. Now, these are two phenomena that, okay, it's fine, understood. Now, it will depend upon what is the position of the moon and the sun also to actually get what the tidal bulge or the strength of the tide is. That will depend upon that, which we'll be seeing in the next slide. Now, there's one other very interesting concept that happens. Supposingly, the tidal bulge is being created. The water is being pulled this side, right? Now, you know that there is a basic concept that Earth has to maintain a balance with respect to the forces that are being exerted. Now, when the force is being exerted inward in this direction, there will be a counter force that will be generated in the opposite direction to balance the gravitational force. This force is known as a centrifugal force, right? So, this is what? This is because of the gravitational force. This is because of the gravitational force of the sun. Now, there is another force that is created which is on the opposite direction. Which is known as the centrifugal force. Obviously, there is going to be a tide bulge over here also, but this is in opposite direction of the gravitational force. Why? Because in order to balance the gravitational pull of the moon or the sun, a tidal bulge is created on the exactly opposite side so that it balances that force, and this is known as the centrifugal force. The centrifugal force. Now, if I combine all these three diagrams, let us see the result. Sun and moon are exerting gravitational force. So, this is a tidal force. This is a tidal bulge that is created. Let's write it down. This is a tidal bulge. This tidal bulge is due to the gravitational force, right? It is due to the gravitational pull. Gravitational pull of, let us say, of moon and sun. Moon and sun. Let us write it this way. Now, on the other hand, you know that this is also a tidal bulge because this is moving out. But this is not due to the gravitational force. This is not due to the gravitational force. The reason behind it is that it is because of the force which is countering the gravitational force. That is how stability is maintained. So, the force is being exerted here. It is a counter force being exerted here. That is because of the centrifugal force acting in the opposite direction. And that is why the resultant is this. So, you have at any particular point, if you are having a high tide in one place, you will be having a high tide exactly at the opposite place also. So, if two places where there is low tide, you will be having low tides in the opposite direction. Opposite, like if there is earth over here, if there is high tide here, there is going to be high tide here. There is low tide here, there is going to be low tide here. Clear? So, this is the reason. So, this is the cause overall if you study. Now, let us study the type of tides, right? Now, we had studied that, okay, gravitational pull is there, all those stuff. That is very interesting to study and understand. But the important thing more over there is that what is the position of the moon and the sun? Now, see, let us study the type of tides on the basis of the position of the sun, moon and earth. Let's see. There's one concept known as spring tides. What are spring tides? Whenever the sun, moon and the earth are in a straight line, whenever they are in a straight line, in that particular case, let us remove this for a timing. When they are in a straight line, the gravitational force which is basically attracting the water is again combined. That means the gravitational pull is combined of both the bodies. So what happens is the tidal bulge that is created again the gravitational force will be more. Because this is gravitational pull of moon plus gravitational pull of sun combined, because they're in the same direction. And we know that very well. There will be again a high tide over here also on the opposite direction. Now see, this is in the case of when moon is between sun and earth. In this case also it can happen. On the other hand, if the condition is of a full moon, then also it will be adding. Why? Because water is being pulled here by moon and water is being pulled by in case of the new full moon condition by sun. So in both the cases, then also the tide is going to be much more than the average tide. And that is why this is known as a spring tide, much more than the average tide, right? That means it is very strong also. Now, if I've said that both of them are in one line, so it can happen twice a month, one on the day of new moon, another on the day of the full moon. So when the sun, moon and the earth form a straight line, the result is in a higher tide level above the standard or the normal tide. That means more than the standard or normal tide. Clear? So this is again being represented in the form of spring tide. Now, there's something else that can happen if they are not in a straight line. Now let us see this. Supposingly, now the moon can be here also. Anyway, we are taking this example. Now the sun is going to exert some gravitational pull. So it will try to have a tide in this direction. So water over here, you will have no tide, lower tide. Over here it is high tide. But on the other hand, the moon is also present in that way. So it will try to pull water that side. So you will have a tide which is much lower than the standard tide, because the gravitational pull is basically being subtracting. So you will not have normal tide also. You will have much lower than the lower normal tide. So this is known as a neap tide. What is neap tide? When the sun and the moon and the earth are at right angle, the resultant tide is lower than the average tide. Why? Because the gravitational pull overall, the net gravitational force is again getting subtracted. Can I say gravitational pull of moon minus gravitational pull of sun? Because the gravitational pull of the moon is going to be more over here with respect to tide, because it is closer. That is why. Net gravitational force is gravitational moon minus gravitational force by sun. So it is going to be less. In that case, it was being added. It is being subtracted here. So obviously it will be much below the normal tide. So it is called a neap tide. Clear? Okay. Next is magnitude of tide based on the aphelion and perihelion. For the timing, let us take one by one. Let us leave this part. Let's see here. This is earth, this is moon, this is sun. Now if you see, perihelion is a condition when the earth is nearest to the sun. When it is nearest to the sun, you will realize that it will have tides which are relatively higher or a greater degree. Why? Because the distance is less, so the gravitational force being exerted will be much more than when it is far away. So what happens here? Can we write it here? Here at perihelion, perihelion means nearest to the sun, right? It is close to on 3rd January. Over here, sun will exert more gravitational force on earth, thus a higher tide strength. You can call that also. On the other hand, and this generally takes place around January 3rd, when it is closest. At aphelion, if you realize, at aphelion, the reverse will happen. Reverse in the sense that the tide is not going to be strong because the distance is more. So strength of tide lesser than usual. Lesser than usual. Clear? Same thing exactly comes when we talk about perigee and apogee. Perigee and apogee is basically with respect to the distance between the sun, between the moon and the earth. Perigee is a position where moon is closest to the earth. So what will happen at perigee? At perigee, you know the force of the gravitational force being exerted by the moon on the earth is going to go very high. Moon will exert high gravitational force on earth. Thus this will lead to higher than usual tides. At apogee, you will realize distance is more. So the gravitational pull will be less. Gravitational force is less by the moon that is exerted on the earth to pull the water, right? That is less. So the tide, the strength of the tide is going to be less. Tide less or less than usual or standard, as we say. Clear? Okay. Now, on the basis of frequency also, there are certain books which classify them on the basis of frequency. That means how frequent they happen. So there are semi-diurnal tides. The most common tidal pattern featuring, that means there are 2 high tides and 2 low tides in a day. This is semi-diurnal. Then there are diurnal tides. That means there is 1 high tide and 1 low tide in one day. And mixed tide, that there is variation with respect to the height of a tide. So this is known as a mixed tide. So these are again a third categorization of tides which we study here. Next comes, with respect to tide, there is a very, very important concept which is very often neglected but very important, that is mentioned in one line in the NCERT. So like Ford's concept was asked in the NCERT, in the syllabus this time, in the UPSC paper, so this can also be asked. Tidal bore. Now what is tidal bore? Please see. Tidal bore are basically very remarkable phenomena that manifest when tides surge into the narrow, shallow river estuary. Let us assume this is a land and there is a river that is flowing in this direction. Now, when the tides basically come from this direction, what happens is the rate of flow of the river is already very less. Why? Because it is at the lower stage. It is not at the young stage where the water speed is going to be very high. It is not that case. Where the water is going to be flowing very gently because it is merging with some sea or ocean. Now, at this moment, when the tide basically comes at a very fast pace, it will create certain wave-like structures, which is known as tidal waves, and the water will start moving in the reverse direction. So the water will be moving in this direction. These are tidal waves, which are known as tidal bore. People sometimes even use them for surfing also, right? In Chinese region, in China also. So this leads to tidal waves whose leading edge are nearly vertical. That means the waves type structure that are created, they are almost vertical. It depends upon the strength also. Now every region does not have such strong tidal bores, but in certain regions, yes. Like the Quanting River in China, they experience relatively very, very strong tidal bores. So this is again a very important concept that you should know. This can be asked in 10 markers. Significance of the tides, they are used in navigation, like the Haldia put in Kolkata you have seen. Fishing, high tides attract fish closer to the shore, so that can be useful for fishing activities. Next, you have the desilting. When the tides come, they remove the silt or the sediments that have been deposited by the rivers along the coastal region. Coastal erosion management, they influence the sediment supply that has come. So that means they're managing, because what extra sediments are there, they can be removed, and whatever certain new sediments are required, they can be brought by the tides also. Tourism and recreation, like surfing activities can be there. So they are a hub of tourism activities also. Ecological significance, tides bring nutrients. Now these regions are very useful because there is a mangrove ecology might be associated with this. There are coastal ecosystem that is there. So the nutrients might be brought to these regions which are useful in balancing the ecosystem. Climate regulations, again, these are again helping in climate because they sustain the mangrove system, also coastal ecology, so they can be very useful for maintaining the or regulating the climatic conditions also, particularly the coastal regions. Energy generation, now these can be used for generating energy. For example, 3 megawatt at Durgadurai regions in West Bengal has been basically implemented over here, so it can be used for generation of electricity also. Let's move ahead. Waves. Now, waves are again something very common, but again, we should understand this. There is no movement of water. It is simply the movement of disturbance. Waves are oscillatory motions. I will tell you why oscillatory. You will understand that also. When I go ahead, I will be explaining you. Like for example, there's a wave here. The motion is like this, right? Beneath the ocean, right? These are round oscillatory motion that are going on. Clear? Oscillatory motion of the water where rising and falling takes place. Why rising and falling? Again, this is the crest, this is the ebb. This is how the waves move. Rise and fall, rise and fall. The disturbance are traveling. So this is what again is rise and fall, leading to circular motion of the each wave particle. So over here, this is a circular motion of the oscillatory motion that is taking place of the particles. Now, they are moving energy. See, they are moving energy. Why I'm saying moving energy? Because the disturbing force that has been created, that can be due to earthquake, that can be due to wind, that can be due to volcanic eruption. They can be created because of any of the factors. Like tsunami is also waves, great harbor waves. Why? Due to, let us say, volcanic eruption or earthquake, underwater earthquakes. In that particular case, you will realize that these waves can be very huge. Now, these waves are not water traveling. These are basically disturbances that are traveled because of the shock wave that are created. So, these are moving energy because the energy is being supplied to water and that energy is being basically moving, or the disturbing force that is moving. Now, characteristics, these are oscillatory in nature. We have seen there are horizontal transmission that is moving from, the disturbance is moving from one place to another. Generating force are generally the wave, the wind also over here. Wind can be one of the factors. Various others. Generating force is basically again short lifespan. When the waves move, after some time they clash with the coast or they do not have a very long time span, unlike the ocean currents. Transforming the coast, because when they clash with the coast, they might even cause erosions also. So they might change the shape of the coastlines. They have varying height. Again, the height will depend upon the extent to which the disturbing force has been acted on the water. Causes of waves. First is air-water interface. Now, wind blows across the ocean surface. Wind can itself blowing create waves depending upon the speed of the waves. Water surface. See, when the water of different densities basically come together, there are like different water masses. Why? Because they have different density. When they come together, it is like two bodies coming together and hitting. And then on other direction, the waves can be created. So water-water interface, it can happen. Mass movement. Now see, it can also happen. Mass movement means, let us say around the coastal region, there is large landslide or water, let us say large boulders basically fall inside the water. Now that will lead to waves being created. Or let us say huge ice particles or large glacier, let us say mass of ice has broken and fallen into the ocean. That can also create waves, and those are known as splashing waves or splash waves. Why? Because something has fallen in the ocean and splash is being created, and that is leading to the creation of waves. So those are another splash waves. Next is underwater regions. Underwater regions can be an underwater earthquake, underwater volcanic eruption that has taken place, underwater avalanche that has taken place. That can basically cause underwater aspects. Next is gravitational forces. Now the gravitational pull of the earth and the moon can also call tidal waves. Tidal waves are also a form of waves, right? Because of the tide, some waves can be created. You've seen in the example of tidal bore also. So these are also the categories, types, right? Or the causes. Certain important aspects that you should know. First, you have already understood the oscillatory motion. So let us see first of all, let me highlight it a little bit. This is a wave that I have mentioned here, right? Up and down, up and down, up and down. The this part, which is the top part of the wave, the highest point of the wave is known as a crest. The highest point of the wave is a crest. This is the lowest part of the wave, which is known as the trough. This is known as a trough. Now, the distance between the crest and the trough is known as the wave height. The distance between the top and the loam is known as the wave height. Sometimes what will happen is there is especially this imaginary line that is created here, and this distance is known as the amplitude. And amplitude, that is why, is referred to as half of the wave height. Now, the distance between one crest and another crest, or one trough and another trough, is known as wavelength. So this horizontal distance between two successive crests or two successive trough is known as wavelength. Two important concepts which are also there: wave speed. The rate at which the wave moves through water is known as a wave speed. Wave frequency, the number of waves that are passing to a particular point in particular point in a unit time is known as the wave frequency. The number of waves passing through a given point during 1 second or a unit time is known as a wave frequency, right? So these are the important concepts that you should be aware of. Again, these have been done in school also. You do it in physics chapter also with respect to waves when we study. This is something we should be aware of, and this is again simply applied to the oceanography chapter. Now, having done waves, I'm giving you a little bit of case study of tsunami. We have already done this earlier also, but why I'm giving you, so that you understand this is also an example of wave. When I talk about tsunami, you have seen that tsunami, su means harbor, wave means nami means wave. Now, these are great harbor waves. That means these are very huge waves that are created, which rise like wall, and they are so huge and they cause massive destruction when they hit the coast. Now, that is why, please understand, there are certain features which are associated with it. Fast speed, amplitude increases near the shore, series of waves triggered by, let us say, earthquake or volcanic eruptions majorly. Wavelength is long, unpredictable, a run-up or inundation that they might go inside large region inside the earth or in the coastal region also, and deep inside because of the force and the water that is there. Multiple causes, sudden onset. Now, in order to remember these fast worms, initial words of all of them have been mentioned here, so you can remember the characteristics by this mnemonic. Major causes, fault movement. We've already done plate tectonics. You would have seen that if there is certain fault movement, you will realize that that will create a lot of seismic waves that are created. Now, these seismic waves are basically what? Again, forces that are going to trigger, let us say, a lot of energy, and this might lead to creation of upward forces, and these waves travel along to the coastal region, and these are also known as tsunamis. One. Second can be plate tectonics. You know that very well. These are various plate boundaries that you have seen in the topic of geomorphology when I was doing. See, movement of plates themselves can cause waves. All of the three can cause. If there are two conservative plate boundaries moving, there is certain motion that can also trigger certain waves. If there is destructive, if there is constructive plate boundary, there is two plates are moving apart, that can also cause certain amount of waves. But when I talk about the aspect of the destructive plate boundary, where it is thrusting or subducting below another plate, this actually leads to a lot of very large scale tsunamis also, right? So the destructive plate boundaries are very often associated with very large earthquakes, along with it very large scale tsunamis also. So these are, again, all of the three can cause one or the other way, but this is the most important one, that is the destructive plate boundary. Now, the release of energy due to the plate movements lead to creation of large waves, which are known as the tsunamis, which we already studied. Now, another reason can be landslides. If supposingly this is a mass of land that has basically moved down, when it moves down, it pulls the water along with it. What along with it? See, it has gone down, the water level has gone down, and this has risen. Now, these are like the waves that are created, which can also be very huge and which can again go to the coast in the form of tsunamis. Next is volcanic activity. Now, when the volcanic eruption takes place, it basically causes very large shock waves. Now, these shock waves again lead to large waves in the form of tsunamis, right? Okay. Others can be certain blasts that are done by human beings, certain bombs attack have been done by human beings, or some meteoroids have hit the earth. Those can also cause, again, tsunamis, right? So these are few of the causes. The most important means are generally volcanic eruptions and the earthquake. Now, if you see this map which I've shown you on the board, this is basically the Pacific Ring of Fire. Now, the Pacific Ring of Fire is, again, we have studied in the topic of plate tectonics, which I told you that this is the most active, tectonically active region.
being more tectonically active, so it has the largest number of the earthquakes and the volcanoes which you can find here. And that is why you will realize this, that these are the regions which are more subject to tsunami also, because it is more tectonically active. Clear? So, if you see recently, on 30th July 2025, 8.8 magnitude earthquake basically took place near the Kamchatka Peninsula, right? And then tsunami warnings were triggered, though again, much destruction did not take place. So you realize that the reports that were released basically talked about a shallow reverse faulting that took place, which was basically seen over here for the earthquake. What is the reverse faulting? We have done already in the chapter of geomorphology. This is the hanging wall. Instead, when the hanging wall goes down, it is faulting. When this hanging wall goes up, it is known as reverse faulting. This is a hanging wall. This is a fault plane. If initially it is in this position, right? Normal fault is when this block moves down. But if this block moves up along, then this is known as reverse faulting. Now, this reverse faulting has happened because of certain compressional forces. Very important. Because of some compressional forces which led to this massive earthquake taking place. We have understood that this is a reverse faulting case, but what were the compressional forces that took place that led to this massive earthquake taking place? See the compressional forces. The report also says that there was subduction of the Pacific plate under the Oshtash plate, which was creating the compressional forces. And that led to the reverse faulting, which led to that massive earthquake. So this is again report. This is the report mentioning the same thing which I have mentioned here. Okay, coming to the next topic, that is ocean currents. The ocean currents are like the rivers that are flowing in the oceans. These are basically following the direction of the winds. Like if you see the map also, the ocean currents which I'll show you, they are basically following the direction of the winds, right? See, the ocean currents refer to the continued mainly horizontal movement of the ocean water. They are like rivers in the ocean, and they play a very important role in transferring heat or energy maintenance, right? The warm currents basically make the warm water travel towards the upper latitudes, whereas the cold currents from the upper latitudes to the low latitudes. So it is trying to balance or maintain it. You've already studied this, that I've told you previously also, that when I was studying you the other parts, I told you that there is a concept of upwelling and downwelling, right? And you know that the ocean currents are not only surface, there are deep water currents also. We have studied that also. So you should keep that in mind. Characteristics. There is horizontal movement. There is permanent and long lasting because they are following the same pattern or same path. There are definite direction and path. They can be warm and cold. There are seasonal variations. In the Indian Ocean, if you realize, with the reversal of the monsoon, you see that the ocean currents also change. Impact climate and weather. Obviously, wherever the cold currents are flowing, they result in arid conditions. They might lead to deserts also. Wherever the warm currents are flowing, they might lead to increase in temperature of that region. Ecological and economic significance, very similar to what we had studied in the tides also. So you can see those regions are important for breeding grounds, for fishing, let us say fish catching. These are regions which influence the climate of the region. So as they influence the climate, they influence the daily life of the people also. Next, factors influencing the ocean currents. Let us see this. Wind. The friction between the moving air and the water surface is crucial role. So this is the surface of the water. The wind is flowing. It exerts pressure on them, that is frictional forces, and it forces the water to move in its direction. So wind is the most important cause for the ocean currents. Second is Coriolis force. Coriolis force means, again, as we have studied in the climatological chapter, as the winds are being subjected to the shift in the direction because of the rotation of the earth, similarly, the ocean currents are also subjected to a similar direction. Gravity, it pulls down the water down and creates gradient variation. Solar energy, it causes the water to expand and because it gets warm. Salinity, it makes the water dense, so it might sink. Along with that, you realize underground topography. Underground landforms deflect the ocean currents. Similarly, the coastal landforms, when the ocean currents encounter a land, it tends to divert the direction because of the coast, and they start moving along the coast. So this is again deflecting the ocean currents. Let's move ahead. When I talk about the types, please understand we've already done something related to this, where I've told you that there can be cold currents. That means the cold currents are the ones which are taking the cold water from the upper latitude to the lower latitudes. and warm currents are the ones which bring warm water in the cold regions. On the other hand, if I talk about the depth, the surface water currents which are up to a depth of close to 400 meters, whereas the deep water currents are the ones which are flowing deep close to the sea bottom. And I have already explained you the concept of upwelling and downwelling in that case, right? What are the impact? See here, impact are first heat balance. Heat balance by the warm water taking warm water in the upper latitudes and the cold current bringing the cold water in the lower latitudes. So it tends to maintain the balance. That is known as heat balance. Next is rainfall. Now please remember the regions where the warm water is flowing, it tends to increase the temperature and it also increases the chance of water or rainfall happening. So it can basically help the region get more rainfall. Fishing. Newfoundland regions where the cold and the warm currents basically mix. Those are regions for very good quality fish, and fishing is one of the major economic aspects of that. So they are very useful for the fishing. Next is the climate. Again, climate is being impacted. We've already done that. Like for example, if the cold current is flowing along the coastal region, it might cause desert-like condition like the Patagonian desert. Now, it is also an outcome of the currents that are flowing, like the Peru current over here or the Humboldt current is also influencing the Patagonian desert being present here. Yes, even the Falkland current is also present here. So on the other hand, if you realize that this region is not frozen during the time of winter, the coastal region. Why? Because of the warm North Atlantic drift that is flowing here. So that is why the climate is also influenced. Tropical cyclone. Tropical cyclones, one of the preconditions that we had studied is existence of some low pressure. Low pressure is again brought by the warm currents also over here. So it basically helps in the creation of the ocean current or tropical cyclones. Last is navigation. When the ship or a water body is basically boat or a ship is flowing in the direction of the ocean currents, it basically consumes less fuel because it is moving in the direction of the ocean currents. So again helps in navigation also. Now let us see certain currents here. The red ones are the warm currents, the blue ones are the cold currents. Let us see the Atlantic Ocean here. If you see over here, this is North Equatorial current. North Equatorial current starts moving towards the northern part, and over here it forms a Gulf Stream. This Gulf Stream again is a warm current. It further moves upward in the form of North Atlantic drift. This is basically important for keeping this region warm, as it takes the warm water from the lower latitudes to the upper latitudes. Now remember this. Similarly, in the southern region, you have a South Equatorial current. This is a warm current which again encounters the Brazilian coast and starts moving downward. When it starts moving downward, over here it is known as the Brazilian current. Brazilian current. This is a warm current. Clear? Now please remember, this arrow which I have mentioned in the reverse order is quite interesting over here. This is flowing in the opposite direction. How come? The reason is, you have already understood that there is piling up of water along the coast of South America by the South Equatorial current and the North Equatorial current. So when it is piling up is done, so the water level raises, so there is a reverse current that flows which is in this opposite direction. This is known as a equatorial counter current. Equatorial counter current, right? Now please understand that this from the northern region over here, Labrador current comes. This Labrador current is again a very cold current because of the cold water that is coming, and this basically is one of the reasons why New York during the cold climate is completely frozen, the coasts are frozen during this time. Now over here, this is after from moving downward, some branch will move downward, and this is in the form of a little bit cold current which is known as the Canaries current. Later on it will again warm up and become a part of the North Atlantic current. If you come south over here, these currents that are flowing just in the southern ocean above the Antarctica, this is known as a west wind drift. Why it is flowing freely? Because there is no continent as such, so there is nothing to disturb them, so they are flowing. Some of them might just encounter the coast and turn upwards. This current is known as the Peru current. P-E-R-U, Peru current. Peru current, or it is also known as the Humboldt current. Peru current or Humboldt. Now this is one of the regions which makes this the western side as arid region with respect to South America because it is cold current.
Similarly, some of the parts might move little northward. This is not the Falkland current. This is also a cold current. Now, on the other hand, when the Peru current moves upward, when it comes closer to the equator, it warms up. Then again, it is basically moves in the form of south equatorial current over here. Again, north equatorial current and a counter equatorial current flowing here, which you can see in this direction also, right? Now, over here, see, this is again on the northern part, you have an Alaskan current. Alaskan current is a warm current. And there is a Californian current. This is a cold current along the coast of California. Now let us come to this region. Again, the west wind drift, some part might move upward. This is known as a Benguela current. This is again a cold current which causes aridity in the southern part of the Africa. Now, if you come here, you will realize some currents will move a little bit northward. Again, west Australian current, which is again a cold current causing aridity here. This is again a south equatorial current, and a equatorial counter current is flowing here, and an Agulhas current is flowing, which is an extended part of the south equatorial current along with the coastal boundary of Africa. There is a Kuroshio current which is flowing as northward in the form of a warm current along the coast of Japan also, and there is another cold current coming from the north, that is Oyashio current. So these are again the most important currents that you should know. If you know them, you can be very well use and understand them, how they are influencing the climate of a region also. Let us come to the topic of marine deposits. Now, marine deposits again are very important. We will be doing a lot of topics here. Ocean deposits. Now, ocean deposits, I'm just explaining you the chart right now, then we'll study one by one all of them, right? They're two broad categories. One is the terrigenous deposit and other are the pelagic deposits. Terrigenous deposits are divided into three categories: gravel, sand and mud. Mud is divided into further categories: blue mud, red mud, green mud, volcanic mud and coral mud. Then you come to the pelagic deposits. They are organic or inorganic in nature. When they are organic in nature, there are two types: calcareous and siliceous. Calcareous is generally found at not very much depth. That means less depth. Calcareous is present predominantly. As you move further in more depth region, or let us say deeper, you will find more siliceous deposits. Now, the calcareous has made up of two categories: petropod ooze and Globigerina ooze. Ooze is basically mud-like structure, mud-like formation, or which you will study right now also. So these are some form of mud. Siliceous can be diatomic ooze and radiolarian ooze. Inorganic are red clay. Red clay are the most dominant deposit that you can find in the ocean. Please remember that. We'll study now one by one. Let us see the terrigenous deposits. Terrigenous deposits are basically of continental origin. That means certain deposits or some erosion that took place on the continental surface, and they were again went through the form of certain erosional activities and went to the oceans or seas. So which in turn is an outcome of the weathering processes. That is why it is called terrigenous material. So terrigenous material is an outcome of the erosional activities that have taken place on the continents. Now, gravel. Gravel has itself a wide variety, right from boulder, which has an average diameter of 256 millimeter, to even a granule which is less than 2 millimeter in diameter. Gravel can include boulders, cobble, pebbles and granules. The extreme form being boulder and the smallest one being granule. Below the gravel, you have the sand. Now, sand again can be very coarse to very fine, but again they are very small with respect to the diameter when you compare it with the gravel. Now, when you talk about silt, they are fine than sand. They are much more finer than the sand. When you talk about clay, they are finer than clay. When I'm talking about mud is even finer than clay. So as you move further, it is becoming more fine and fine. This is again very, very important here. Clear? Now let us categorize. Let us see, we have already done gravel, sand, silt and clay. Mud, which is finer than clay. But mud has to be studied because there are various categories of mud. Mud is of various categories. Now let us study one by one. This is not mentioned in the NCERT. Please remember that and make sure that you do it well. Why? Because this is something that can be asked in your examinations repeatedly. And I would request you to please go through this well, because when you go through this, you will be able to solve many questions which might be asked in your mains examination in particular, not only prelims. So blue mud, it includes material that is derived from the disintegration of rocks that are rich in iron sulfide and organic elements. The ones which are rich in iron sulfide and organic elements. Now, this forms blue mud, and now it has 35% of calcium carbonate. 35% of the calcium carbonate. Now, when we move ahead, there is red mud. Now, the red mud is derived from the volcanic rocks rich in iron oxide. It contains about 32% of calcium carbonate. Next is green mud. Now, green mud is basically it is formed due to the chemical reactions where chemical weathering, wherein the blue mud is changed to green because of the reaction of the seawater. And you will see that calcium carbonate over here can be from 0 to 56%. Volcanic mud. Now, these are because of the material derived from the surface and underwater deposits. Coral mud again are those muds which are because of an outcome of the depositions which is remained by the corals. So, that is what is known as coral mud. Now, next comes pelagic. Now, let us see what is here. We have done pelagic. Now, pelagic has organic and inorganic and these categories. Let us study them. It consists of matter that is derived from algae and are mostly in the form of liquid mud. These are liquid mud-like composition which is known as ooze. Liquid mud is known as ooze, right? So, these are mostly derived from, again, organic resources. First are calcareous ooze. Calcareous ooze has two categories, petropod ooze and globigerina ooze. Petropod ooze formed from a floating petrobod mollusk, again organic, right? Which is conical in shape. And that is why again you realize that these have large composition of calcium carbonate. So, this ooze itself has 80% calcium carbonate. It is found at a depth of 300 to 1000 fathoms. 300 to 1000 fathoms. Then you have the globigerina ooze. Globigerina ooze. Now, this is formed from the shell of variety of foraminifera. But most of the ooze is formed from certain germs. Those germs are called globigerina, and that is why this is known as globigerina ooze. Now, this has calcium carbonate of close to 64% composition is calcium carbonate. Important thing over here is it lies between 2000 to 4000 fathoms depth, right? Next is siliceous ooze. Now, siliceous ooze is also has two categories. That means greater amount of silica is present here. First is radiolarian ooze. It is formed from the shells of radiolaria and foraminifera. Silica over here is 5 to 20%. Lime content decreases as with depth. I had already told you with depth there is more of the silica content rather than the calcareous content. This is found between 2000 to 5000 fathoms. Second under the siliceous ooze is the diatomic ooze. Now, they are formed from the shells of very microscopic plants containing silica in abundance. Now, they are formed close to 600 to 2000 fathoms at the higher latitude. So, these are because of the diatoms. Again, all of these are organic in nature. That is why it comes under the broad category of organic deposits. Now, what comes under red clay is it is inorganic in nature. That is the last. It covers the largest area of the deep sea. It has silica of alumina, that is 85.3% oxides of iron, and it contains radioactive elements. If you see the deep sea plains or the abyssal plains, the largest area that is covered is of the red clay. So it is the major or the largest deposits. If anybody asks you, is the red clay. Please remember that. Next comes the categorization of marine organisms. There are a lot of marine organisms also present. You should be aware of that. First are the plankton community. Now, the planktons are again diverse group of buoyant and floating marine organisms. You know that very well that these are planktons which are floating on the surface of the water. They do not have their own strength like the fishes to move from one place to another. They're just lying or floating, and wherever the water takes them, they move. So, extending up to 200 meters below the surface, they can be phytoplanktons, zooplanktons, algae, diatoms are present here. Next are the nekton community. Nekton community itself means swimmers. That means they are living organisms that can swim. So, that means they are basically comprising the fishes which can move from one place to another, not merely dependent on the motion of the water, but their own strength to move from one place to another. So, they move without being affected by the currents. Most of them are vertebrates and with various species of fish.
Now, last is the benthos community. Now, these are the ones which are lying on the surface of the ocean floor. Comprises all the plants and animals that are residing on the seabed. They can be seaweed, large algae, mollusk, and oysters. Clear? Okay, mineral deposits. Now, mineral deposits can be also of various categories which are found at various places. Some at the surface deposits. Now, surface over here are basically talking about with respect to continental shelf and continental slopes. And then you have the bottom sea deposits. Please remember this. The minerals of the continental shelf can be zircon, monazite, magnetite, gold, platinum, sulfur, phosphate. Along with it, oil and gas resource are majorly found here. Here also oil and gas. So minerals of continental slope, cassiterite, that is type of tin, gold deposits, phosphorates, oil and gas are found here. Then you have the deep sea bottom deposits. Over here, manganese nodules are found here. Again, International Seabed Authority has also given the permission to India to explore manganese nodules. Again, they are very important for the industrial growth of the country also. Now, manganese nodules, polymagnetic nodule, these nodules containing various minerals like nickel, copper, cobalt, lead, zinc, iron, silicon are found. So these are very, very important, right? Polymetallic nodules are also present. Then you have the sea floor massive sulfides. Wherever there are hydrothermal ore deposits, you will realize that they are formed closer to the hydrothermal regions, and massive sulfide deposits are also found there. Right? They can be sometimes greenish to even yellowish, greenish to bluish color also. They are very often found. Right? Next is the conventional resources. Now see, conventional energy can include the petroleum and the oil natural gases that are found here. Non-conventional can be tidal energy, which can be used, wave energy can be used, or OTCE, ocean thermal energy conversion. This can also be used as a mean, but it is a very expensive method and limited scope. That is why it is generally avoided. Last comes the topic, which is the law of sea. Now, please understand, this is a diagram that I've shown you. Now, I'm going to tell you certain things over here, concept of baseline, international water and all. Let's see something first of all before we move ahead. Have you seen very often that the coastline is not regular? Let us say it is like this. Now, how to measure the distance? How to measure the distance? Like we have seen over here, like they have said that territorial sea is 12 nautical miles. This is 12 nautical miles. How do you measure? Do you measure it from this region? How? What generally happens is, because the coastline is a natural form, so it cannot be of a defined shape. So what happens generally is, there is an imaginary line that is created, which is joining these pointed edges. Now this is known as the baseline. This part which is inward, landward side, this is known as the, see here, this is known as the internal water. Clear? Internal water. So see here, this is internal water. Complete jurisdiction of the sovereign state lies here. Now this is something that you should understand. After this, it becomes easy, because baseline identification is something that is very difficult for a person who is just reading this structure over here, or this photograph over here. So now, what do we see here? Once you identified the baseline, it is based on just adding the pointed edges and just making a line. This is known as a baseline. From here, you calculate the distance, whether it is 12 nautical miles or so and so forth. One which is inside this is the coast, and the water which is in the landward side, this is known as the internal water. Clear? Now let's see here. Baseline, it is the low water line along the coast as officially recognized by the coastal state. So this is the baseline, which is basically formed by adding or making an imaginary line through the projections of the coast. And this is known as a baseline, which is useful for further calculation of the territorial water and other features which you're going to study now. Internal water, the water on the landward side of the baseline. Landward side of the baseline, what do you mean by that? This is the baseline. Landward side is this. So this is what the internal water. Territorial sea. It extends seaward 12 nautical miles from the baseline. See here,
This is the baseline. 12 nautical miles from the baseline is the territorial sea. Somewhat like, supposingly this is what? This is 12 nautical miles. 12 nautical miles. Now this is what is the territorial sea. Territorial sea. Clear? Now comes the contiguous zone. It extends seaward up to 24 miles from the baseline. It does not provide air or space rights. That means the other countries cannot fly simply their aircrafts over here, or they have to take permission and they have to end before they enter this region also. So what is that? 24 miles. So let 12 miles is this, further 12 miles, that is 24 miles. This is what? This is the contiguous zone. Clear? Contiguous zone. Now comes exclusive economic zone. It extends from 200 nautical miles from the baseline. Now, if I want to extend this, please see this. From the baseline, this is 200 nautical miles. Right? This is what? 200 nautical miles. So this is the region is exclusive economic zone. Exclusive economic zone, but distance from the baseline is 200 nautical miles. So it does not give the coastal state the right to prohibit or limit freedom of navigation over flight. That means over this region, other commercial flights and commercial navigation can take place. It cannot restrict it. The sovereign state has right to carry out activities like energy. Over here, whichever country has the exclusive economic zone, it can carry out its energy exploration with an exclusive right of its own. Then you have the high sea. Now beyond this, beyond the exclusive economic zone, till here it is exclusive economic zone. Beyond this is the high sea. Now over here it is for everybody. Everybody can move here, explore whatever they want to do. So this is again the law of the sea. Now please remember, the very important concept that comes here is ecology, something that we keep on reading. But what ecology is? See here. Please remember, you can keep on noting it down. Ecology is basically defined as the scientific study of the relationships of the living organisms with each other and with the environment. First of all, remember, whenever the word logy comes behind anything, it is basically study. So it is a study of the, very important, scientific study of the relationship of the living organisms along with its environment. Now, living organism is interacting with each other, yes, along with its environment. Now, environment can have a lot of living as well as non-living components also. So it is a study of that, right? Now, it was coined by a very important person, Ernest Haeckel. Now, this question has been asked in the preliminary examination as well as UPSC and PCS examinations. Remember that in one of the statements. Ecology is, again, he gave this definition or gave this concept, in fact, in 1869, where when you see the word ecology, eco is derived from the word ecos, which means home or estate. Logy means study. So that means you are basically studying about the relationship and the interactions of the living organisms with the surrounding environment in a particular region. So that is why it is ecology. Ernest Haeckel. Clear? Okay, let's move ahead. Now, when we are talking about ecology, over here by default the concept of interaction between the biotic and abiotic component is irrelevant. As we told about the interaction between the living organisms and with the environment, so living and non-living interaction is also being considered here. Now please remember, over here I have very categorically mentioned certain important things. Levels of ecological interaction. Now when I talk about interaction, it can be at various levels, right from an individual or an organism to biosphere. So from an organism to the biosphere, you will realize that this is increasing in the sphere of what study you are doing. Let us see this. Let us see. First of all, when I take at the lowest level, it is organism. Now, organism can be seen as an individual living, a living entity. That is a basic unit of study. Now, when you go ahead further, the word population comes. Now, population includes certain set of individuals who belong to a same species who are able to breed. That is what population is. Always remember. It is a group of individuals. They are of the same species And along with it, they are capable of breeding. This is a very important characteristic. Whenever we say, let us say, a population of this or that, we are referring to a particular species of which population is being calculated or studied. So population is, whenever we use the word population, it is of a particular species. And if it is of a particular species, the members are able to breed and produce children. Next, above that comes concept of community. Now, the community is basically an assemblage or collection of population of different species that are interacting with each other, right? Now, it is quite possible. Let us take a particular region. Now, over there, you can have humans also, you can have animals also, you can have plants also. They're interacting with each other through various manners, depending on each other also for various resources and needs. So, that case, you will say it is a community. Next comes, this is with respect to environment, right? Ecosystem. Now, ecosystem is a functional unit of nature where the biotic and abiotic components interact through energy and nutrient cycles. So, we'll study this in detail also. It is a functional unit, very important, focusing on the biotic and abiotic interactions. And again, there is transfer and movement of energy and as well as the nutrients over here. Then comes the landscape. The landscape is a heterogeneous area. Heterogeneous area basically means that it is not something uniform. There is a lot of variation that are present. Composed of mosaic of interacting ecosystems. So over here, if you realize, this was ecosystem. Landscape has various ecosystems which are interacting with each other. That is what is landscape. When you come or talk about biome, which is above landscape, it is a large regional ecosystem with a specific climate and vegetation and fauna, like the tundra. We had studied about them in the climate. Similarly, with every climatic classification, you have a vegetation associated with it. So you have tundra, taiga, tropical rainforest region. So those are again can be categorized into the biomes. Why? Because they have a specific climate and they have a specific vegetation along with it, right? Then is the biosphere. It is a global sum of all the ecosystems that are present, right? All the ecosystems that are present. So that is the sum up of it. Now, this is again the various levels. You can be asked questions with respect to, let us say they'll ask population and they will say population means a group of people of different species staying together. No, it is community. So you should be well aware of the definition that I've written over here because this is something that is very often neglected by the candidates, and what happens is ultimately in the examination you suffer. So you should be very clear. You can please note it down also. As you move higher, the complexity is increasing because individual, simple, so many multiple things come, so the complexity increases as you move up, right? Okay, let's move ahead. Now let us understand, we've studied a little bit of ecology. Let us understand what is environment. Now when I talk about environment, environment is everything around an organism that affects its throughout its life. That means if I'm here, everything that is around me, living or non-living, that is impacting me is my environment, right? Whether it is your neighbor, whether it is a climate of that region also that is impacting you. So whether the certain vegetation that is around you is impacting you. So environment basically comes from the word or meaning that is surrounding. And something that is around you, whether it is living or non-living, that is impacting you is your environment. Now, when I talk about this, it includes all the living and non-living things also. So if I see, and the biotic means living. Plants, animals, bacteria, fungi, humans, microorganisms, everything over here are basically referring to the biotic components. Abiotic components, if you realize, sunlight, temperature, heat flow, water, air and atmospheric gases, soil, geological substratum and the landforms that are present here. All of these are part of the non-living component. So you are surrounded by all of these things, biotic or abiotic. Humans, your neighbors, that is also part of your environment. Does it happen that sometimes you are not in good terms with your neighbors? You often say that the environment of this colony has been spoiled because of certain neighbors being very obnoxious in nature or not so well mannered. What does that mean? Because again, you are interacting, you are one or the other way might be interacting with them or not interacting, but they're close to you. So that means they're also creating nuisance. So that is why environment from that perspective can also be seen, right? Ecosystem. Again, when we talk about ecosystem, see, an ecosystem is a functional unit of nature encompassing interaction between the biotic and abiotic components, right? It is a functional unit of nature that basically is encompassing or dealing with the interaction of the biotic and the abiotic components. Now, what are the biotic and abiotic components here? Abiotic components can be categorized into three categories.
Physical, that means the aspect related to temperature, humidity, light, atmospheric pressure. Inorganic aspect, water, oxygen, carbon dioxide and nitrogen. Organic, now this might have protein, carbohydrates and lipids. All of them are non-living, right? So over here, these are abiotic components. When I talk about the biotic components, you can have what the life forms that are present here. Let us assume producers in the form of green plants, grasses, trees and all. Consumers who are eating that, let us say various forms of animals, or let us say decomposers like the microorganisms, even let us say the fungi, the bacteria, the worms that are present here. Those can be categorized under the biotic components here. Clear? So we have the abiotic, we have the biotic components. Clear? Let's move ahead. Functions of the ecosystem. Now, whatever words I've mentioned over here is something that will be explained to you, right? Now, energy flow through food chain. Second is nutrient cycle, that is biogeochemical cycle, ecological succession and homeostasis. Please remember, every single word I'm going to explain, like energy flow is mentioned. So similarly, biogeochemical cycle, ecological succession, everything will be explained in the coming parts of this lecture. One thing that you need to know is homeostasis. Homeostasis basically means maintenance of balance. What do you mean by balance? Have you seen that when we talk about landform formations also, you realize that as an outcome of the endogenetic and exogenetic forces that take place? Why? Because it is a balance being maintained. You know that the earth is neither too hot nor too cool when on the surface. Why? Because again, the condition is such that the nature itself has managed in such a way that we are able to survive because of that. It has also got to do with luck that we are on this planet. But again, when we talk about heat budget also, you realize that there is a mechanism of the atmosphere along with the earth to maintain a balance of heat. Yes. So that is again what is known as homeostasis. Do you realize that there is a heat budget of the oceans also, which we had studied in the previous lecture? That is again same thing, again balance being maintained. So what happens is that homeostasis in a whole means balance being maintained, right, through various processes. Coming back, let us through energy flow and all these concepts, let us study now. Energy flow. Energy flow concept will be only complete when you have studied the concept of food chain, food web, the various pyramids of energy flow and all. Only then it will be clear. So let us see, the topic is energy flow. Now under which let us study the various concepts first of all. Whenever I talk about food chain, you know that this is a process of eating and being eaten. How? You know that very well, like there's a, let us say, there's certain grass at some place, right? A plant at certain place. You realize that possibly that grass is being eaten by a small animal. That small animal is being eaten by a bigger animal, and that animal is further eaten by a larger predator. Now, do you realize one is eating another, another is eating another, another is eating another, and there's a chain that is formed. Now, please understand there will be multiple chains that are linking here, but we are talking about just one chain. This is known as a food chain, because for this is a food, 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 right? So food chain is a transfer of food energy from the green plants that are producers who are producing it through a series of organisms with repeated eating and being eaten. This is known as food chain. Now I can represent it in the form of a triangle also like this. For example, at the base I can say, let us say, these are the producers, that is the grass. Then I can say there is grasshopper. Then I can say this is a frog. Then I can say this is a snake, and then I can say an eagle. So I can put it in this way also. This, do you realize this is various levels, 1, 2, 3, 4, 5. Similarly, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. These are trophic levels. So each step in the food chain is known as a trophic level. So you can represent it in this way also, same thing. And this whole is a food chain that is being represented over here. That is repeated eating and being eaten. Clear? Let's move ahead. Now this is something very important, a concept that I have written here. Please understand. Gross primary productivity and net primary productivity. I've written a formula also over here. I'll rewrite the formula also, don't worry. Let's see. This has been asked in the civil services examination also. And that is why I'm telling you the concepts that we are doing, those are basic concepts which are indirectly mentioned in the NCERT, and I've expanded them. So that whatever requirement that is left also with respect to the NCERT, you have covered it over here, right? So there's a concept of gross primary productivity. Now what happens is, It refers to the total rate at which the producers means a green plant over here because they're producing their own food, capture the solar energy and store it. So what is the rate over here? That the energy is being captured and is being stored by the plant. Now you know that the amount of energy that is being stored is not the total energy, because there will be certain energy which is being, let us say, which is being captured, is being stored, but out of that which is being stored, you know that some will be utilized for the basic metabolic activities or respiration activities of the plant also. So let us say a plant is being eaten by a person, or let us say an animal of the next trophic level. For him, the complete amount of energy that is being produced or captured by the plant will not be available, because some energy has already been utilized by the plant for its respiration. So what do we see? The remaining energy from the gross primary productivity which has been utilized for respiration. So what do we see? The net primary productivity is equal to gross primary productivity minus energy used for respiration, or slash you can put metabolism also. This is the net primary productivity. Clear? Okay. Let's move ahead. Food chain. We have done food chain. What is food chain? So let us see the types of food chain. The first one which I had given you the example is basically a representation of a grazing food chain. What does you mean by grazing food chain? From the grazing word, you should understand the word green plant. It is a type of food chain that begins with a green plant. It begins with a green plant as a primary producer, and after that it involves certain herbivores that consume as a primary consumer. So grazing food chain basically uses that the first stage is a green plant which is producing its own food, and later on it is being consumed by some other animal or various resources, and finally the culmination. So when it begins with a green plant, it is known as a grazing food chain, which you had already seen in this diagram also. This is a representation of a grazing food chain. Let's move ahead. Second is aquatic food chain. Whenever I talk about the aquatic food chain, it is, please remember, I'm not simply talking about oceans. It basically refers to a scenario where the process of eaten and being eaten is being carried out, but it is taking place in the aquatic environment. Now, aquatic environment over here does not mean only ocean and sea. It can include ponds also, it can include lakes also, it can include estuaries also. So those which are associated with water. So over here the energy and nutrients are transferred from an organism to another through feeding interactions in aquatic ecosystem. Over here, the aquatic ecosystem basically can be rivers, lakes, ponds, estuaries, oceans, and seas. Now, this is an example of a pond ecosystem where the primary producer is being algae over here, which is being eaten, which is being consumed by a small fish. The small fish is being consumed by a frog. Now, the frog is being consumed by a large fish, and the large fish by a heron. So, this is again what? An aquatic food chain. Clear? Let's move ahead. Detritus food chain. Now, this is something very interesting. Why it is interesting? Please see. When I talk about detritus food chain, please see. Detritus basically means that is related to something that is dead, right? So whenever I talk about dead organic matter, we are talking about the word detritus. It can be, let us say, an animal had died now, or let us say the dead leaves are lying on the floor. Now those can be categorized under detritus, or even the fecal remains of the animals can also be categorized under this. So it is known as decomposer food chain that begins with a dead organic matter such as leaf litter, fallen branches, dead animals, or fecal matter. So the interesting thing about this is that it begins with the dead material, and then it is being consumed by what? The worms, which make it further simplified. They get their nutrition from them. Then these beetle are consuming the worms, and the beetle is being consumed by the bird. So the beginning, if it is with a dead organic matter, then you are basically talking about a detritus food chain. Clear? Okay, let's move ahead. Now comes the food web. Now see, till now you have seen various food chains. Now the food chain is not an isolated event. There might be various food chains which are linked to each other. Now if let us assume, if I have mentioned here worm, it is not only being eaten by beetle, it might be eaten by some other organism also. So that means there will be various food chains which are linking each other. So these linking of the various food chains basically lead to a web-like structure which is known as a food web.
It refers to the complex network of feeding relationships among various organisms in an ecosystem depicting multiple interconnected food chains. Multiple interconnected food chains. Clear? So, what can I say in simple words? Linkage of the various food chains basically lead to a web-like structure which is known as a food web. Simple. Clear? Okay. Now comes the concept of ecological pyramid. Again, we are talking about the energy flow only. All these things are under that. See, in the previous topic when we were doing the food chain, I had very well told you that I could represent those food chains in the form of a pyramid also. Like producer, primary consumer, secondary consumer, tertiary consumer. So it depends upon what is the length of the food chain. Now, you will realize this that over here, I have converted that in this form of a triangle, right? Now, when I represent in the form of a triangle, we can associate it with like a pyramid-like structure, right? So see here, ecological pyramid is a trophic pyramid. Trophic means the various levels that are present over here. It is a geographical representation of the trophic structure and energy flow within an ecosystem. So within an ecosystem, who is eating what is being eaten, what is being consumed, how the energy is being transferred is being basically studied through this. Like it was being studied over here. So similarly, in this manner also we are studying it. It illustrates the distribution of biomes, energy and the number of organisms with the different trophic levels. So you will understand this that through these pyramids we will get to know at which level the number of organisms are more. What is the energy being transferred? As we move ahead in this particular topic, you will get to know about these things. So you get to know about the animals through the biomes also. If there is a particular biome, you know that these types of organisms will be present there, right? So a lot of information is conveyed through this. We'll study this. Now see, first is like I said, the number you mentioned. How do we get to know about the number? There's a concept under this is, first is pyramid of number. Pyramid of number. What is pyramid of number? Analyze. Now understand this. It is a graphical representation of the number of organisms at each trophic level. This is something very important. Number of organisms at each trophic level. Now, this is a pyramid again. I can make it in this way also, so there is no issue. I made it like this. In this is relatively very broad. So that means the number of organism, that means the number of phytoplanktons in numerical number or counting are much more than the large fish. Yes or no? If I am taking certain coastal ecosystem or region and I'm studying that, so do you realize when I'm studying that the number of phytoplanktons that are present, if I count them, are going to be much larger than the large fish that is present in that region? You will say yes. So over here, pyramid of number, we are counting the number of organisms at each trophic level. So over here, the phytoplankton number is very huge. So broad. If you go above, zooplankton, they are lesser in comparison to phytoplankton, so lesser number. Small fish, relatively lesser number. Large fish, even less. So you will see a pyramid which is in this form. You can see this also, and there can be an opposite direction also, which we will see. Just a representation I'm done. Now see here. When I'm saying pyramid of number basically represent at which trophic level how many number of organisms are present there, right? Now this can be of various types. First is the upright. Upright, in a way, this particular structure that I've explained you is an example of grassland ecosystem which we had just studied. Over here, the number of organisms decreases from the lower to the higher trophic level. So as you move in the higher trophic level, the number of organisms will decrease. So this is known as an upright pyramid. So pyramid of number can be upright and pyramid of number can be reverse also. Like this over here, see. Inverted pyramid. Now see, here the number of organisms increase as you move higher in the trophic level. As you move higher in the trophic level, the number of organisms will increase. Now see the example. There is an example of parasitic food chain. What happens is, over here the oak tree is a producer for them, and there are various birds over here which are consuming some aspects from the oak tree. Then there are lice and bugs that are present here, and then there are bacteria also feeding on them. So this is a concept which you realize that this is reverse in nature. Right from producer to this, you see the number of oak tree is going to be, let us say, 1, but there's so many birds on that, there's so many lice and bugs and much more number in bacteria. So as you move higher, you realize there is number is increasing. When you make the make a pyramid, it is like an inverted pyramid. Can you make it like this? Like, see, it is like an inverted pyramid. So we are seeing over here that a number of pyramid of number can be reverse also, depending upon the ecosystem. Third is irregular or spindle shaped. Now, irregular or spindle shaped means that it does not follow any rule with respect to whether it is completely reverse or upright. It can be of any shape. Now, see here. Here, the pyramid number may not follow strict pyramidal shape. Example, tree ecosystem. Let us see. Producer are the trees. Above that, you have the birds. You have certain animals like deers and all. Over there, you have wolves and then lion. Now, over here, you realize there are trees, are lesser in number, birds and all are more in number. Then you have wolves and then you have lions. So that means this is not a pyramid shape also. It is again like a spindle shaped or an irregular shape. So that means, what do you understand by this is that the pyramid of number can be upright, the pyramid of number can be reverse, the pyramid of number can be irregular shaped also. Irregular shape means that there is no specific shape. Clear? Okay, next. Pyramid of biomass. Now please remember, first was a pyramid of number where in the concept of number I was counting the number of organisms at each trophic level. Now over here I am going to weigh them. That is very, very important here. So pyramid of biomass is a graphical representation that shows a relationship between the biomes, that is biomass, that is the total dry weight of an organism at different trophic levels within an ecosystem. Now please remember, it is measured in grams per meter square. That means amount of weight per meter square. So you're basically measuring the weight, not the number here. So in this method, the individual is at each trophic level is weighed instead of being counted. Instead of being counted, it is being weighed. That is very, very important here. So types, you can have an upright pyramid also. Let us say the plants in a, let us say take a region over there. Let us say you have plants also, deer also, cheetah also. Now, if I take the biomass, that is the weight of the plants, total weight of the plants of that region, you will realize those total collection of the plants together will weigh much more than the cheetah. Because cheetahs are not going to be in large number, because we are not talking about the number, we are talking whatever the cheetahs present. So their weight is going to be lesser per meter square, but plants is going to be more, deer is going to be between them. So you will realize that over here the biomass is more, less and lesser. So it is an upright position also. It can be inverted also, like phytoplankton, zooplankton, small fish, large fish. The large fish, the biomass is larger. Phytoplankton, because they're already very less in weight, very negligible weight. So overall the biomass contribution is relatively less. So it will be inverted in nature. So pyramid of number can be again similarly as we have already discussed, pyramid of number can be inverted. It can be upright, it can be spindle shaped. The pyramid of biomass can also be upright and inverted, that is reversed. Now comes the third pyramid, which is pyramid of energy. Now, pyramid of energy is something that you should always remember. It is always upright. There is no other shape. It is always upright. Why? We'll understand that. See, it indicates how much energy is required in the next trophic level. How much energy is required in the next trophic level? You know that very well. See, for this concept to be understood, there is a law that you should be knowing. Only then you can understand that. There is a very popular law that is known as Lindemann's 10% law. What is the name? Lindemann's 10% law. Lindemann's 10% law basically states that only about 10% of the energy available at one trophic level is transferred to the next trophic level in an ecosystem. It means that you know that if there is certain amount of energy in this trophic level, it will be consumed by the upper trophic level, but the amount of energy that is transferred is only going to be 10% of the energy that is available here. That is why as you move up in the trophic level, you know that the energy will be becoming less, that less available energy will be there. So that is why it is always upright. Supposing it 100 units or 100% energy is here, you move ahead 10%, move ahead up 1%, up 0.1%. That is why please remember, you cannot have multiple layers or levels in a food chain, because over there then the amount of energy that is available in the top layer will become less and it will become unsustainable. This is one of the questions which has been asked in the prelims examination also. That was conceptual and you should be knowing it. Because the number of levels increase, the amount of energy that is reaching the top layer will be less as per the Lindemann's 10% law. That is why generally 4 to 5 layers are maximum that you generally study or see. Clear? Okay. Now comes the second point which we had studied in the functions. Biogeochemical cycle. Now this is again very, very important topic. And this is something that you should always be, it is very clearly mentioned in the NCERT also. So I have expanded that concept to study it even more in more detail. See, biogeochemical cycle. Over here, when we talk about biogeochemical cycle, it revolves around the movement and transformation of essential elements and compounds between the living organisms, environment, and the geological processes. Let's take an example. Let us take the example of carbon. Now you know that our body has carbon. You know that there are all the metals along with other lot of metals, there is a lot of carbon also present around me in form of so many compounds. You know that every living organism has carbon. You know that carbon compounds are present in the crust also. You know carbon is present in the landscapes also. Carbon is also present in the atmosphere in the form of carbon dioxide and other compounds also. Yes, carbon is dissolved in form present in the oceans also. And you realize that there is a transfer or movement that is continuously taking place among these various bodies or reservoirs. Reservoirs means a place where a certain element or mineral is stored. Like my body is also a reservoir of carbon. An ocean is also a reservoir. Atmosphere is also a reservoir. And from between these reservoirs, there is an interaction or changes taking place. How? Let us assume. Now, I am inhaling oxygen, but I'm exhaling carbon dioxide. So, from a reservoir that is my body, I am adding carbon dioxide to the atmosphere. Yes or no? Yes, I am. Now, there is a log of wood that is present here and I burn it. Now, carbon is in a stored format in that way in a wood. That is why it is also again a carbon sink. Now, when I burn it through the process of combustion, carbon monoxide, carbon dioxide gases will be released. That means from a reservoir of being a wood, it is being released into the atmosphere. So again, these processes are taking place. Now, please remember this. So these are the various phenomena what you study in the biogeochemical cycle, where the movement and transformation of these elements or compounds is taking place between living organisms, between the environment through the various geological processes. Clear? Now see, it involves circulation of elements such as carbon, nitrogen, phosphorus, sulfur, water through various reservoirs like atmosphere, oceans, soil, living organisms. Now, when I talk about biogeochemical cycle, it basically is an interconnectedness or a relationship between or among, let us say, biological, geological, and the various chemical processes involved in the cycle. Now, let us understand when I'm talking about biogeochemical cycle, there are a lot of components also, and what are the various cycles we are going to study? Let me show you that also first. We'll study the gaseous cycles, carbon, nitrogen, oxygen, and we'll study the sedimentary cycles also, phosphorus and sulfur. These are very important. The questions have been asked on them also, right? So we'll study them. Even the question was asked that which among the following are the sedimentary cycles? They had put carbon, nitrogen, oxygen, phosphorus and sulfur. So only phosphorus and sulfur were there. So this has been asked in multiple times in the PCS exams and even in the UPSC exam also. Okay. So let us see what are the components of a biogeographical cycle, biogeochemical cycle. Let's see. First is reservoir or pool. Reservoir or pool is a particular place where a particular element or compound is stored. As I said, my body is also a reservoir. An ocean is also a reservoir that is storing some element or a compound. Atmosphere is also a reservoir because it is storing some amount of element or compound, let us say carbon, nitrogen, whatever be the case. Even for that matter, vegetation also. So where there is stored for a good amount of time, then it is known as a reservoir. Pathways of fluxes, movement of elements or compounds between different reservoirs. As I said, a tree is there which is itself a storehouse of carbon. Now, if somebody cuts the tree and burns that tree, you are releasing that carbon compound in the air. So from one reservoir, that is of a tree or the vegetation, you are releasing it into another storehouse, that is the atmosphere. So you are making or exchanging taking place between two reservoirs, so that is known as a pathway. Exchange processes. The processes which facilitate the transfer of elements or compounds between reservoir. Let us say I had burned a wood. What is that? Combustion. Now the combustion is a process through which I have changed the one reservoir to another reservoir. So that is the process. Next is geochemical cycles. Now within this process you realize that various processes which you've already studied in the landscape formation also, weathering, erosion, sedimentation and all also play a very important role in changing the reservoirs from one place to another, also changing its form also. Last is anthropogenic influences. For example, I said burning of the wood, a simple example that is done intentionally by human being. So what human beings or what type of disturbances they are creating are also part of it. Let us say you have now a lot of vehicles. Earlier on, vehicles used to produce a lot of pollution. You are adding those pollution to the atmosphere. Now EV is coming. Now EV is reducing the pollution also. So what we are trying to understand is that human intervention also playing a very important role with respect to one reservoir to different other reservoir and the processes involved in between them. So these are the various components which you should be understanding and knowing. Now comes the next part, which is the types of the biogeochemical cycle. There are two categorizations. First is the gaseous cycle. Gaseous cycle has the carbon, nitrogen and oxygen cycle, and the sedimentary has phosphorus as well as the sulfur cycle. So let us study one by one. Please see here. First is a carbon cycle. Now please understand the introduction almost remains the same for everything, but what major important thing is when I talk about carbon cycle, it basically means how carbon is basically moving from one reservoir to another, right? That is the main thing. So carbon cycle is a complex biogeochemical process that involves the movement of carbon among the various reservoirs in the earth from atmosphere, biosphere and hydrosphere. So whatever is the concept, similar things are going to happen for the other cycles also, right? How nitrogen is moving or oxygen is moving. Let us see. I'd already mentioned what is a reservoir. I'd already mentioned what are the flow processes. So you don't need to explain that. So what is relevant in this particular dimension? See, when I talk about reservoir, atmosphere is also a reservoir. You've seen that. So it contains carbon dioxide and methane. Again, carbon, both of them. Terrestrial biosphere, plants, soil and organisms like we are also reservoirs. So we also store it. Ocean has dissolved carbon as well as carbon dioxide. Geosphere, carbon stored in rocks, sediments and fossils. So these are all what reservoirs for carbon. This can be asked in your papers also. Which among the following are basically representation of the reservoirs of carbon? Flow processes. Now if you see photosynthesis, now in which carbon dioxide is converted to organic carbon. Change of state or change of reservoir. This is in the plant, now this was in the air. Respiration, release of carbon dioxide into the atmosphere. Decomposition, breakdown of some, let us say, the dead organic matter and through which, let us say, carbon dioxide or carbon gases are released. Combustion, burning of the fossil fuel through which, let us say, gases of like carbon dioxide and carbon monoxide are also released. Weathering, this is a physical and chemical weathering of the rocks through which you know that there can be release of the stored carbon that is released from the rocks. So that is also again under the dimension of weathering, right? Now let's see. Exchanges. You've already seen the exchanges that are taking place among the various parts. Atmosphere, biosphere exchange. How is the atmosphere, biosphere exchange taking place? Through photosynthesis and respiration. Atmosphere, ocean exchange. How it is taking place? Through photosynthesis and ocean outgassing. Ocean outgassing basically means the release of gases from the ocean when it is saturated. Biosphere, geosphere is a exchange, decomposition and through nutrient cycling. Geosphere, atmosphere exchange through volcanic eruption or let us say carbonation also, this can happen. Next comes the nitrogen cycle. Now nitrogen cycle, exactly the same thing. How the transfer of nitrogen is taking place from one reservoir to the another, right? That's exactly the same thing. So let us see. Reservoir, atmosphere, 78% is of the atmosphere is again nitrogen. Soil, abundant nitrogen compounds are present in the soil. Living organism, essential for proteins and nucleic acid. You know that the basic building block of life is amino acid, and amino acid itself is has protein, and protein itself is composed of nitrogen. So nitrogen is very critical. Ocean, it has dissolved organic and inorganic nitrogen that is present. Now please remember this. There are certain points which I'm going to mention here. Please understand them very well. over here, these concepts which I'm going to explain to you, nitrogen fixation, nitrification, assimilation, ammonification, denitrification, all these concepts are very, very important for your examination, particularly your prelim examination. Because in the prelims, they will ask you, okay, which among the following, let us say, write a statement. They'll write a statement and they say which among the following is correct. Whether it is nitrogen fixation, whether it is nitrification, assimilation, all, and you'll get confused. So let us very categorically understand how this nitrogen is moving from the atmosphere to the soil, from dead organism to the soil, and then released in the atmosphere and all. So these are various processes. Let us see them. First, flow processes. What is nitrogen fixation? Please see, the nitrogen gas in the atmosphere is converted to ammonia or ammonium ion, NH4 positive, by nitrogen fixation bacteria, which possesses an enzyme which is known as nitrogenase, which basically helps it in this conversion. So what is the nitrogen fixation? Please understand, what is nitrogen fixation? Over here, the nitrogen that is available in the atmosphere is basically converted to ammonia or ammonium ion by the nitrogen fixation bacteria, which has a enzyme which is known as nitrogenase, which helps it to convert it. This is known as nitrogen fixation. Clear? Nitrogen fixation. First. Second thing that happens is nitrification. What is it? Nitrification. What is nitrification? The ammonium ion which was created in the previous phase, that is nitrogen fixation, that ammonium ion produced by the nitrogen fixation or released from the organic matter are converted to nitrate ion. So, important thing is that the ammonium ion over here is converted to nitrate ion through the oxidation reactions carried by the nitrifying bacteria. So, nitrification involves conversion of the ammonium ion to the nitrate ion. By what? The nitrifying bacteria. Third point, assimilation. Plants and other organisms take up the nitrate and ammonium ion from the soil or water and incorporate nitrogen into organic molecule like protein. So this is then observed, assimilated, observed by the plants and other organisms, and then used for its growth and development, right? This is how assimilation takes place. Clear? Now, next is ammonification. Now, this is again a reverse process is taking place. See. Organic nitrogen compounds like protein from dead plants. Now, if a plant, if let us say a dead plant or animal is there, so the reverse process will take place. Over here, the nitrogen compound, that is protein that is present in the dead plant or animal, is converted to ammonium ion by decomposer organisms like the bacteria and fungi. Now, please understand what is happening under ammonification. Now, supposing a plant is dead or a dead animal is there, it already has a lot of proteins. Nitrogen compounds are present. So, ammonification basically means that there is conversion of the protein into ammonium ions through the decomposer organisms like, let us say, bacteria and fungi. So again, this, please remember, when we were talking about the ammonium ions being present through the process of nitrogen fixation, we should also know that ammonification also provides nitrogen ion. Clear? But it is from the dead organisms. Last is denitrification. Now over here, what happens? This is again the reverse process of nitrogen fixation. It is a microbial process in which the nitrate is reduced to nitrogen gas or other gases like nitrogen oxide by denitrifying bacteria under anaerobic condition. So again, the reverse process is taking place. So this should be very, very clear to you, these processes. Keep it in mind very clearly and keep it in mind and remember it. Clear? Reduced to nitrogen gas. Obviously then escapes to the atmosphere. Exchanges, you see that soil and plant exchange is taking place. Plant animal exchange, atmosphere soil exchange. So we have already seen through these various processes, these exchanges are taking place. Next comes the oxygen cycle. We very well know that oxygen is present in our bodies. It is present in the atmosphere. It is present in the various landforms. It is present in the crust. It is present in as compounds in various through chemical reactions. It is present everywhere. So this conversion, or let us say from one reservoir to other reservoir, is taking place here also. Let us see here. Reservoir atmosphere has 21% approximately of the oxygen. Biosphere, it is essential for the biological molecule again. Hydrosphere, because it is a part of the water, right? Lithosphere, it is part of the crust also. These are all reservoirs. What are the flow processes? Again, photosynthesis, through which oxygen is basically added. Respiration, which is basically consuming oxygen and releasing carbon dioxide. Combustion basically involves the oxidation of the organic matter, which basically consumes oxygen because it happens in the presence of oxygen, right? Exchanges, again, atmosphere, biosphere exchange, hydrosphere, lithosphere exchange, and human activities takes place. Second last, these are now the first of the sedimentary cycle. This is not in the gaseous form as such. It is again present in the sediments and all, in various bodies also, but it is not a gas, right? So this is something that you should understand. Now, phosphorus. Now, please remember, when we talk about reservoir, soil, primary in minerals released via weathering and organic matter decomposition, crucial for plant growth. Soil is one of the basic, very important reservoirs of phosphorus. You know that very well in us also, ATP, adenosine triphosphate. Phosphorus again becomes very critical for the protein synthesis, growth of an organism, as well as the plants also. Aquatic, cycles between dissolved form and utilized by aquatic organisms and stored in the sediments, Biota means living organisms, incorporated in the biomolecule, essential for cellular functioning. Sedimentary rocks also, you will realize, stored as phosphate minerals released through geological processes. Clear? Okay, these are the reservoirs. Processes, weathering, phosphorus-rich rocks, minerals, and parent material, again through weathering, can be broken down. Absorption and uptake, plants absorb phosphorus directly from the soil in the solution form through their roots. Nutrient cycling, phosphorus cycles between biotic and abiotic components of the ecosystem through nutrient cycling paths, through like decomposition and mineralization, which you have just studied. Exchanges, soil-plant exchange and aquatic cycling. Sulfur, again, same thing goes for sulfur also, again it is sedimentary cycle. Let's see. Atmosphere contains sulfur components. You know that during the volcanic eruptions also, hydrogen sulfide is also released. So sulfur is again present through that form also. Sulfur dioxide is also present. So over here you realize that undergo chemical transformation and transport. Soil present in organic matter and minerals. Aquatic environment also it is present. Dissolved form. Biota, again, you know it is important for protein synthesis, energy metabolism also. Flow processes, volcanic eruptions release sulfur gases. Biological processes, if you realize, sulfate reduction, sulfate oxidation, and organic sulfur metabolism, it is required. Exchanges, atmospheric deposition, and sulfate uptake through plants and microorganisms can also take place. So these are some of the forms which you should have a brief idea about. You do not have to go into R&D. It was mentioned in the NCERT, so I've expanded that. Ecological succession, the next part which we had to study. Please understand something. When we talk about the next topic, this is ecological succession. Here we have now completed with the cycles, right? Now let us come to the next point, that is ecological succession. There are two scenarios in which we basically study this. Supposing there is a bare rock, nothing was there earlier, no vegetation was present there, bare rock is present. Slowly you realize that there are certain changes that take place, and you realize some, let us say, lichens basically come. Now lichens basically produce some chemicals also which help in the formation of soil. Then later on you see mosses are there, then you see grasses come, grasses after that you see some shrubs coming, then small trees and huge trees. So you realize that this is a sequential change of the vegetation that is taking place from a point where there was nothing. This is known as succession, but primary succession. If supposingly there is destruction of this type of forest and there is forest fire, and again there is succession taking place, but initially there was something present before, though it has been destroyed. When there is nothing, then it is primary succession, but there was something present in the form of vegetation, then again the start of the succession takes place, then it is known as the secondary succession. Please note it down. Clear? Now see. Let us read ecological succession. It refers to the gradual and predictable processes of change in the species composition and structure of an ecosystem over the time. So the species are changing, the structure is also changing over the time. They are primary and secondary. Let us see what is primary. You've already seen that it basically occurs in the areas where there was no soil or living organism. Over here in the primary succession, please understand, there is no soil or no living organism is present. And it is just the start. So over there, initially you realize that some species will be there, like in the forms of particularly the lichens. Those are known as the pioneer species because they are the first ones to come to that place and start with the process. So those are known as pioneer species. It begins with the colonization of like lichens and later on mosses that grow on the bare rocks. Over the time, lichens and all release certain chemicals which help in the formation of the soil also. Then you realize slowly some other form of life will also come up. Over the time, organic matter is accumulated and soil develops. More complex plants will come, like the grasses, shrubs establish, and in the later stages, eventually you'll have trees. Initially, shorter trees and later various other varieties of huge trees also present. Now, please remember, after this process is going on from one stage to another, there is a stage which reaches in which we say that this is a stage which is stable in condition or stable in nature. That stable condition or state which we study over here is something very important. Why? Because eventually a stable or diverse community is known as climax community. Climax community means that over here various species will be present, but they are in stable condition. Various plants are present, huge trees, few smaller trees, some other creepers that might be present. But this is a stabler condition now. Now this condition is known as a climax community. Clear? So this is primary succession. Secondary succession, please remember, is an outcome where certain thing or something was earlier present, which was later destroyed, let us say due to some disruptions like forest fire, floods or something. And later on you realize again that again the succession starts. So it occurs in the areas where soil and other vegetation remains intact after a disturbance such as forest fire and flood. So it is quite possible that some soil was already present, some vegetation or roots might already be present. So it is easier now for the succession to take place. It begins with the re-establishment. See, it is not establishment, it is re-establishment because earlier the vegetation was present, it was destroyed, and again the process is starting. So it is secondary succession, not the primary succession of the plants and animal communities in the areas which was previously inhabited. This is secondary succession. Okay, now let's move ahead. This is something very, very important here. Please understand. Two concepts which I'm explaining to you here. First is biodiversity, another is biogeography. Biodiversity refers to the vast variety of life found in a particular area encompassing the plants, animals, fungi and other microorganisms. If I take a region or area and see what type of vegetation or plants or animals or microorganisms are present, how diverse are they? That is basically a representation of the biodiversity, right? So what does it mean? The vast variety of life that is found in a particular area encompassing animals and plants, fungi, microorganisms is biodiversity. Now the question comes, and what is biogeography? Biogeography refers to, first of all, a study. It studies basically the distribution of the species and ecosystems across the geographical space and time. This is biogeography. Clear? Okay. Now let us see. When we talk about biodiversity, let's come to biodiversity. When we come to biodiversity, there are three types of biodiversity broadly that we study. One is genetic biodiversity, second is species diversity, and third is ecosystem diversity. Clear? Let us see this. Let us see them. Just quickly note this definition if you want. Quickly note it down. All those who want to note it down, please note it down. Okay, so please note it down also. See why. See, when I talk about biodiversity, let us see this diagram. Can you see these are like small, whatever species they are, like small mouse. Now there are different colors, little bit variation is there. Do you realize they are of a similar species but different variations are there within a species? This is what is genetic diversity. Let's see. When I talk about genetic diversity refers to the variations in genes within a species. Let us say I am Homo sapien, you are also Homo sapien.
there are Homo sapiens across the world, you realize there is certain variation in the genes that are present within the Homo sapiens also. So that is what is known as genetic diversity. With respect to, you will see, how do you see these diversities? Some are tall, some are short, some are intelligent, some are less intelligent. Some have a different shade of color, skin color. Some, you can analyze these through even the racial classification that is present. Mongoloids, Negroids, Caucasoids and all, we generally do when we study also. For general studies also, for optionals like geography and optionals like anthropology, we study them. So what are those? Those are basically a representation of the genetic diversity. That means what we say as phenotype, that is a representation of the genotype, that is the genetic composition, is being represented. So that means there is certain variation in the genes also. So this diversity is seen in different genetic compositions that individual pose and which leads to variations in appearance, behavior, and resilience. Next comes the concept of species diversity. Species diversity basically refers to, again, from the concept of genetic diversity, we have come to a broader aspect. It refers to a variety of species within a habitat or a region. Variety of species within a habitat or a particular region. These are of three types: alpha, beta, and gamma diversity. Let us see alpha diversity. Alpha diversity means the species diversity within a single ecosystem or community at a local scale. When we talk about beta diversity, it basically refers to diversity between two different communities or ecosystem. Gamma diversity refers to overall species diversity across multiple ecosystems within a large area. So this is again broader scale as we study, right? Third is ecosystem. Third is ecosystem diversity. It basically is representing or telling about the variations in the large diversity present in a region having various ecosystems. So if you realize there's a large region which has various ecosystems, let us say we can have ecosystem coastal, we can have estuarine, you can have desert, whatever. You can have so many ecosystems there. You will realize that this is a huge region which might have large number of ecosystems. So obviously the diversity is also going to be huge because various species are acclimatized and adapted themselves to each individual ecosystems. Clear? This is the ecosystem diversity. Let's move ahead. Patterns of biodiversity. Now let us see how the pattern of diversity is basically there, how the changes take place. This is a question which has been asked in the civil services also, so it's important. First is latitude. Now see, as one moves away from the equator, the biodiversity decreases. So that means that where there is extreme of temperature in the form of cold, you will realize that the biodiversity is less. So more biodiversity is present close to the equatorial region. So that is why as we move away from the equator, the biodiversity is going to decrease. Altitude. With increase in the altitude, you realize that harshness of the condition of the cold comes in, so the biodiversity will decrease. So with increase in altitude, the biodiversity will decrease. Size of the habitat, if I keep the other factors constant, whenever we are doing this, we are keeping other factors constant because actually in reality, various factors are acting together and the result is very different. So let us take one by one. So we have to keep other factors constant. Size of the habitat. So keeping other factors constant, if you realize the size of the greater the size of the habitat, that means more species can be accommodated there. So the greater the size or the larger the size of the habitat, it will basically means that more number of species can be present there. So greater diversity can be there. Clear? Next come seasons. Now please remember, is a very subjective topic. For me, an extreme cold is very problematic. But for some other animal who is very comfortable in the cold, it is not a problematic issue. Let us take, if you get the husky dogs which are actually adapted to cold environment, if I get a husky and put them near the equatorial region in some house, they might not survive even 1 week. Yes? So what do you mean? That means when we talk about the species, it is also depending upon the fact that certain climatic conditions are more favorable and others are not.
Overall, when we realize that the warmer season, we see that it is relatively more has a more diversity. So overall, it has to depend upon the favorable conditions. So favorable condition, there is greater diversity. Favorable conditions, more or less over here, means that when it is summertime, relatively more summertime, there is going to be greater diversity. Historical factors. Now, historical factors also can be multiple. Let us, for example, there is a volcanic eruption that has taken place thousands of years ago, and possibly the species that were present in that region have been destroyed. And though, let us assume, though it is near the equatorial region, though let us say the size of the habitat is larger, but because of the historical factor, the species are less. That can be a historical reason, something that has happened in the past. Second thing can be, let us say, colonization. Second thing can be, let us say, colonization. Now, example is like killing of bisons in North America by the Britishers. When the Britishers basically invaded or started capturing the regions, they not only butchered the Native Americans, they also butchered millions of bisons that were present there. For them, it was like a wilderness or a representation of backwardness. So they're starting killing those bisons. So in a way, they were responsible also for decreasing the indigenous species that were present there. So these are also what historical factors. Last is nature or isolation. Now see, isolation can be one of the reasons for new species being produced, that is known as speciation. But one more thing also should be understood, that it may decrease the genetic diversity also. Yes, because people are now isolated. You are not mating freely with other people. Now you're restricted. So there will be decrease in the genetic diversity during that time. So this is also very critical and important here. Let's move ahead. Functions of biodiversity as mentioned in the year NCERT also. First is ecological function. It helps in the ecological sustainability along with survival of the species. Ecosystem service, that means pollination activities taking place, climatic regulation and nutritional cycle, as we have already done in the biogeochemical cycles. Scientific aspect, research and education and reservoir of genes, because it is a storehouse of the gene pool, that means the genes that are present in a particular ecosystem. Last is, a very important is productive. Why? Because it is providing you with food supply, it is providing you with medicines, it is providing you with the raw material for the industries. So again, from the productive value, it is also very important. So these are the critical points which have been asked in the preliminary examinations repeatedly, right? Okay. Then coming to the next point is biodiversity hotspot. Now you will realize that, so what is this? Please remember, there are certain places which have been facing a lot of problems with respect to their biodiversity. Or let us say they have been, because of the nature, let's see, there are multiple factors that are involved in certain region being declared as a biodiversity hotspot. Like for example, we'll see the criteria. There are a lot of endemic species that are present, and let us say there has been a lot of intervention by the human beings which are destroying that region. So certain regions were very critical for the environment and biodiversity, and they're being harmed. So they are categorized as the biodiversity hotspots. See here, these are the regions of high level of species richness and endemism, that are endemic to that environment, as well as substantial human caused concerns. So along with this, why it is important is, there are richness also in the species, but along with that human beings are intervening in that environment. And that is why it is raising a concern. So what is the criteria for declaring any particular region as a biodiversity hotspot? See, a region must contain at least 1500 species of vascular plants as endemic to that particular region, accounting for more than 0.5% of the world's total. This is one. Second, must have lost at least 70% of the original habitat or retained only 30% or less of the original natural vegetation. So if these two conditions are being met, then you can declare a region as a hotspot, biodiversity hotspot. In India, you realize there are 4 regions over here you can map: the Western Ghats, the Himalayas, then you have the Indo-Burma and the Sundaland, a part of it. So these are again can be part of your biodiversity hotspots. What are the measures that are taken? Now please see, I am confining myself to the NCERT only, so I will be using certain content which is present in the Indian NCERT also, job part, as well as the old NCERT of physical geography and certain other parts. We are not going beyond that because we are doing NCERT. Little bit content has been added to that. Let us see what are the measures that have been taken to protect the biodiversity also. For example, the forest conservation. National Forest Policy 1952, it basically gives certain provisions, bringing 33% of the geographical area under the forest cover, maintaining environmental sustainability. We've already done this in physical geography of India also, so I'm repeating it again. because it is important for this chapter. Covering the natural heritage, biological diversity and gene pool, checking soil erosion, ensuring the forest cover, increasing productivity of the forest to make timber, fodder, fuel wood and food available, and creating massive people's movement so that they act like a force towards protection of the forest. This was the earlier policy 1952. Then you have the newer one, that is 1988. The objectives are environment sustainability, conservation of natural heritage, soil and water conservation, meeting the local needs, increase the forest and the tree cover, tribal and forest dwellers welfare. So please remember, it is not only talking about simply the forest, it is giving you a holistic development of a region. Holistic development basically over here means that it is talking not only about the forest, it is talking about how to sustain a region, how to bring about the welfare of the people who are located in that region. Like you have seen that they're mentioning about tribal and forest welfare and their welfare. So this is again very, very important. It is also talking about meeting the local needs. That means the voice of the local should also be adhered to and met. What are the key features and the provisions that are present with respect to this particular policy of 1988? It says first, emphasis on the joint forest management, JFM. That means the local communities to local community interaction, people interacting with the government over here as joint forces, and so that they can basically help in the protection of the forest. Maintain the forest cover at 33%, that means 60% of the hills and at least 20% in the plains. Diversion of forest land is restricted, but if there is diversion, then you need to have compensatory afforestation. Compensatory afforestation basically means that if you are cutting trees in certain region, you need to compensate that by planting forest or trees in some other region. This is known as compensatory afforestation, which is mentioned over here. Next is industrial needs. Now they're saying that the industries who needs the timber and the food, timber, or let us say the wood for their use, they need to have their own plantation of the trees and use that rather than cutting the forest. Next is wildlife conservation. Protection of the forest ecosystem and corridors are important for biodiversity. Clear? Now this is one question in front of you. I would request you to please answer them. Which forest policy first talked about the 33% cover as an important for sustainability? Forest policy of 1894, 1952, 1988, or the Forest Rights Act of 2006? This is question number 1. Please mention them in the comment section below. Social forestry also. These are also measures to protect the biodiversity. This is again mentioned in your NCERT. Social forestry means the management and protection of the forest. Need to manage and protect the forest along with the afforestation to plant more trees on barren land with a purpose of helping the environment, social and rural development. So overall, this is the social forestry. Now these are of 3 types. First is urban forestry, second is rural forestry, and third is a farm forestry. Rural forestry is further divided into subcategories. We'll see them also. Urban forestry, that means raising and management of the trees on the public land as well as the private land. See, public land as well as a private land, this can be asked. They can ask you that, okay, the urban forestry deals with planting only in the public land. You will say, yeah, that is fine. If they mention it can be used in private land, you will say, no, how can someone plant in the private land? It is mentioned here. So, you can plant, right? Owned land in and around the urban centers. Obviously, you have to take permission for that. You cannot go to someone's house and just force them to plant a tree. You cannot do that, but obviously with consensus. So, that means you can have the plantation taking place or planting of the trees taking place at the private property as well as a public land, right? This is urban forestry. Rural forestry, basically, it emphasizes on promotion of agroforestry and community forestry. What are these? We'll be seeing in the next slide, so don't worry. Farm forestry grows trees for the commercial and non-commercial purposes, right? Now let us come back. We have done urban forestry, we have done farm forestry, we have done rural forestry. Rural forestry has 2 types. First is agroforestry. It combines forestry with agriculture. And community forestry, it is raising of trees on public or community land. So this is again, that was basically mentioned in your NCERT, also very critical, very important for your examination with respect to biodiversity. Wildlife conservation, you know that Wildlife Conservation Act is 1972, which was amended in 1991, which was made further stringent. Serves as a primary legal framework for wildlife conservation and protection. Now, it provides 2 major objectives. This has also been asked in the examination. First is safeguarding the endangered species which are listed in the Act. And second, providing legal support to conservation areas of the country like national park, closed areas and the sanctuaries. These are two major objectives. Now you realize that this act was passed in 1972, but it was amended in 1991. Through these measures, basically the provisions have been made more stringent. The punishment has also been more stringent. So in order to make it make sure that the provisions of them are basically implemented on the ground level. Okay, let's move ahead. Biosphere Reserve. Now, Biosphere Reserve is a very unique and a representative ecosystem of terrestrial and coastal areas, which is institutionally recognized by a program of UNESCO, which is known as Man and Biosphere Program, which we have already done this also. Now, it has three objectives. First is conservation, that is conservation of the biodiversity in the ecosystem which is lying within the Biosphere Reserve. Second is logistics. That means it is basically an international effort of the various bodies that are associated with it. That means international network and more research and monitoring can be done. That means international collaboration. Over here, logistics means. Next is development. That means we need to associate and have a balanced development as well as protection and conservation. That is again development here. Now, if you see, there are three zones of the Biosphere Reserve. If a Biosphere Reserve is again divided into three zones, the inner is a core zone, which is a very protected zone. This is the most protected zone. Over here, free from human interference. And over here, you realize there are a lot of animals and plants which are endemic in nature are found here. When you move in the outer zone, outside the core zone, you have the buffer zone. This is a zone which is between the two zones. That is the middle zone. Its activities are managed in this area in such a way that it provides support to the core zone. That is why you realize over here some types of activities like tourism, research, fishing, grazing and all is to a certain extent allowed. When you move out, this is known as a transition zone. Over here again, this is the outermost zone, and over here most of the activities are allowed here. So this is like a transitional areas, transitional zones over here, so that this is the region which is most protected, right? So this is what is the Biosphere Reserve. These are some Biosphere Reserves of India that you should be aware of. Cold deserts in Himachal Pradesh, Nanda Devi, Uttarakhand, Kanchenjunga, Sikkim, Dihang Dibang, Andhra Pradesh, Devru Saikhowa, Assam, Manas, Assam, Nokrek, Meghalaya, Sundarban, West Bengal, Simlipai, Odisha, Achanakara, Amarkantak in Madhya Pradesh, Chhattisgarh, Seychelles in Andhra Pradesh, Great Nicobar, Gulf of Mannar. Then you have Agastyamalai, Kerala plus Tamil Nadu. Then you have Nilgiris in Tamil Nadu, Kerala and Karnataka, Panchmari in Madhya Pradesh, Rann of Kutch in Gujarat, and Panna in Madhya Pradesh. So these are the Biosphere Reserves that are found in India. So this was the chapter. Now please remember, we have come to the end of the physical geography series that we were doing. Hopefully you have enjoyed it. Hopefully you have covered a lot of things. We will be coming up with initiatives further to enhance the geographical acumen of you, further give you the best of the content, further give you all the weapons that are required to counter any question that comes in your prelims or the mains examination. If you like the lecture, you can let me know in the comment section, and that is also a means of our motivation. When you comment, you tell us whether it is something positive, whether it is constructive criticism, please let us know. It was a wonderful journey with you, and hopefully we'll be coming with such initiatives to further enhance your knowledge with respect to various other dimensions of geography and environment. Take care, and at last I would always say, Jai Hind.